Hello, best of luck. Best of luck. आर एस पाटील बोलतोय.
थँक्यू सरजी, थँक्यू.
ओके, ऑल द बेस्ट. चाल दे. Very pleasant good morning. Hello. 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 Very pleasant good morning. I, Professor Santosh Kumar Patil, IQSC coordinator, on behalf of on behalf of Satpura Shikshan Prasarak Mandal, Vasantrao Naik Art, Science and Commerce College, Shahada District, Nandurbar, Maharashtra, heartily welcome chief patrons, resource person, members of advisory committee, our honorable principal, organizing committee, and dear register participants on one-day international e-conference on ethical and quality aspects in nanoscience and nanotechnology research, that is Equinar 2020. Honorable dignitaries associated with this e-conference, as all of us we knew that the COVID-19 epidemic has made strong influence on all sectors of life in the lives of human beings. Consequently, higher education is also not untouched from the effects of COVID-19 epidemic. The higher education sector is going to face many challenges, many problems because of the COVID-19 epidemic. And it is our duty to cope and adjust with the situation. Taking this, our college, as the epidemic has prohibited us from manual meeting, therefore our college taking this an opportunity, consequently are continuously organizing various academic activities since last 2 months. Earlier, we have organized 3 days national workshop multidisciplinary on the quality aspects of research in science and humanities. Thereafter, our college has organized the 3 days national e-seminar on now, continuing with this motto and this aim, today our college is going to organize international e-conference, that is Equinar 2020. Our college is continuously trying to adjust with the COVID-19 situation, epidemic situation, and trying to best for the various stakeholders of education, that students, academicians, research students, and all other things. I, on this event of Equinar 2020, that is organized by Head Department of Physics, Vasantrao Naik Art, Science and Commerce College, in collaboration with KBC, NMU. I request the coordinator of this conference, Professor B.Y. Bagul, to make a brief introduction and preface of today's conference. We have number of
gallery of academicians
academicians
present for
present
this
for
conference. We have the chief patrons, Honorable Karmasakshi Nanasaheb Premchandji Javdar, founder president of Satpura Shikshan Prasarak Mandal Vidyawadi Dhule, Honorable Bhai Saheb Ashatai Premchandji Jadhav, Vice
Vice
President of
President,
Satpura
Satpura
Shikshan
Shikshan
Prasarak
Prasarak
Mandal
Mandal
Vidyawadi
Vidyavadi
Dhule,
Dhule,
Honorable Appa
Honorable
Saheb
Appa Saheb
Sujitji Jadhav,
Sujitji Jadhav,
Secretary
Secretary,
Satpura Shikshan
Satpura Shikshan
Prasarak Mandal
Prasarak
Vidyawadi
Mandal
Dhule,
Vidyavadi Dhule,
Honorable Bhaiya
Honorable
Saheb
Bhaiya Saheb, Divisional
Secretary.
Secretary.
We have the
Now the
blessing of
blessing of Honorable P.P. Patil, Vice Chancellor of KBC NME Jalgaon. We have Chief Patrons, Professor P.P. Maulekar, Pro VC, KBC NME Jalgaon. We have Chief Patron, Dr. Satish Deshpande, Joint Director of Higher Education, Jalgaon region, and so many academicians from India and from abroad. It's our grand pleasure to welcome all of you on this event of Equinar 2020. To make the preface of this e-conference, I request the coordinator of Equinar 2020, Professor B.Y. Bagul, Head Department of Physics, to make a brief preface of the conference Equinar 2020. Over to Professor B.Y. Bagul, sir.
Good morning and welcome to everyone who has been a part of this wonderful e-conference on ethical and quality aspect in nanoscience and nano research organized by Department of Physics, Vasantrao Naik, Arts, Commerce and Science College, Shahada, in collaboration with KBC NMU Jalgaon. I, Professor B.Y. Bagul, Head Department of Physics and convener of this conference, take this opportunity to welcome Sakshi Honorable Nana Sahib Premchandji Jadhav, Founder President, Satpura Shikshan Prasarak Mandal Dhule, Honorable Bharat Jyoti So Ashatai Premchandji Jadhav, President, Sonamai Shikshan Prasarak Mandal Dhule, Honorable Advocate Appa Sahib Sudhirji Premchandji Jadhav, Secretary SSPM Dhule, Honorable Professor Bhaya Sahib Sanjayji Premchandji Jadhav, Divisional Secretary SSPM Dhule, Honorable Sau Pratimatai S. Jadhav, Vice President Sonamai Shikshan Prasarak Mandal Dhule, Honorable Sau Varshatai S. Jadhav, Secretary Sonamai Shikshan Prasarak Mandal Dhule, Honorable Professor P.P. Patil, Vice Chancellor, Honorable Professor P.P. Mahulikar, Professor Pro Vice Chancellor, Honorable Professor B.V. Pawar, Registrar, KBC NMU Jalgaon, Honorable Dr. Satish M. Deshpande, Joint Director, Higher Education Jalgaon, keynote speakers, Professor S.T. Benre, BOS Chairman, School of Physical Sciences and CADP Chairman, invited resource persons, Research Professor, Brainful, invited scientist, Dr. Nisha G. Deshpande from South Korea, Dr. Rupesh G. S. Devan, IIT Indore, Dr. Umesh A. Shirsagar, IIT Indore, and Dr. Arindam Ghosh from JDC Memorial College, Bahal, Haryana. Honorable dignitaries and participants, nanoscience and nanotechnology have become one of the fast developing fields of research in the past few decades. It has multidisciplinary nature with tremendous potential to create new devices and materials with wide range of applications. Advanced nanomaterials comprise of electronic, optoelectronic, energy and functional materials are at the heart of many technological developments from space to terrestrial applications. Variety of processes has been developed to synthesize different types of advanced nanomaterials, increase computational powers, and our ability to model various phenomena at different length and time scales have made it possible to design and develop new nanomaterials and synthesis process. Equina 2020, the first internationally conference on ethical and quality aspects in nanoscience and nanotechnology research held by Vasantrao Naik Arts Science Commerce College, conference on ethical and quality aspects in nanoscience and nanotechnology research held by Vasantrao Naik Arts Commerce Science College. Shahada mainly aims to promote sharing of new knowledge and exchange of latest ideas in the fields of nanotechnology through deliberations in the conference. The conference would make an opportunity available to young researchers to develop their young research to discuss their ideas and views with the experts, scientists invited for the conference. The wholehearted dedication and devotion to science is the social service and in turn space service to work community. Modern world is facing various problems and hoping solutions from knowledge creators. Modern world is hoping of getting cheaper and sample amount of electricity from solar energy, eradication of disease like cancer and now pandemic COVID-19, water as fuel for vehicles and many more from nanotechnology. Department of Science and Technology of the nation is directly related to development of industry and economy. Stronger economy would eradicate the poverty. Teachers should innovate in active research and attract talented students towards the research in hardcore physics. Hardcore physics, science is the base of the technology. Physics is the mother of engineering and contribution of physics to develop modern world is uncommon and unmatched. Physicists have employed principles of physics and developed highly sophisticated instruments such as transmission electron microscope, scanning electron microscope, etc., and many more. All of them have been appreciated by conferring Nobel Prizes. Without the support of them, nanotechnology would not progress. This conference gives emphasis on synthesis and applications of advanced nanomaterials, also gives futuristic view of research to young researchers. The keynote address, invited resource persons, oral and poster presentations have been designed to represent the length and breadth of the field of nanotechnology. These presentations will demonstrate with specific emphasis on the young scientists and research students who have they express their enthusiasm and support to participation from country and abroad in a large numbers of abstract submissions which are vital importance to the conference. My heartfelt thanks to Honorable Professor P.P. Patil, Vice Chancellor, from his kind permission for collaboration of this conference. He conveyed this message. Best wishes for the success of this conference. I sincerely thank our chief guest, Honorable Professor P.P. Maulikar, Pro Vice Chancellor, and guest of honor, Honorable Dr. Satish M. Deshpande, Joint Director, Higher Education, Jalgaon, for kindly accepting our invitation and gracing the inaugural function. I am thankful to all invited resource persons for gracing the conference with their presence. We are extremely grateful kind cooperation, motivation, and timely guidance of the all management trustee of SSPM Dhule, the dynamic leadership of these dignitaries, their encouragement and excellent support has been a great strength for this conference. We hope that you have pleasant stay at home and will benefit professionally by participating in various deliberations of the conference. Thank you.
Thank you, Professor Bagul sir, for making a big brief preface of the conference. Dear participants and all the honorable dignitaries associated with the university. I request Professor P.P. Maulikar to inaugurate this e-conference with a message about and with best compliments and wishes to us. Professor P.P. Maulikar for the inaugural message and speech. Over to Professor P.P. Maulikar, sir.
Namaskar. Do you hear me? Patil sir, do you hear me? Hello.
Hello.
Do
Sir,
you
you
hear
are
me?
audible. Yes, you can continue. You are audible.
Okay. Namaskar. Good morning to all of you. I am very happy to be here on the occasion of one-day international conference on ethical and quality aspects in nanoscience and nanotechnology research, organized by Satpura Shikshan Prasar Mandal, Vasantrao Naik Arts, Commerce and Science College, Shahada, in collaboration with Kavitri Bhainabai Chaudhary, North Mass University, Jalgaon. First of all, I welcome all the organizing committee, the management of that college, principal and his team, all resource persons, principals, professors, faculties from various places, and all delegates or participants who have been participated in this one-day international conference. Dear friends, we all are aware about the COVID-19 attack or crisis since last 4-5 months. The corona attack, which was firstly identified in China, then it was spread in world more than 220 countries. And on 11th March 2020, World Health Organization declared it as a pandemic crisis. Accordingly, in India, our Honorable Prime Minister Narendra Ji Modi, as well as in our state of Maharashtra, Honorable Chief Minister Uddhav Ji Thackeray have declared a lockdown on 23rd March 2020. After declaration of this lockdown, our academic has been totally disturbed and our teaching learning process has been totally stopped. Meanwhile, on one side we are facing problem of COVID-19 crisis, and on other side all colleges and the universities have organized the e-conferences, seminars, webinars, workshops, even faculty development programs also have been organized by a number of colleges. Means we have grabbed that opportunity to continue our all educational activities through this internet system using this learning management system, LMS and IT tools. Today, Vasantrao Naik Arts, Commerce, Science College has organized this one-day international e-conference on a good theme, that is ethical and quality aspects in research. Though this title is in nanoscience and nanotechnology, but it is a common theme for all disciplines and subjects. And nowadays it has gained the most importance and significance in the contest at national and international level. In order to maintain ethical and quality aspects, now UGC has also introduced one course for research student who have been registered for PhD. That is a course work number 4. Already there are 3 courses. First is the research methodology, second is the subject course, third is the guide course. And from this year, UGC has introduced fourth course for 30 hours. That is research and publication ethics. So, as I said, college has selected a good theme for this conference, which is the must that every research student should know the ethical and quality aspects of research. As the fourth course has been made compulsory by UGC, now it is expected that the research quality at college, university and institute level should be enhanced. Just our university has published a guide list. In guide list, I think number of research guides have been seen, might have been seen that list. The number of guides for physics are 72 and electrons only 15 in our jurisdiction of KBC and MU Jalgaon. That number is very low, electronics. If you see the changing world, and now because of COVID-19 attack, no one can predict about future changes, what is the expected changes in educational systems, in industries. It is very difficult to predict that all things or the future scenario. And one more thing that is very clear that the coming industry will be at fourth phase, that is industry 4.0 phase. Accordingly, we have to increase the teaching learning process, means our education at fourth phase also. And in that, we are expecting the number of tools instead of the manual work in all kinds of industries, and total base for all these changes will be the physics and electronics, especially electronics. So whatever we are expecting, that is internet of things, then big data, then artificial intelligence, all these are actually require the fundamental aspect, that is electronics. So in my opinion, as in our university, the guide supervisors in electronics, it is only 15. Now we should encourage more and more faculty members, teachers from all colleges to complete their PhD work and to become the research guide as early as possible. The theme of this conference covers number of topics, nanoelectronics, magnetics and all. Among all these, for coming future applications, optoelectronic material, solar cell material, and photocatalytic material, these topics will be highly important. So with this, among this number of subjects that to be discussed in this conference under this theme selected by this college, so it is expected that the more and more awareness should be created on renewable energy sources for better future without any environmental problem or pollution that we are facing since last 3-4 decades. The resource persons who have been invited by college are very renowned persons. Nishad Deshpande from South Korea University, and Umesh Kirsagas, Rupesh Devan from IITs, Arvind Ghosh from Haryana, and from our university, other university and institutes also. Definitely all these resource persons will enlighten all participants on the various aspects according to relevant to the theme of this conference. And definitely this conference will be highly beneficial to all participants to gain the knowledge according to the need of time and future requirement. So with this brief, I congratulate the team of college. First of all, the management of this college, Nana Sahib Premchandji Jadhav, then President Honorable Ashatai Jadhav, Honorable Bhaiya Sahib Sanjay Jadhav. With their moral and inspiring support, the college has organized this one-day international conference on ethical and quality aspects in a research theme. Equally, I congratulate the secretaries and vice presidents of this college, that Satpura Shikshan Prasarak Mandal Dhule. I congratulate Principal Dr. A.N. Patil and his colleagues, convener Professor B.R. Babu, who is heading physics department in this college, co-convener, IPSC coordinator Dr. Esham Patil, other organizing committee members and staff of this college for organizing this nice event in their college. Equally, I congratulate Dr. Satish Deshpande, Joint Director of Higher Education in Jalgaon, who has also been participated in this conference. I congratulate all participants who have been joined this one-day international conference organized by this college. And with this brief, once again I congratulate one and all from this college, and I wish all the best for all participants for their bright future and the successful career. So thank you very much. And with this brief, I declare here that the one-day international conference on ethical and quality aspects in nanoscience and nanotechnology research has been inaugurated, and now it is open for deliberation and discussion to all participants and delegates. So thank you very much.
Hello. Thank you, sir, for making the inauguration of this international e-conference and giving us some of the message to conduct and to maintain ethical and quality aspects in research. Basically, research is the basis of higher education, and no research is possible without following ethics and quality. Our sincere attempt is to touch the subject and to bring out the many various facets of quality aspects and ethical aspects in the nanotechnology and nanoscience research. In present day, nanotechnology and nanoscience is an emerging field in science. It will help human in the lives of human being from all angles. Therefore, this conference is a sincere attempt to bring out various folds of the quality and ethical aspects in the field of nanoscience and nanotechnology. Thank you, sir, making the inauguration of this conference. As we know, this is a formal inauguration. Your blessing is always with us. Similarly, for this conference, we have the blessing, compliments, and good wishes of so many academicians, resource persons, and renowned persons. Among those galaxy of the academicians, administrators, we have one of the best wishes from Dr. Satish M. Deshpande, Joint Director of Higher Education. He has given us complimented, and his best wishes have motivated us. Now, I request Professor Dr. Satish Deshpande, Honorable Joint Director, Higher Education, Jalgaon Region, to give us and best wishes for this conference and to boost our morale and our energy. Over to Professor Dr. Satish M. Deshpande, Joint Director, Higher Education, Jalgaon Region.
Thank you, sir. On the occasion of one-day international e-conference on ethical and quality aspects in nanoscience and nanotechnology research, I welcome you all. On the occasion of this, the Secretary of Satpura Shikshan Prasarak Mandas, Honorable Bhaiya Sahib Sanjay Ji Jadhav sir, the Principal of Vasantrao Naik Arts, Commerce and Science College, Shahada, Dr. A.N. Patil sir, Convener Bagul sir, Co-Convener S.M. Patil sir, all organizing committee members, the participant, principal, professors, associate professor, teachers of all colleges as well as from India and abroad. From the 23rd March, we are facing the COVID-19 pandemic situation. And in this situation, government of Maharashtra as well as university authorities in academic field, we are stressing online platforms and stressing on the online courses as well as the online things. And definitely today, as considered to the all this situation, the college has organized the one-day international conference. So I congratulate Dr. N. Patil sir and his team as well as the all authorities. Now we know that is the nanoscience and nanotechnology is a multi-beneficial branch of science and it has a use in a multi-dimensional way. So as concerned to this e-conference, the topic chosen by the college, definitely it has a wide use. And the resource persons like Dr. Bendre sir, Dr. Nishad Deshpande, Dr. Rupesh Diwan, Dr. Umesh Chirsagar, Dr. Arvindam Ghosh, definitely that they are related with the all topics, means that is the biosensors as well as the solar materials. These are the very useful topics of today's of need of our. So definitely the knowledge shared by the all resource person is highly beneficial to the researchers who are carry out the research in this field. The university authorities like Professor P.P. Maulikar sir has already stressed on this one. We are facing the crisis, but we have to means think about the online things. So definitely the e-conferences, webinars, as well as the workshops, they definitely boom up our academicians on online things. Definitely all these things and as well as those participants, definitely they will get the wholeheartedly knowledge of all these themes. I hope that the knowledge shared by the all resource persons in the today's e-webinar, e-conference definitely help to carry out the ethics as well as the quality aspect of research. We know that the research in the research field, as concerned to the academicians research, always we think on the quality and how it will be converted into the applicability as well as the employability as well as the entrepreneurship. So definitely the knowledge given by these all resource persons, by all participants will take help of them and as well as in future they carry out the good research. Finally, I wish a grand success of this international one-day conference. Thanks one and all.
Thank you, sir. Thank you very much. On behalf of the organizing committee, I assure that the expectations from you from this conference will definitely get fulfilled at the end of the conference. Your support and kind wishes will definitely boost our morale to conduct and more such academic activities in coming days. Thank you, sir. Thank you once again. Now that we have another best wishes from the management trustee of Satpura Shikshan Prasarak Mandal Vidyawadi Dhule, without whose kind support, moral guidance, this event could not have been possible. The college has the best wishes for these conferences from Honorable Bhaiya Sahib Sanjay Ji Jadhav, Divisional Secretary of Satpura Shikshan Prasarak Mandal Dhule. It's my grand pleasure and it's our grand pleasure that he himself is a part and parcel of higher education and working as a professor in the Department of Science Zoology. Therefore, His timely motivation and guidance always prompt us, motivate us to conduct more and more such academic activities. This today's conference is also one of the result of his thinking and of his aim. Now, I request Professor Bhaiya Sahibji Sanjay Ji Jadhav, Divisional Secretary of Satpura Shikshan Prasarak Mandal Vidyawadi Dhule, for his best wishes for this e-conference. Over to Professor Bhaiya Sahib Jadhav.
Hello.
Yes, Bhaiya Sahib, you are
Hello.
audible.
I am audible.
Yes, you are audible.
Thank you. Thank you. Thank you. Now it is the time for excellent and outstanding performance in international conference on ethical and quality aspects in nanoscience and nanotechnology research. It is the very nice theme that definitely gives the new vision and new ideas to our viewers. So first of all, on occasion of the inauguration, I salute Honorable President of Vasantrao Naik College, Shahada, Honorable Karma Sakshi Nanasaheb Premchandji Jadhav, Vice President Honorable I Saheb Jadhav, and Honorable respected Ismail Chacha, and our respected Secretary Honorable Appa Saheb Advocate Sudhir Kumar Jadhav. Recently, our college has been successfully organized 3 consecutive online program. That is, first attempt was 3-day national workshop. Second was 3-day e-seminar. And today is international conference. For arranging such a successful online program, I congratulate our organization team, Principal Dr. N. Patil, Convener Professor B.Y. Bagul and Dr. R.B. Marathe, Co-convener Dr. S.M. Patil, and technical support Professor Ishi and Professor R.P. Patil. I am very thankful to our intellectual and expert research person, Dr. Shirsagar and Dr. Devan from Indian Institute of Technology, Indore, Dr. Ghosh from Haryana, and Dr. Deshpande from South Korea for giving the valuable time for our conference. I am also grateful to KBC North Maharashtra University, Jalgaon, for collaboration with our college, especially Vice Chancellor Dr. P.P. Patil sir, Honorable Dr. P.P. Patil sir, Honorable Pro Vice Chancellor Dr. P.P. Mahulikar sir, Honorable Registrar Dr. B.V. Pawar sir, and our Chief Patron, Honorable Joint Director Dr. Satish Deshpande ji, for their encouragement and guidance during the inauguration. I am very thankful to participants for their participation with prompt submission of abstract. Finally, I wish good luck To all of you, thank you very much.
Thank you, Bhaiya Sahib. Thank you, Bhaiya Sahib, for your best wishes. I assure that your expectations from this e-conference will humbly and hardly try to get completed or fulfill it. Now, this e-conference, today's e-conference is an outcome of the constant motivation of our principal. Our principal is our real motivator and inspiration, who continuously encourages us to conduct such and such more academic activities for the various stakeholders of higher education, ranging from student, parents, researchers, teachers, and so many on. Today's International Year Conference is one of the micro and sincere attempt regarding that. Now I request the president of today's inaugural function, Professor Dr. A.N. Patil sir, for the presidential speech. So over to Professor Dr. A.N. Patil sir for a brief presidential speech.
Very good morning. I, Principal Dr. A.N. Patil, Vasantrao Naik College, Shahada. All online honorable dignitaries, delegates, honorable patrons, academicians associated with this conference. It is honor to welcome you. I am thankful for inauguration, Professor P. Maulikar, Vice Chancellor, KBC NMU, and Honorable Joint Director, Desh Pandey Sahib, the Jalgaon region. It gives me immense pleasure to introduce this one-day international conference on physics on the topic nanoscience and nanotechnology, jointly organized by KBC NMU and VN College Shahada. COVID-19 epidemic has made strong influence on all sectors of life. All sectors, higher education system is also going to change. The workshop, the conference mainly aim to bring out such changes and the need to adopt various advanced techniques. About my college established in 1993, 2 cycles completed of NAC, now in 3rd cycle. Our management and our inspiration, President Karmasakshi Nana Sahib, has been awarded with Banjara of Century and many more. SSPM having 18 branches spread in Dhule and are working independently. About 6,000 students are learning in my campus from KG to PG. College management is very keen to inspire the staff and encourage the development of college. Also improve the performance and uplift the students' activities. Sanstha made available 3 acres playground for sports, skill and fitness activities. College area spread in 8 acres with buildings and greenery in the heart of the city. College becomes under 2F and 12B Act, also received development grant from UGC for faculty development and permanently affiliated to North Maharashtra University. College provided all types of scholarships to students. College organized all research activities, workshops, etc. I proudly say that my college 80% staff awarded by PhD in different subjects, and they are updated in research activity, learning activities. Thank you again to Professor Maulikar sir for inauguration. Thank you. Thank you.
Thank you, Principal Dr. A.N. Patil sir. Thank you very much for the presidential speech. Now, for today's e-conference, we have a very renowned person as a keynote addressee. He is serving in KBC North Maharashtra University, Jalgaon as a senior professor. Dr. S.T. Bendre is a chief keynote addressee for the today's e-conference. Now, I request the convener of this e-conference, Professor B.Y. Bagul sir, to make the brief introduction of the Dr. S.T. Bendre sir, who is going to deliver the main keynote address of today's e-conference related with the subject. So over to Professor B.Y. Bagul sir for the brief introduction of Professor S.T. Bendre.
I express my sincere vote of thanks for making the inauguration of the conference of all honorable dignitaries who have associated with this conference. Now, dear participants, as per the schedule of this conference, international conference, we are moving to technical sessions. Among that, in the first technical session, Dr. Nishaji Deshpande is going to deliver a lecture on the topic, what makes nanomaterials important. Dr. Nishaji Deshpande.
Hello.
Hello, sir.
Can you hear me, sir?
Yeah, sir. Yeah.
Okay.
Sir,
Possibly
sir,
you can. Yeah.
Sir, just a minute. Now we introduce, I take opportunity to welcome and introduce one of the eminent personalities, research professor, brain full invited scientist, Dr. Nishaji Deshpande from Department of Sungsong University, Suwon, South Korea. He has completed MS for doctoral degree in 2020, 10, and PhD in 2011 from Hanhang University, Seoul, South Korea. From 2011 to 12, he is postdoctoral researcher, Hanhang University, Seoul, South Korea. From 2012 to 13, he is postdoctoral researcher, Institute of Atomic and Molecular Sciences, Academia Sinia, Taiwan. From 2013 2018, he is the DST Inspires Faculty, Department of Physics, Shivaji University, Kolhapur. And till 2018, till date, he is research professor in Advanced Material Science and Engineering Department of Sanyong University, Suwon, South Korea. His research interests area in fields nanomagnetism, spintronics, magnetocalories, solar water splitting for sustainable energy, photocatalysis for water waste treatment, and gas sensor for environmental monitoring. He received number of honors and awards, 3 Best Poster Award and 1 Excellent Post Paper Award from countries like India, Korea, and Taiwan. Recipients of Brain Korea 21 Scholar Fellowship Award 2008. In 2013, DST Inspire Faculty Award, Department of Science and Technology, Government of India. In 2018, Young Research Associate Fellow, Department of Academy of Sciences, Pune University in Maharashtra. In 2018, Brainful Invited Scientist, National Research Foundation, Government of Korea. Apart from this, he has published number of papers, 71 papers in international journals, 1 paper in international journals, books 1, book in chapter 1, others 5. Projects, 3 major projects completed, total cost of 44 lakhs, funded by DST, Government of India, UGC, DAE, CSR, Indore and Mumbai centers. Now, I request Professor Dr. Nishaji Deshpande to enlighten on topic what makes nanomaterials important. Yeah. Dr. Nishaji Deshpande, sir.
Okay, thank you, sir.
Okay.
So firstly, can you hear me?
Hear me? Yeah, sir. Yeah. You can audible, sir. Oh.
Okay. So can you see my slides?
Yeah, sir. Yeah. I saw that.
Okay. So now you can see my slides also, right?
Okay, sir.
Hello.
Hi, yeah, sir. Okay, sir. Okay. Audible and visible also, sir. Okay.
Okay. Thank you very much, sir. Okay, so firstly, I'd like to congratulate you all people for organizing this very nice conference, virtual conference, because this is the need of time now that we should get connected through virtual conferences and social networkings. So maintaining the social distances as well as maintaining all other aspects and trying to connect through and share our knowledge is very important these days. Since I am also giving lectures here at Sungkwon University at Advanced Material Science Engineering, so these universities have also adopted similar kind of techniques like introducing ICTs as well as introducing online lectures and making virtual classrooms. So I think this is one of the important need now in the COVID crisis. So I would like to congratulate all the organizers and really look forward for a very nice virtual conference today. With this small introduction, I would like to come to my topic today. So basically, I'm trying to introduce a very large area, like what makes nanomaterials important. So this is very large. So I'll try to be more brief now and try to come to the main aspects of this. In this particular lecture, okay, so in this particular lecture, I would like to cover about the materials, for what these materials are being used, why they are being used, for what purposes they are being used. Secondly, we would like to see, like on the length scale, how these materials will behave, some synthesis aspects of this material, like how we can fabricate, synthesize these materials, what is important about these nanomaterials, and do really surfaces and interfaces have any importance in these nanomaterials? what is the easiest way to effectively analyze these nanomaterials in sense of quality and in sense of quantity, as well as to understand the surfaces and interface qualities. Lastly, I would like to cover a small aspects of application in which I will also introduce you with what we are also doing currently, and how these nanomaterials are effective in planning some different kinds of applications. And with this, I would like to comment on the summary. So here you can see like there are different kinds of materials, mostly like metal, ceramics, polymers. You can see that metals have their own properties, intrinsic properties, like they are good conductors, have lustrous appearance, susceptible to corrosions. They are strong and deformables. So you can utilize this kind of metals in various applications, like making electric wires, connecting wires, as well as using in fans for aircrafts and all. On the other hand, if you see about the ceramics and glasses, then you can understand that they are thermally and electrically insulating in nature. So usually when you are making some connectors, you require some dielectrics to be coated onto it, so that these dielectric losses can be eliminated. Accordingly, you can have similar kinds of so many kinds of materials wherein these ceramics can play a very vital role. Not only that, they are very resistant to hard temperatures and harsh environments, and they are hard and brittle as well. Coming back to polymers, you can see like these polymers are all large molecules, although they are low density. e- Uh, yeah, although they are in low density, but mostly they are flexible in nature. So you can make various kinds of devices, applications from these polymers also. So what these materials are, for what we are going to use these materials. So now we are talking about ethics and research, quality research in nanomaterials. So first question comes in our mind is like what these materials are and for what we are going to use these materials. uh, the important aspect for a student also, if like whenever I started my research, I had this question in mind, like what are these materials, why are we going to study these materials, and what will be its output exactly. So most importantly, scientists, academicians, or engineers, they are trying to understand or make choices of these materials for a particular output or a particular applications. So selection of materials becomes an utmost important part of our research. So first important thing is like how you are going to select a material. Firstly, you're going to see its performance. Secondly, you're going to understand the deterioration properties of these materials. And lastly, how this economical is material. So if I'm going to commercialize any kind of applications, the first and foremost important point for me is to understand like what material I should choose. Just arbitrarily choosing any material and just going on doing some research and trying to go for some applications. At the last end, what I see is this material is useless to me now. So this means my whole research is gone. So that means first point or first priority should be about how we are going to choose our materials. Accordingly, if you can see that I have just shown some simple examples. Now you already know this is Coca-Cola, which is using different kinds of bottlings. Like they are using aluminum materials for bottling, glass for bottling, plastic for bottling. Now, why they are doing this? So first thing, if you try to understand these materials, then its important point is like how to make this commercialize, how to utilize these properties of these materials for say temperatures, for say environmental aspects, and so economics also becomes one of the important points in our research activities. So coming to these material studies, when I'm trying to understand these materials, I need to understand many of the aspects of these materials. So if you can see here that the first aspect remains is like what kind of structures these materials have. Second aspect remains is how this processing is possible using these materials. And the last aspect comes is the properties. And overall, when I see, what remains is the importance of performance. So I want to understand now structures. So actually I will try to understand the bulk properties, the macroscopic properties, the microscopic properties. Then I will try to understand the arrangement of internal components of these materials. Secondly, when I understand all these structures and all these properties as an initial prior art studies, I'll try to understand it's how I am going to fabricate these materials now. So this also becomes one of the important aspects for me. So not just someone is doing ALDs, like atomic layer depositions. Someone is doing like chemical vapor depositions. I will also go and try to do the same thing. No, this is not actually what the research ethics or the research importance is. So the importance of research lies in how economical, how easily, and how simple way I can fabricate these materials. So that's what becomes the pure or the basic aspects of trying to understand the structures, trying to utilize the fabrication methods. And then lastly comes is how you are going to understand the properties. Whatever you have deposited, whatever you have fabricated, you need to understand how this material is formed. So accordingly, this material characteristics, the response to the simulations, like mostly if I am talking about computer simulations, or like if I am talking about external stimulus, let's say like mechanical, electrical, thermal, magnetic, optical. So how these all aspects are going to affect the properties of my material. This becomes one of the biggest aspects of my study, and we want to understand the relations between these materials and its properties. Lastly, all these are connected to each other. So one important point is, when I know all these structures, I understand the performance now. So what particular performance I am expecting from these materials is becomes a very important thing for me now. So lastly, like when we know all these four pillars of this research, wherein we can understand pure state art, we try to understand the structures of these materials, we try to know the processing of these materials, we try to understand the performance of these materials and then properties of these materials. So what remains is how we are going to scale down now, or how we are going to scale up the materials. So already we all are working in bulks, we know everything in bulks. Slowly the technology requires or the requirement of this technology is how we are going to microscopically make these materials. Almost like now for a decades we are trying to move into the length scales of nanometer scales. So here you can see that this length scales almost like zero point 0.2 to 100 nanometers we are moving. So why we are moving into these length scales is the importance that we are trying to miniaturize all the devices. Earlier, like if you see, our computer is almost a room dimensions, but now a computer is very small on your hand, palm hands, you can see. So Samsung here has developed a small computer which is almost like dimensions of your mobile. So these computers are now miniaturized, so that's why the length scale is been changing to nanometer scales. And now the atoms, nanoclusters, nanostructures are becoming more important uh, to study. So oh, accordingly, like we need to understand now this, like how this nanometer like synthesis can be done or fabrications can be done. Two are the important aspects I have shown here. One is the top down approach, the second one is the bottom up approach. So if I try to see a bulk, and now I try to break down this bulk into small pieces, like these small shape squares I have shown. So what I can go is I can cut down this bulk slowly in parts, and I can come to actually the dimensions of nanometers. So accordingly, from top to bottom, I can go and make such certain kinds of nanostructures like nanorods, nanopyramids, nanoparticles, nanoneedles, or any other aspects or shapes of nano particles. What are these different top-down approaches? One is the ball milling, a very well-known technique. Chemical techniques involves like thermal ablations, laser beams also are used in physical methods, explosion processes. Lithographies are now quite commonly used to make IC circuits using these small particles or small nanostructures. Considering the bottom-up approach, now the same thing, the same small nano dimensions, if I go on putting one another up, so what I can see is I can connect the atom to atom. So one atom connected to another atom, and slowly you can form an atomic layer here. So one atom is connecting to the other, the third, and you can form a layer here. Secondly, if the same layer I grow on the first layer, what I see is I am trying to build up a two-dimensional layers now. So slowly I am making a atomic layer by layer structures now. So this is how you are going to do it by bottom up approaches. And mostly these are condensation methods, solidal processes, chemical depositions. Now these are forming an economical aspects here. So this is where like synthesis also is very important, and how you go with a simple method to obtain nanostructures. So the main questions here, and the title of my topic is what makes nanometers important. So this question is very important. So is another question comes in mind, is it surfaces or interfaces? And the answer is yes, because when we are trying to go into nanoscale region, what actually we are trying to do is, or what we are actually trying to study is its surface. So where like what is a surface or an interface now? So it's simply defined as like a special interface between solid and liquid, or an vacuum interface. So anything like for an example, now if I see if there is an environment change, like temperatures, change in temperature, pressures or something, the first thing affected for us is our skin. So why this happens is because of our skin is nothing but now the surface, and now the surface is intimated, or it is in contact with the environment here. So this means like the interface is also important. Surface as well as interface plays a very vital role, and these surfaces and interfaces are important to be controlled now, because since you are going into the nanometer scale dimensions. So one, if you have a better control on the surfaces, then surely you can have a better control on the interfaces. So this is how you can and actually try to understand like nanomaterials. The importance of nanometer materials lies in the surfaces and interfaces. So here as an example, you can see like if I have an oriented substrate here, now I know the dimensions of this lattice, and what I'm going to do is I'm going to deposit certain material onto this. So what I will do when I'm trying to deposit on this lattice dimensions, there will be some shrinkage because this material will grow along the lattice directions now. So that means there is a shrinkage. So what I am actually doing is inducing some strain now. Now, this induction of some strain on the material can be helpful for me to control many of my properties. Secondly, if I have an oriented substrate which is quite wide now, so what happens is now this is having some tensile strain. So I can now actually control the surface as well as interfaces. And why the surface and interfaces are becoming important? The important point lies in here. Like you can see that many properties are determined by surfaces and interfaces. Mostly like all chemical reactions take place yeah, on the surfaces and interfaces, like catalysis, crystal growths, thermal emissions. There is a strong intercalation or relation between the surface and interfaces, and therefore now the current trend is totally moving towards surfaces and interfaces, like understanding of these surfaces and interfaces. And you can see like this surface and interfaces can influence the phase, density, composition in. So this like in your bulk form, and now you go into this nano form where surface and interface becomes more important. Then you can see that they are going to influence all your properties. For an example, you can see here, this is a flat silicon surface here. Now, when I put a drop onto water droplet onto it, I can see there is some angle, water angle or contact angle taking place. This contact angle is almost like 41, which shows that the wettability is quite good here. But now the same silicon surface, when I use a pyramidal structure, formation of nano pyramidal structures, I can see that within these voids, I can have a a ball on like water droplet ball, which is having a contact angle almost like 102 degrees, which means that the wettability is gone now. So this is how like at the surface and interfaces you can you are going to control it. And now if I grow nanorods on this surface, what is going to happen is the angle is moving more larger towards the larger side, like 157 degrees now. So this means I'm totally making the surface hydrophobic in nature now. So this has some different aspects for applications then. And so the nanostructures are very important. Now you can see that at if this example is quite well known for all of us, like butterflies, and you can see the beautiful colors on these wings of the butterflies. Now what are these? These are nothing but the photonic crystals. Mostly they are called as lattices, and these are stacked lattices. So whenever a light is diffracted from these lattices, they will be diffracted in a different wavelengths, and therefore at different wavelengths they are going to show different colors. So that's why you can the appearance looks like having a different colorful background on the wings. So that's why the nanostructures at the surface and interfaces are becoming very, very important and to study. You can see almost like not only condensed matter physics, semiconductor devices, heterogeneous catalysis, vacuum technologies, electrochemistry, corrosion chemistry, or almost are been dealing with the surfaces and interfaces these days. So almost applications are belonging to surfaces and interfaces. So when I look at what is important in nanomaterials, I come to an conclusion that yes, surfaces and interfaces are more important, and they need to be studied very hardly in order to control the external properties. So here I just want to show as schematics like how these surfaces and interfaces are unique. So if you see, if I am having an atomic lattice now here, and these atoms are being arranged periodically, the same layer is again grown on the first periodic lattice. Is what I see is now at the surface or the interface there is a very, very good periodicity. What it means is that like the surface and interface is perfect. But now let's see what happens if when I'm growing something and in between there is a sludge present. What happens is now the surface and the interface, and in between you have a sludge. What it makes is the compound can go into some different properties. Note that if I have a perfect surface and interface, I know that the probably my first answer for this would be like this material will be very strong. But if there is a sludge present in between, like say dislocations or some defects like I've shown here, what I can see is that surface might be more brittle or might not be very hard because of these dislocations and defects present into the surface and at the interfaces. So therefore, each suffix will speak its own story, and we need to understand what this story is all about. So there comes our skills of characterizing the materials. So first and very simple method to characterize of a surface is nothing but a contact angle. So this contact angle can make very is a very helpful technique or a tool to understand the surface properties at the and also the interface properties. You can see that if you have a flat homogeneous surface, what I can see is the contact angle making on this surface is almost very low. So this means that the contact angle which is below 90 degrees, so this means there is a wettability between the surface and the interface now. So this means that we are having a hydrophilic surface now. Now, if you see that there is a high roughness on the surface, what happens is this high roughness also changes the angle of contact. So therefore, the surface can be very easily characterized with the simplest tool that is contact angles. So I'll just like to explain later in my application part where how we have utilized these simple techniques in fabricating devices. So here you can see like what makes this contact angle change is nothing but the surface tension. It is the energy on the solid surfaces and the interaction between the forces of liquids and molecules and the surface roughness and temperatures. So in a nutshell, if I want to understand and these hydrophobic and hydrophilic surfaces, I can see that if the contact angle is high, then the adhesiveness is low, the wettability is poor, and then the solid surface energy will be low. This means that I am having a very highly hydrophobic surface in nature. On the other hand, if the contact angle is low, then you can understand that the reverse case is possible and wettability will be more higher. In that case, hydrophilic surfaces can be easy seen in on the surfaces. Here you can see like this is we already have studied in our BScs like how the cohesive and adhesive forces are taking place when you have a surface and interface. So you can see that within this bulk part, there are equally balanced forces. So these intermolecular forces are been equally been balanced with each other. So there is no net force on this now. But if you see at the surface, what happens is at the surface there is a net attraction towards the bulk part. So what happens is there is an imbalance in the force, and when there is an imbalance in the force, you can see that at the surface or the interface you have a curvature now. So there is an upward force trying to pull this interface here, while there is a downward force, which is an attractive force making the surface or interface move down and giving a curvature. And therefore this is simple technique is very much important. So how these polar bonds on the surfaces are affecting the surface tensions or the contact angles. So you can see that if I have the polar molecules present on my surface, then I can see that these polar molecules can get attached with the molecules by adhesive forces, and accordingly, if there is a strong bonding taking place, then this means that there will be a very good contact angle, or the wettability will be more higher. So accordingly, one can actually tune the surface properties, understanding the surface tension on the surfaces and the interfaces. So if I want a high energy, or if I want a high or a low surface energy, so that means I can use some treatments. Like if I use a plasma treatment or a chemical etching treatment, I can change the low surface energy to high surface energy. Or if I can use an adsorption or hydrogenation processes, so if you can see, like if I use a hydrogenation here, then the H2 will be formed, and then these bondings will be more higher, so I can make my surface go from higher surface to lower surface. So here you can see that this pyramid shows you, like the greater the portion of your polar groups, higher will be the attractive forces, higher will be the surface tension, and high will be the contact angles. So therefore, this is very important. You can actually see that if you put an oil or if you put an water on the surface, you actually can see what is going to happen. So this means that the chemical composition at the surface is much dependent on the surface energy. Secondly, these polar groups, if uh, not properly polished or they are unpolished, then they causes high surface energies. You can see that most of the contact angles can be leading to different kinds of surface understanding or properties. So not only that, your temperature and surface roughness can be one of the effective points to understand. So I have made just shown you small table which shows like how the wettability of the surface can change, and how the hydrophilic and hydrophobic surfaces can be made to achieve different kinds of applications. So coming back to understanding the properties, that not only this simple tool to understand the surface properties, but there are more sophisticated techniques like X-ray diffractions. You have surface X-ray, surface or glancing angle X-ray diffractions. You have XPS, you have XES, which shows the electronic properties or the chemical composition properties. You have XFs, you have polarization dependent and reflection absorption spectroscopies. You have Raman spectroscopies. You have AFMs to understand different kinds of properties of these surfaces and interfaces. So let me come to application part of this. Now you can see when I'm talking about nanomaterials and I'm talking about the surface and interface. So we already know this. This is a well-known mechanism now. Everyone has came across this mechanism. So you can see at the surface and at the interface now. The interface is between the two grain boundaries now, and at the surface you have polar bonds. So what happens is now when there is no interaction of any gas on the surfaces, what I can see is the current and voltage have a very linear relationships. Now when I'm talking about a linear relationships, that means I am making a contact which is ohmic in nature of this study. Now when, or as soon as I input some reducing gas on this surface, what is going to happen is this H2 will react with the surface is polar bonds of O minus, which is chemi absorbed on oxygens present on the surface. And what happens is there will be a reaction taking place at the surface and interface. So electrons will be given in, and these electrons can be passed through the interface grain boundaries, because the grain boundaries will be lower down. As a result, I can see that the current will increase, and therefore the resistance will be lowering down. So if you see that the potential barrier here now goes down, and electrons can be easily conducting. On the other hand, if you see for an oxidizing gas, the polar surface is, in this case, now the oxidation gas will react with the oxygen to make an O2 minus us, and electron will be removed from the surface. Thereby the grain boundaries will start to grow up. Now at the interface, an electron on barrier is taking place, and electron will not move very easily through this. Therefore this barrier will increase, and you can see that the current will be lower. So now what I want to tell you from this application is that how this surface is important, because this surface and interface are very important for me. So if I know how can I control this surface and interface, that means I'm going to control the exact output of my device. Is coming down to various applications. Now energy being a very important part in our life now, because we are moving on to understanding the renewable energies is, and battery is one of the very important field, or you can say that electrochemical devices are playing a very important role in energy aspects, wherein battery, supercapacitors, or solar water hydrogen splitting is playing a very important role. You can see here I have shown a very simple cartoon here. Now you can see these are the two electrodes, which is at a potential positive potential, and the other one is at negative potentials, and we have grown some layers on this is electrodes. What you can see that the grow the contour of the surface is defining the contact angle now. So you can see the contact angle will be defined by the controls of the surface. Not only that, at the surface and the electrolyte, what you can see is there is a capacitive double layer, Helmholtz layer, and this will be governed by again the contact angle on the surface here. So the important point is like how I am going to control this surface will affect my total current and potentials or the device applications. So here you can see that if the surface and interfaces in electrodes are and the electrolyte are porous in nature, what is going to happen is there will be a high intercalation taking place between the electrolyte and the surface as electrode. So this means that there will be a possibility of very high redox reactions taking place on this surface, and accordingly you can see that if you have a porous layer, then that means your current will be pushed here, so that your ore potentials will be lower, and you can have a very high currents and produced at a very small potentials, applied potentials. So this means like this application of understanding the surfaces and interfaces plays a very crucial role now now I'll just try to sum up my talk by giving a simple example. This is our current paper which was published, and what we have done is we have taken an antimony selenide. Now antimony selenide has an intrinsic bonding, so along this it has an covalent bonding, and along the horizontal face it has a van der Waals bonding. So what it shows me is that along the covalent bonding I can see that there are adhesive forces taking place, and the contact angle is becoming lower. So I am getting in an hydrophilic surface if I am stacking in the antimony selenide along the 0 Ka 0 planes. On the other hand, if I'm trying to make the antimony selenide in such a way that I am having H0L planes or H00 planes, so what I'm doing is I'm actually at the surfaces I'm using a van der Waals interactions, and now these interactions make the water contact angle much higher, and therefore I have an hydrophobic surface now. So why I want this surface is to make a bifunctional filter now. Now this filter will be very essential for me, such that if I use this is filters on a mesh part. So here is a mesh, and we have grown this is antimony selenide oriented surfaces. So what you can see is that when you put oil and water on this surface, what happens is now it is having in hydrophobicity for the hydrophobicity towards the water. So on the surface, the water will remain while oil will penetrate. So this means like you can have a filter now, and now this filter is going to be used in such a way that oil will be separated from your water. Now if I have uncontaminated air water, so what I will do is I will use this is surface now. So what I will do is I will irradiate this surface with some light so that electron holes are generated. And now if the contaminated water is present, like dyes are present in this, then I can degrade the dye at the same time. So these are bifunctional materials we have been developed, and you can see that this is our device where you can see that for just understanding, we have put some colors into it. So this is a methylene orange, and this is hexane, which was mixed together, and then when we put into this device, what we see is the methylene on orange, which is having a water part, it remains at upside, while the hexane, which is having an oil part, goes through it. So that means we have a very good filter now. And now when we put in light and put some electrode into this, what we can see is we can degrade this. Is now this electrode is nothing but our mesh structure here. So that means that the surface is very important, and how you control this surface, you can control the bifunctional properties, wherein we have shown in antimony selenide that we can use this simple material for making such filters. Likewise, I would like to sum up this talk, that at length scales of nanometers, you can see that at the surface and interface, they are going to play a major role defining overall physical properties. Not only the physical, but I will say that physicochemical properties will be governed by the interactions at the surfaces now. And now almost like we are going to miniaturize all the devices. So that means surface and interfaces will become an important part of our study. So using various techniques, we can identify and study these surfaces and interfaces. And what remains a challenge for all our scientists is that how we are going to who actually control the surface and interfaces. So this is the main focus of the study currently going on worldwide, and I feel that this becomes a very important aspect for all the researchers today to study the surfaces and interfaces, and try to make various devices which are commercialized. So lastly, with this, let me make different and beautiful surfaces and interfaces. You can see that we can make a lot of surfaces and interfaces. So our facial itself is a very good research topic to study. And with this, I thank all the organizers for giving me this opportunity to talk. I hope and congratulate them for a successful conference. Thank you very much. And I would be happy to have some questions now.
Thank you, sir. Thank you very much. As relevant to the topic, what makes nanomaterial important, our registered participant, research students, and many other academicians. Thank you very much.
Yes, thank you, sir. Thank you.
Thank you very much. And I pay my special vote of thanks to Nishadji Deshpande, who has delivered a talk on the what makes nanomaterial important from South Korea. Thank you, sir. Thank you, especially in a very lucid and simple style, explaining the importance of nanomaterial. Thank you very much.
Yes.
I hope your kind love, showering of kind love will continue with us in coming days also with the manual conferencing when this pandemic will be get over. Thank you, sir, very
Sure,
much.
sir. It is a great honor for me, sir. Thank you very much.
Thank you, sir. Thank you very much.
Thank you.
Now, moving, I request or I announce that today's another chief resource person for this conference is Dr. S.T. Bendre, sir, who is head of the Department of Physical physics in the KBC NMU Jalgaon. So I request Dr. S.T. Bendre sir to come over here. Before it, I request the chief conference of convener of the conference, Professor Dr. Bagul, to make a brief introduction of Dr. S.T. Bendre sir. So over to Professor Dr. Bagul.
Hello.
Respected dignitaries on the screen and behind the screen, faculty, staffs, and my dear participants, very good morning to all. It gives me a great pleasure to introduce the resource person, Professor Dr. S.T. Bendre, on this memorable occasion of first day international conference on ethical quality aspects in nanoscience and nanotechnological research. That is ICNAR 2020. He has former director, School of Physical Sciences, KBC NMU Jalgaon. He is chairman of Board of Studies. He is coordinator, ISRO, VP Talk Back, EduSat Technical Terminal. He has organized number of science programs to understand the basic concept among the peoples. He is coordinator of Rajiv Gandhi Science and Technology Center, Government of Maharashtra. He is only academician, scientist in Maharashtra, has been granted a major project for Silage Based Area Development Program, CADP, at Nandurbar, and sanctioned 14 crore in phase first. His research area in fields like advanced new materials. With this brief introduction, I request Honorable Dr. S.T. Bendre sir to enlighten on topic material aspect for green energy issue, our CADP initiative. Honorable Dr. S.T. Bendre sir.
Hello. Am I audible?
Audible,
Am I
sir.
audible? Yes,
Audible,
yes. Okay.
sir.
I will share the screen then. Huh? Okay.
Okay. Okay, sir.
Huh?
Okay, sir.
Yes. Are you able to see the screen?
Yeah, sir. Yeah.
Yes. Okay. Good morning to all. First of all, before starting this particular address, I congratulate the chief patrons, management members, principal, then convener of this particular workshop, E-International Conference, the participants, distinguished resource persons, and other who are directly or indirectly involved with this particular conference. First of all, I'll be talking about material aspects for green energy issue, our CADP initiative. Now, what this CADP word is, that I'll be explaining after a couple of minutes. But as far as I am concerned, I'll be focusing couple of basic issues as far as this particular area is concerned. My presentation will include this particular talk. I mean, some of you can call this as a motivational talk. The experts, I will ask them because this is going to be very basic, and that is why I'm calling this as a motivational talk to encourage the coming researchers. I'll be also giving a couple of basic issues of the materials, followed by the technology-driven examples, and then what this particular CADP, our new initiative in the Nandurbar region especially, with the help of green technologies. And I understand the task of this particular conference is related with the nanoelectronics, magnetics, ferrites, nanochemistry, biosensors, semiconductor materials, and solar cell materials. So once again, on behalf of all of us, we congratulate the organizers for choosing this particular one of the very novel area for the applicability point of view from the basic research as well as from the technology application for the real applications. This is our School of Physical Sciences,
And I request all of you, whenever you get some time, please visit our university. We'll be happy to welcome all of you. Since this particular conference is related with the nanotechnology, and I understand number of other distinguished resource persons are going to talk on that, but just for the sake of convenience, here I have classified the materials into various categories like solids, liquids, and gases. But out of these, especially the material science always deals with the class of materials called as solids. And the question is how small and how big. And therefore, I have cited this particular example by taking a small leaf. And then if we divide this particular leaf, we can go on a very smaller scale at the level of quarks and still below. On the another side, I have shown the picture of this particular man and this particular smaller scales. On the other side, larger scales. And that is where the understanding of the physics and material science is coming into the picture. And therefore, number of disciplines of the physics are coming out, and nanotechnology is playing a very, very important role as far as this particular understanding is concerned. And therefore, as far as the research is concerned, now if we concentrate our attention on a material called as solids, and if these particular solids are exposed to one of the two important field, what is called as electric field and magnetic field, very interesting things are coming up. And therefore, this particular solid, I am calling that as now conductor, exposed to the electric field. What are the fascinating things are coming up? The same solid, now we can call that as a magnetic solid, exposed to the magnetic field. What happens to that particular thing? And these are the basic issues which are responsible for the technological applications. This seems to be very simple, but at the same time, it is very, very complicated from the physics point of view. And therefore, the same conductor, now I am applying the electric field and then vary the temperature. Number of issues are coming up. Now, why I am sharing these particular things? Because these are the important issues as far as the understanding of the materials is concerned for their application point of view. Number of instrumentation issues are coming up. What kind of temperature sensors we are going to use? What kind of low signal devices we are going to put? What are going to be the interfacing issues? What are going to be the various kind of PID controllers? Contact issues with the materials. And as a physicist, one of the very simple characterization normally we do here, which I am represented by resistivity variation as a function of temperature. Now, temperature variation, how large or how small, that becomes a great problem as far as the number of issues are concerned. Now, the same experiment I am putting again here, and fortunately, majority of us, we are carrying this particular experiment from our 10th standard, simply called as a conductor, and then apply the electric field. And this is one of the very famous law called as Ohm's law. But all of you know that this particular experiment, one needs to still carry, and some of you might be knowing that this is one of the very famous area called as the superconducting materials. And there are still number of Nobel Prizes are still waiting in this particular area. And if tomorrow participants of this particular conference can discover this particular new materials, I think that day the society will be very, very happy. Here, just for the sake of information, what temperatures we can go down, low temperatures. And that is the big problem as far as the physics is concerned. Can we really achieve 0K? Something like you might have heard the number 10 to the power minus 34, 10 to the power minus 12. But can we put into the reality? And that is where the instrumentation part is coming into the picture. Another experiment I would like to share, normally in the material science, earlier we used to study the electrical phenomena separately and the magnetism phenomena separately. But now a combined effect has come into the picture that given a material, then apply the magnetic field and then vary the temperature. In that case, some kind of very interesting properties are coming into the picture. And therefore, these are the novel concept which has emerged as a part in the material science with the development of nanoscience or nanotechnology. And therefore, these issues are very, very important. And therefore, experiments plays a very, very important role as far as the material science is concerned. The same experiment here I have shown this particular solid by the form of what are called as electrons, and these electrons are characterized by their spin. Now, very interesting thing in the physics that majority of the words are getting ended with on. For example, electron on, photon on, neutron on, and that is making our very interesting life very, very interesting. And at the same time, I will not go into the details. Here, the thermal energy, kT, and the magnetic energy, mu h, decides in what way this particular solid is going to behave. And based on these particular issues, number of devices are coming into the picture. I'll be not giving a couple of our own results, but just for the sake of information to this particular audience, I have enlightened these particular two experiments, which are very, very important from the technology point of view. And this particular experiment gives the information that if I carry the resistivity variation in presence of magnetic field and without magnetic field, I get some number, and that particular number happens to be very, very large. That is normally called as delta rho by rho. And this particular phenomena in the material science is referred as giant magnetoresistance. And this particular giant magnetoresistance phenomena is now has been put into the technological applications, and the devices are playing a major role. And again, this was awarded the Nobel Prize in the physics, and the way in which the materials are playing an important role. Same phenomena, but now I am putting what are called as a manganite materials. These manganite materials are the specific materials, and when they are exposed to the electric field and variation in the temperature, we get this particular GMR or CMR to be in a very large manner. And therefore, based on this particular phenomena, we are now having a new devices what are called as the spinotronic materials. And here, just for the simplicity, I have shown this particular diagram, the kind of appliances which we are using in our day-to-day life, like pen drive, hard disks, all these particular things. And these are the basically consequences of these particular materials. One more very interesting thing that has happened, I am very sure within a very short period of time, all of us will be throwing all our tablets, all our screens in the dustbin, and now we'll be having what are called as a new 3D devices. And this has really created an excitement as far as the technological part is concerned. My wish for all of the new upcoming researchers, please enjoy this particular beautiful aspects of the physics, which is a consequence for the better technological as far as making our life in a very comfortable manner. Yes, now coming to my actual talk that I was supposed to talk on the green energy issues, and just for the not going into the too much complicated details, here what I am trying to say that this particular conference has focused on one of the aspects what are called as the materials issue. And therefore, here, for example, if we have a solar radiation falling on this particular certain kind of material, so far we normally call that as a semiconductor material, and then certain kind of interactions goes on, and we get certain kind of output. And therefore, this becomes one of the very, very important part in what best way we can extract the needfulness as far as we people are concerned for the application point of view. And therefore, as far as this particular solar cell materials are concerned, let me put another very significant attention of all of us that these solar cell materials are characterized by, or they have one of the very, very important parameter called as the efficiency of the solar cell. And again, this particular experiment needs certain kind of attention. If some of the researcher, if tomorrow comes up and breaks this particular efficiency, like at the present, the efficiency is up to only 10 to 20%. But if some kind of researcher comes up tomorrow with with 80 or 90%, the whole world will run behind and immediately the Nobel Prize will be awarded. And that is where the significance of materials aspect is coming into the picture. And therefore, my request for all the young researchers, please activate this brain part for the betterment of our society, because that is where the research is now limited. But if tomorrow somebody is going to break this will be really a great revolution as far as the material aspects are going to be concerned. Now, just for the sake of convenience, how this particular solar cell materials are concerned, you have one cell. Out of that cell, then you form what are called as the modules. Then you construct these particular modules in an array, and then finally we get what is called as a solar cell panel. Now, the difficulty with this particular solar panel at present, they are not flexible. So if tomorrow somebody is going to come up with a flexible solar array, that will be really again great day. And therefore, a lot of material aspects, chemical issues are involved in this particular area. And new area, what are called as the perovskite solar cells, is also coming up. People are talking about various kind of things. And therefore, this particular field is really upcoming because it has got tremendous applications as far as the society demand is concerned. Just for the sake of your information, this particular first aeroplane called as Impulse is totally based on this particular solar panel. Power is drawn from this particular panel and it has been operated. And again, scientists are looking for the flexible solar panels. Just at my end, although I'm a man from material science, but just for the excitement at our end, we made one solar bicycle, and in fact, a word of appreciation by His Excellency Dr. Kalam, the former President of India, electrified our experience. And from that day, I have really started working in this particular area. There are a number of issues in this particular solar cycle. So far, I am not happy, but there are a number of issues like storage of this particular power and all those particular electronic circuit. Number of issues are coming into this particular area. But again, this area needs to be upgraded as there is a demand from the society. Yes. Now coming to the another issue, what is called as a sillage at our end. What our aim is, whatever research we are doing in the laboratory, this should go directly for the applications to the society. That particular research should not be restricted only in the laboratories. And therefore, we have made a first attempt that in our university, whatever research we are doing, that should be applied for the societal applications. And therefore, we have come up with a new idea, what is called as a CT, what is called as a sillage. Now, what this particular sillage is, basically, if you look at the city structure and the village structure, in the villages, number of things are not available, and therefore, their life is restricted. Whereas in the city, number of things are available, but at the same time, their life is also restricted. For example, in the village, you have the best environment, like best purified oxygen, but in the city that is not available. Although some of you might have heard a place called Delhi from India, now oxygen parlors are coming. And this is one of the biggest problem as far as this couple of these advanced cities are concerned. And therefore, what we are thinking of, taking the best parameters from the villages, taking the best parameters from the city, and if you can combine these particular two things by use of the high-end technology, we can upgrade the life of rural and tribal India. And therefore, we have come up with a new word. Unfortunately, this particular word is not also available in the Google dictionary. This is a sillage word. Sillage means best of city and best of villages. And this particular concept, we are going to utilize, or we are going to motivate in the tribal and rural part of our Nandurbar district. Unfortunately, as far as our university is concerned, we are having a very good cooperation for this particular program, and I am calling this as a cooperative effect. But this particular cooperative effect in physics is a very famous. For example, you might have heard about the two electrons. One electron and another electron, they don't like each other. They always fight with each other. But if by some means these two electrons form a pair, in that case, that particular pair loses the resistivity. And that becomes one of the very famous phenomena called as a superconductivity. And you know that we can have a super currents and so many things. A number of Nobel Prizes have gone for understanding of the cooperative phenomena in the condensed matter physics. And therefore, I am using the very powerful word that let us make a cooperation with each other for better enhancement of our number of issues. And therefore, as far as this particular issue is concerned, we're having a cooperation from one of our leading institutes from our country called as Bhabha Atomic Research Center, Mumbai. This BIAP Pune, one of the very oldest agro-based industry of our country. Then we have a couple of Krushi Vignan Kendras from Nandurbar. Then we have another Maharashtra Knowledge Corporation Knowledge Foundation Center, normally called as MKCL here Pune. And then one of the another distinguished institute called as ICT Mumbai. They are participating for this particular silage program. Let me repeat it again. The idea is whatever research we are carrying out in the laboratory, this research should not only remain in our, for the publication point of view or for our own enhancement, but this research should go to the society, and that is what is our aim is. This is basically what we have worked out. We'll be having a science and technology entrepreneurships and resource node center at the Nandurbar, where a number of technologies will be worked out. These number of technology will be worked out with the high-end technologies like Akruti Tech Pack, then e-platform, then Silage Angels, and these number of institutes will be coming into the picture for contributing this particular field. There will be a proper execution in this particular Nandurbar region where Wadi, FPO, SHGS, Akruti, STRC, villages, cyberspace, silage, all these particular things will be taken into the consideration. I'm just sharing this particular presentation for the sake of information that how technology is going to uplift the life of rural and tribal India. And in fact, let me, since we are talking in this particular pandemic situation, they are the people now who have sustained in a substantial manner. Cities like Mumbai, Pune, or Delhi, they have gone in a very critical crisis situation. But look at our rural part. They are the people who have really overcome this particular pandemic situation in a substantial manner. And therefore, now through this particular silage, with the use of the high-end technology, we can upgrade their life. And that is why my request for all the researchers, if you have some good idea, please join for this particular novel initiative aimed for the noble cause. This will be the functional structure of this particular program. I will not go into those particular fine details, but this is where the role of fine researcher is coming into the picture. Yes, through this particular silage program, we have identified couple of very serious areas where we are going to work it on. One is what is called as a bioinoculant technology. Number of biofertilizers, chemical fertilizers will be developed from this particular project, and that will be applied at the end of rural and tribal zone. Then another area is about the micropropagation facility, especially the medicinal plants. All of we are aware that some of the medicinal plants are getting deteriorated or getting vanished, And this particular idea is we'll be recovering them through this particular thing, and therefore there is going to be a great emphasis on the micro propagation facility. Another area my slides are not moving. 1 minute. Hello, you are able to hear me? Hello.
Yes, sir. You are audible. Yeah, you are audible, sir.
But this slide is not moving. That is a big problem.
You are a coast road. Aren't you controlling it?
I am controlling it, but that is not moving.
Can we help from here? Can we?
Yes, yes, please, please.
Sir, remove the slide and share it again.
Okay. Okay, now it is going. Okay. Yeah, another technology which we are working on, that what are called as the eco-friendly domestic fuel technologies. All of we are aware about the adverse traditional chulas, and therefore in this particular program we have a very focused issues on what are called as the eco shredder, eco pellet makers, and then the specific eco chulas will be given to this particular tribal zone so that they will be enjoying this particular fuel technologies, and some of the things are ready at our end. But because of this particular pandemic situation, we have not yet gone into the fine working details of that. But this is the another area which we are going to concentrate. Another area which I will be giving a couple of examples of what are called as the solar issues. This is one four-wheel drive vehicle which has come through this particular project, and this particular vehicle will be installed 2 kVA mobile solar upgrade power plant. And the unique design will be, this is going to have a lithium ferrophosphate battery, and that is what we are calling as a real green approach as far as this particular work is concerned. And this is what is going to also give a popularization about the solar aspect in the rural part. And that is what again our emphasis is, to put the reality of this particular research issues in the application point of view. Yeah, next thing is about one of the very important thing which we are carrying out at our end. And this has really excited the whole community. We have developed one 5 kVA solar power plant that is called as a demonstration unit. And that is what we are calling as the off and on green mode. And at the same time, this will be also used for the e-vehicle charging station. Now, some of you might be able to see here this particular car. This particular car we are charging from the last 3 years. And therefore, I have not utilized even a single drop of any petrol or diesel for this. And therefore, this particular car is running on the solar. And therefore, number of issues are coming up here now. And therefore, there is a great challenge that how best we can utilize these particular resources for our number of application point of view. As I mentioned, we can apply our mind because all of we are being the physics and electronics teachers. We can think of this particular number of issues, on-grid, off-grid issues, storage capacity of the batteries. That is one of the another very, very important aspect as far as the material science is concerned. Then fast chargers and inverters. What short period of time I should be able to charge my vehicles. This is another very standing problem as far as the researchers are concerned. At the same time, can we have this particular vehicles to run for a longer period of time? At present, at the most we can achieve something like 120 kilometers, but tomorrow can we achieve 2000 kilometers? Can we achieve 1000 kilometers? Those kind of storage battery capacities, those particular fast charges. So these are the issues as far as the researchers are going to be concerned. And I am sure over a period of time, this nanotechnology, material science, and the interdisciplinary approach will definitely solve these particular problems for the benefits of the human mankind. The integrated mode, which I'll be talking about, is one of the very, very important issue, because the kind of solar panels which we are using only for the submersible pump can be also utilized for rest of the applications. And therefore, this particular integrated mode is very, very important. And therefore, these green initiatives are going to play an important role as far as our life is going to be concerned. This, at the same time, just for the researchers, I have come up with certain points here. For example, what kind of conducting wires we are going to utilize in this particular, what kind of earthing, that is also, because for the earthing, making a good earthing for this particular e-vehicles, we will struggling almost for a year. And therefore, these are the issues. How EN voltage we can make almost zero, that is a big problem. Best kind of arresters, like SCADA platform, these are the issues as far as these particular technologies are going to be concerned. And therefore, these particular organizers which have selected this particular nanoscience, nanotechnology, that is going to cover all these particular issues, and basic understanding as well as the application of these particular issues, an important part. Some of the things are at our experimental stage. We are still in the process of designing some kind of hybrid fridge. For example, this 11-liter fridge, why I'm simply giving an example, in the rural or the tribal zone, they don't have any fridge or something like that. And then how they can preserve their foods? And therefore, this 11-liter fridge, just operating on the solar cell, can serve their purpose, and therefore we are developing this particular fridge. And therefore, in short, the integration of like solar pump, car, home appliances, this needs to be integrated with this particular solar panel. And what kind of storage batteries we are going to use, that is also another very standing problem as far as the material science is concerned. This lithium-ion, lithium ferrophosphate battery storage, no doubt is going to solve that particular problem. But at the same time, we want very high storage capacity, and therefore for a very longer period of time, then and then that will really solve that particular problem. Then as far as since we are the teacher, it is easy to teach on the blackboard, but extremely difficult to put on the reality. And therefore, in what best we can solve these particular problems, and in what way we can have the solution. And we are very much sure that we'll have a solution through this particular green technology. So small ideas can bring big revolution, and therefore our request is think globally, but let us act locally to solve our problems. What are the challenges as far as the material science is concerned? For example, biomaterials are going to be another new area. For example, right now we are connecting the pen drive to laptop or desktop or iPad, but in future these pen drives will be connected directly to your body, and number of issues will be solved. Hybrid human being, for example, the way in which we are thinking, can I detect the brain waves, and then can I solve number of problems from the medical branch? That is going to be another very area. This CMR materials, that is also going to solve number of problems. As today we are talking about the nano devices, in future we will be also having the femto devices which are coming up. Spinotronics, photonics are going to be the another area. Then can we create large magnetic field in the laboratory? That is also going to be the issue. Nature, the greatness of this particular subject, and therefore let us respect this particular nature. The role of researcher is something like a booster leader. They can only solve the problems, and we are sure even this particular COVID-19 situation, the very good researchers will solve this particular problem, but it will take certain time. And we are sure the interdisciplinary approach will only solve best good instrumentations, best use of all the disciplines that will solve this particular problem. And therefore, booster leaders can act as a good example as far as our society is concerned. Some of you might have realized that these words normally in the society, quanto, nano, impulse, magnetic, companies or industries are using these particular words. But please remember, they are all our basic physics words, and that is what the society is respecting. Finally, I am not going to simply put the thanks, but since I am working in the area of giant magnetoresistance, my fashion is normally, I am putting the giant thanks and our honest efforts for the society-related activity and understanding of novel phenomena from the nature for the benefit of mankind. With request to visit our university whenever you get time, as well as our Rajiv Gandhi Science and Technology, North Maharashtra University Center, as well as our the Silage Area Development Program, a novel program which we have initiated in the Maharashtra for the societal application, and request of this knowledge which you people are going to gain in this particular nanotechnology conference today to propagate these issues among us, the students, societies, your enemies also, for boosting the scientific department to address the problems for green energy solution. This was the presentation for noble cause. And if some of you are interested, if some of you are doubt, you can reach me at also stbendre@nmu.ac.in. Thank you. Not simply thank you, but giant thank you.
Thank you, sir, very much. Now, actually, it's our turn to pay very giant thanks to you.
Thank you, thank you, thank you.
As you saw in Marathi proverb, it is said that Jana Seva is the Ishwar Seva hoy.
Yeah,
Service
yes.
to man is the service to God. What the
Yes.
Department of Physics and the KBC North Maharashtra University, other departments of science are doing is a directly service to the poor people, service to the local people, service to the
Yes.
downtrodden people and common people. Very big
Yes.
thanks and big salute to the works, all of your works you are taking. And although you have said that these are challenges before us, but we still believe that as far as your hard work is concerned and your journey up to this time is concerned, those challenges will become into actual outcomes, actual goals. Our best wishes are with you. You will definitely serve the poor society and the common society in the not in the KBC enemy jurisdiction, but for the whole mankind. Thank you very much. You have enlightened us on the various issues of solar energy and its uses, nanotechnology, its uses. You have rightly said, sir, that the many industries are using the words from the Department of Physics. Physics, it is not only a science of masses or universe, it is the science of lives, it is the science of human being. And now in this pandemic situation, all the world is looking with a very big hope to physics, that they will do something nano research or find something for the better cure of the human being. Very, very big thanks for you, and we hope that all the registered participants and other so many academicians who are registered with this international e-conference, they are warmly welcome by Dr. S.T. Bendre, our honorable resource person, to visit their different initiatives for the good mankind at the KBC NME Jalgaon. Thank you, sir. And as we know, we are very fortunate that we are part and parcel of our parent university NME Jalgaon. What it is doing, we have experienced it. Big thanks, big applaud for your enlighten us on the solar energy issues and enlightening us your services. Thank you, sir. Thank you very much. Now,
thank you. Thank you.
Moving next, we have another galaxy and gallery of the resource person. The next turn is, the basic theme of this conference is following the ethics and quality in research. Research is basically what is existed and it is getting funding. It is a research, and any good activity must follow the ethics, quality. If you do not have a ethics and quality, then no research will continue too long. although it will serve you individually, but it will not serve for the mankind and it will not last long. Keeping in with you, our next session is from Professor Rupesh Diwan, who is from IIT Indore, about it that ethics in research publication. Nowadays, it is said that India is far behind in research as compared to the data of the world. But I hope that if India will follow the right track of the research, and then definitely it will last long and will prove a good example of research. Now, before to proceed further, I request the convener of this Equinar 2020, Professor B.Y. Bagul, to make the brief introduction of the chief resource person of next session, Professor Rupesh Diwan. Over to Professor B.Y. Bagul, sir.
I take opportunity to welcome and introduce one of the resource person, a very scholarly, dynamic, and renowned personality in the area of physics, that is Dr. Rupesh S. Dewan. He postgraduated in physics, specialization in material science, and received his PhD in physics material science from Shivaji University, Kolhapur, India. In 2007, he joined as postdoctoral fellow at National Fong Ho University, Taiwan. After availing the Inspire Faculty Award in 2014 from the Department of Science and Technology, DST India. He joined University of Pune, India, and moved to Central University of Punjab in 2016 as associate professor. He has joined IIT Indore as assistant professor in March 2017. Now, he is an associate professor since December 2018 in the discipline Metallurgy Engineering and Material Science, Indian Institute of Technology, Indore, India. He is the editor of the Chinese Journal of Physics elsewhere. His research interests included the fabrication and characterization of metal oxide and polymer nanostructures for engineering applications. His research group utilizes nanoheteros architectures, photoactive materials, and core shell nanostructures for energy conversion storage applications. Polymers for energy applications. In his research field, he has published 1 book, 2 book chapters, and 97 research articles in SIG journals. He has citation greater than 3,1956, H index 38, and I-10 index 70. He received number of honors and awards, associate member 2006, Institute of Physics, London, UK. Excellence in PhD research in 2006, Shivaji University, Kolhapur, India. Postdoctoral fellowship, Ministry of Science and Technology, Taiwan. Inspire Faculty Award by Department of Science and Technology, DST, India. Young Associate of Maharashtra Academy of Sciences. Excellent grade 2007 for Inspire Research Project by DST, India. Editor, Chinese Journal of Physics. DUA India Professor Fellowship Award is ASEMDO S Korea. Apart from this, number of research scholars are working under his guidance. Bachelor students 3 are completed and 3 are ongoing. Master students 7 completed and 5 are ongoing. MPhil 4 students are completed and PhD 8 students are ongoing. With this brief introduction, I request Honorable Dr. Rupesh S. Dewan to focus on his topic, ethics in research publications. Honorable Dr. Rupesh S. Dewan.
Thank you, sir.
Oh,
am I audible?
Okay, sir. Audible, sir. Yeah.
Yeah. This is quite long introduction. Actually, you would have introduced me that I'm friend or I'm known to Gosavi, sir. That was more than sufficient for this place, right? I'm going to talk today about ethics in research publication. The topic is a little bit different for many of the audience might be. But as a researchers, we are always engaged with research publications, and we have to consider that research publication will be long lasting in the form of a record, and then we have to consider what ethics needs to be followed to publish the paper. So before I start about the research publications, I would like to correlate the research with the day-to-day activities. So if you look at this, then my talk will start with introduction, then some importance of publication. Then I will be talking about factors affecting on publications. So what is good publication practice, how ethics in publications are important. Then I will let you know some how we track the plagiarism as a publishers and what are the publishers' viewpoints. So before I start actual topic, I just would like to correlate daily activities with the research. So as per my knowledge or as per my views, the research is nothing but like farm to market. As we as an Indian, we know that our economy is based on farm. So if you look at this picture, there are two lands. One is fertile land and other is non-fertile land. So if you use this fertile land, then it depends on you how you grow your crops, what kind of crops you are going to grow in your farm. After that, how you arrange matters more to attract the people to buy it. If you arrange it randomly, then maybe attraction not good. But if you arrange it a proper way, then it looks much better. After that, what comes out is how you process these foods. Suppose you want to go into good market, then you have to process all these foods. And then what happens is how you arrange and how you process. Based on that, you can sell your product, but where you can sell, either in a local market or in a mall. So if you go to local market, your product will be sold very fast, but price will be very less. But if you want to go to a bigger market like a mall, then you have to process your foods. You have to waste a lot of energy for processing, but price will be higher. So ultimately what need for the product which are being farmed is either you should have a larger price, or you can sell with even a smaller price. So that's it. So journals, if you are looking for a research publication, then we are not different from that. So laboratory is nothing but our fertile land. So it's like a farming, right? So in a laboratory, what kind of materials you synthesize matters a lot. So after synthesizing a lot of materials, you have to consider the analysis of these materials. So after that, you have to consider the property analysis. So after analyzing this material, you have to understand what kind of properties are there with this material and what kind of application you are going to have with that particular material. After that, you can think about publishing this research in a scientific journal. That means you have to consider writing skill, and that indirectly it's your marketing skill because you are going to publish this. And once you publish your paper in this journal, then they will have impact factor, and based on their impact factor, this journal will decide your growth, and then your publication will be either ranked 1, 2, or 3, or somewhere in between. So this fertile land, after that you use your knowledge to publish your data over here, and these journals decide the quality of your research publication. So during these publications, the question comes out that are we ethical in this publication race? So the best example over here is the sumo. So most of you know the sumo, which comes from Japan. So this is a bigger guy, and here is a small kid, which is going to be a sumo wrestler, want to fight with this particular guy. So is it ethical? Of course, if you look at this answer, of course not. So why I put this picture over here? So this is a journal and this is your publication. So suppose you feel that your publication is not that good enough, then can you publish it here? So of course not. Another thing is, this is your research problem and this is you. So suppose your research problem is too much big for you, then can you compete with that? Of course not. So you have to compromise somewhere, and you have to decide how you are going to tackle your problem, how you are going to publish your data. So this is the best example that we should ask ourselves, without ethics, is it possible for development? So if you look at this picture, it's a first computer comes out with very big size, approximately 20 by 40 square feet room occupied. And then nowadays you can see this 20 by 40 square feet room occupied computer converted into a small pocket computers, and you can use it anywhere, you can carry it anywhere. Why it happened? Because ICs on one particular area are doubling. So you can see the IC size is decreasing day by day, and it's following Moore's law. So every year it's twice on the 1 centimeter square area. but recently it become 2.5. It's quite large. So if this research would have not been ethical, can we be able to convert this big size computer into a pocket computer? It's of course not. So we have to be ethical. Then the question comes out, nature is ethical to us or not? So if you look at some examples, then sticky feet. So lizard can walk on any wall. That means they have sticky feet and they can move around anywhere. So nature is giving an example of nanotechnology. Second one is spiders. You can see this, a small spider uses saliva in the form of polymer and create a very good net, and that can have very good strength. It can catch the foods for the spider, right? And that even can carry the weight of this spider. Next example is a self-cleaning butterfly. So if you look at this butterfly, it's very beautiful, but always clean. So we are using such kind of technology for self-cleaning windows in aeroplane and buildings. So optical nanoscience again there. If you look at this guy having lot of colors, we are known about the 7 color systems which comes out with the rainbow. But this guy let us know that these 7 colors can be mixed together and we can create a lot of colors. So we are trying to mimic this technology and we are creating a lot of colors which can be used for a variety of applications. Then the water collecting bitterbegs. So if you look at these bitterbegs, it's used to survive in a desert. Now the question comes out, without water, how it can survive in a desert? Because the structure is in such a way that it can collect the water across this body and can move directly to its mouth, and that can survive in a desert. The similar way, our real life Punsuk Wangru has created a big tower of the ice in open environment. Then the Takun beak, you can see this bird with very large beak, approximately size of its own body. So such kind of beak, how this bird can handle, because it's very lightweight, very porous, but of course it not percolate water. So we are using this technology to create aeroplanes. So just imagine if this nature is giving us an idea to create a technology for our own. But what if this nature hide everything from us? If nature is not ethical, that means what? Suppose we try to understand how they're handling all those properties. And during this analysis, if they not give us an idea, then we cannot do anything. So nature is really ethical to the human being. So we have to be ethical with this. So why exactly this ethics is required? So if you look at this equation, E is equal to mc square. E stands for energy, but for me, E stands for Einstein. So this man created a very big research for atomic bomb, right? So when first atomic bomb was established in July 1954, this Einstein might be very happy to see his research revolution coming out. He might have thought at that time that his research will be used to extract the minerals from the earth or to send some very good satellites or human being in a space. But does it happen? Of course not. Exactly after a few days, America threw this big atom bomb on Hiroshima and Nagasaki. At that time, Einstein might become sad because whatever he followed ethically, the country could not follow. There may be a controversial discussion on these ethicals, but I feel this was not ethical. So that's why ethics should be followed. Now, the source of ethics starts from the childhood. If you look at this picture, this is a PhD student, research scholar, and this is your supervisor. When you start working on your research part, first comes out with the conflict of interest, and there are many other things. So to learn all those things, we should be ethical. So where exactly source of ethics come? First one is family, because from childhood, our parents or our family teach not to lie. So that starts with the ethical things. Then friends, of course, not only in a graduate school, but all your friends. Then fellow graduate student who let you understand their things without hiding anything. Then comes out mentor and supervisor who tells you everything since joining to the lab. Other faculty members with whom the student is associated. Then religious belief, because each and every religion tells not to lie. So religious belief is most important thing. Then discussion in a course, lab, or seminars also gives you ethical discussions. Then professional organizations are there which offer the ethical training. Then courses dealing with the ethical issues are also there. But nowadays, the social networking like WhatsApp and Facebook can give ethical training if you use it properly. So what happens when research lacks the integrity? So if you not follow your research with the integrity, then it's called as high crime. So what are those high crimes? So this high crime is any kind of research misconduct, which can be a plagiarism, data fabrication, or falsification of data. So what happens if you go with this research misconduct? There are certain kind of punishment across the globe. The first one is a formation of the committee, and you will be issued with a warning, and then you will be asked to apologize if your misconduct is not that of high impact. And then you will be given with ethical training, and then you will be always supervised by certain committee. And after accepting that you are now following your research ethically, then certificate will be issued for future research if your ethical misconduct is not that severe. Suppose it's more severe, then the funding agency can stop the financing, then they can stop even your research. If suppose it's go to the more severity, then they can withhold your payment. And then if suppose this misconduct happens at the degree level, they can cancel your degree and terminate you from the job. So these are the consequences, or these are the punishments for the unethical things in a research. So the question comes out, if these are the punishment, then why one should put everything on a record? Because what happens if suppose you not put everything or your knowledge on a record or in a written record, then it will be lost. So there are certain examples. So first things comes out with the agenda and arrow. You can see the people at that time might be not knowing about the paper, ink, and color. So they put everything on a stone. So whatever knowledge was there, they put on a stone. So we can now assess their knowledge and we can try to understand how they were. After that comes out is painting of Mona Lisa. Mona Lisa might be the first painting of the world, may not be. So that comes out in 1503 to 6. So we could understand that people know the emotions at that time, even people know the color coding. Then the first scientific journal comes out in a market in 1665. So people start reporting their knowledge in form of journal. So I said why knowledge should be recorded. So if you look at these pictures, these ancient stained glasses markers know how to paint the color, paint these glasses using gold and silver, because they were using gold nanoparticles and silver nanoparticles of different size, and they were creating some pictures. If you look at this picture, is from Kerala. There is one church, old church, maybe around 16th century. So you can see there, you can find such a stained glasses. So our ancestors know the technology of preparing gold in a very fine particles, but it was not recorded. So now we are, most of the researchers are investing their valuable time to create gold nanoparticles, and the color which is actually gold, they try to make it in different colors. So just imagine if our ancestor would have put everything this on a record, then many of our researchers would have explored those ideas and put their ideas further level, and technology might have developed faster. But that not happened actually, because why? The knowledge was not reported. So everything should be recorded on a paper. Now these journals, once you accept the publications, then they will have impact factor. So what is definition of impact factor? It is nothing but scientific index that indicates the citations for the papers published in the particular year. So this impact factor was designed by Eigen, who founded the company called Institute of Scientific Information. And they start calculating impact factor since 1975 for the journals listed in journal citation reports. So impact factor will be, am I audible?
Audible, sir, audible.
Okay, because message comes out something. That's why I'm asking.
No, sir, audible.
Okay, thank you. So after that, ISI was acquired by Thomson Scientific and Healthcare in 1992, and then this ISI called as Thomson ISI. And recently in 2018, the Onyx and Bearings have occupied this institution, and they call it as a Clarivate. So how they calculate impact factor? So impact factor for year Y, if you consider, then they consider citation for last and last to last year plus publications in last and last to last year. So for example, if suppose you want to calculate impact factor in 2017, they consider citation for 16 and 15 as well as publications for 15 and 16. So this was the impact factor for general science in 2017. So if you want to publish your data in research paper, so you have to organize data in IMRAD format. What is it? I stands for introduction, M stands for method, R is for research, and D stands for discussion. But sometimes what happens, the methods needs to be correlated with research partially. So you can club R and M together. So these methods and results can be clubbed together, and then you can call it as a experimental section. After that, if suppose results needs to be discussed immediately, then results and discussion can be clubbed together. So this IMRAD format becomes IN plus R1 plus R1 plus R2, R1 plus D. So it's become IMRD simply. But nowadays you have to follow the general policies, which includes title, author, keywords, abstract, conclusion, acknowledgement, and finding as well. So apart from these IMRD, you have to consider this. So if you look at this actual structure of your paper, then first comes out to be title, which used to be brief details of your research topic, then abstract, which used to be nutshell, which brings those highlight of your major finding, then introduction, which indicates your problem importance, then known unknown facts, also your research questions and your hypothesis. If you are doing biological studies, then you have to cite your site, where you have done this study. Then you have to talk about methods. That means how you do it, what kind of instruments you have used, and what you have to give the justification for that. Then you can consider for results. That means how you find it and what you find. And then you have to discuss these results together. So you have to give the proper discussion for your hypothesis. Then you can put conclusion. Of course, conclusion and abstract cannot be same. So conclusion can just include your significance of the reasons. So you can discuss in detail over here. Then you can put acknowledgement and references according to the policy of journal. Even after doing all this work, you submit the paper to particular journal, and bad luckily what happens, you receive an email in your email box saying with the title, "We regret to inform you that your paper has been rejected," and you become sad. So that's quite common. So what are the reasons to reject the paper? First comes out to be a original work not found in your manuscript. That means somewhere it is copied from somewhere. So for journal, your work found unsound. That can be other reason. Third one is incorrect journal. That means you have not selected proper journal according to your research topic. So incorrect format. Nowadays you have to submit your manuscript in the proper format provided by the journal. Then incorrect type allocation. So let's consider you have selected all these proper 4 types properly, and when you submit the paper to the journal, they have subtype, you have not selected it properly. So that can be a reason to reject your paper. Next one is previous rejection. That means you submitted that paper to earlier somewhere in some journal, and that journal have rejected with certain comments, and you not given answers to those comments when you resubmit the paper. So that can be tracked easily by the editors. So previous rejection can cause the rejection one more time. Then slicing and duplication. So you put your results yourself in 2 different formats in 2 different manuscripts. So that called as a slicing and duplication. So if editor comes to know about slicing and duplication, then they can reject your paper. Plagiarism is another reason that if you copy more than 3 consecutive words or 4 consecutive words, that comes under plagiarism. So that can be a reason for rejection. Next one is unready work. That means you have not concluded your work properly and you submit it. So that can be reason of rejection again. And last one is English is so bad. It's unambiguous. That happens quite in India because we are not in a native English speaker country. So these are the 10 major reasons that paper gets rejected from scientific journals. So you have to follow good publication practice. So first thing is avoid misrepresentation or manipulation of research in publication. So publish accurate, complete, and clear and unbiased work. Avoid falsification, which can be manipulating research material, equipment, and processes. Also changing or omitting data or results, and image manipulation. So you have to avoid this. So data fabrication also you have to avoid. So make up-to-date data and results and record and report them properly. So this is most important. Next one is avoid fragmentary publication. So publish manuscript with presenting substantial findings. And then you can avoid duplication of your manuscript while submitting. So don't submit same manuscript at two different publishers. That's more important. And you have to consider a new contribution to the field while submitting the manuscript. And then collaboration issue always there, because as editor, we have received many comments from the collaborators that collaboration is not cited properly, contribution is not cited properly. So avoid these issues. And if you are going with honest errors or difference in opinion in a manuscript, then that will not consider as a research misconduct. That will be a proper ethical things to giving a honest errors in the manuscript. So what is manipulation of the publication? If you look at this picture, then you have upper and lower panel. What happens here is author keep a level command for a whole image, and then image is modified. So if you are giving whole level command to whole picture, then it is acceptable as an enhancement of the figure. But if you look at this figure, at this area particularly, the author has given the command, level command, only at certain level to enhance the quality of the figure. So this is not acceptable. So this is called as a manipulation of the figure. So please, you have to avoid this. And if you are doing this because of negligence, then you have to lead for the retraction. So this picture tells us what is meant by retraction. So this trained person was knowing that there is a wall and after that no track, but he dared to drive without track, and then accident happened. So this is what called as a retraction. So if you look at this picture, particularly in this paper is published in Nano Latest, which is very high impact factor. What the authors were talking, that chopstick like nanorods can be tuned and can be placed in a particular angle, and they can be in a pair form with high yield. So they give this paper in Nano later. But if you look at this particular things, this paper was retracted. Yes, so paper after publishing was retracted. So this paper published in 2013. So what was there? So if you look at this image particularly, this talks about putting two nanorods at 90 degrees. There are other images as well, which says that you can put these nanorods perfectly parallel to each other, perfectly perpendicular to each other, and perfectly aligning in one line, putting 180-degree angle. This paper was retracted because of the comment from one PhD student, what he observed. If you look at this particular area, which is zoomed over here, then the background was totally different. So these are the actual rods and this is the background. But if you look at along this line, these rods were selectively photoshopped and then they arranged this. So this is called as a manipulation of reasons. And because of this reason, the paper was retracted. You can see it is clearly visible over here. The background was totally different. So that means you are always in surveillance for the plagiarism, like you walking in a train path or you walking on a road and someone is watching on you. So editors are always watching you. So what is meant by plagiarism, or what is the duplication? If you look at this picture, this lady is writing something on a paper and this guy is copying. So if this is happening, this is called as a plagiarism. But this lady has put one more pen which is attached with the stick and the same is copied over here. This is called as self-plagiarism. So these two concepts comes out from National Academy of Press and IEEE policies. So both plagiarism and self-plagiarism is not acceptable in a scientific literature. But nowadays, copy and paste option, which is available in Word, late or tempted the young generation to copy paste and be in a plagiarism. So using Word and not writing always mislead for this. And this digital technology of copy paste is always tempting for this plagiarism. But what I afraid is internet may redefine the concept of authorship and singularity, because nowadays whatever published in a literature format in a scientific journal or anywhere is available on Wikipedia or easily available for file sharing and publishing. So in future, this concept of authorship and singularity is going to change. That's what I believe. So if you look at database for retracted papers, then till 2016, approximately total 946 papers are retracted. Out of that, the major retraction was because of fraud. That was 411, which is really higher. If you look at total publications retracted out of 10,000, then most of the time, every year, 5 to 4 papers are retracted per 10,000 publications. And the most of the retraction happens because of the plagiarism. So these are the countries till 2016 where more papers were retracted. Iran, 14 papers per 10,000 publications. And of course, we are not out of this list. We are there with 7.5 publications retracted out of 10,000 papers. So if you look at China, then between 2012 to 16, China retracted 276 publications. Of course, India is again in that list. But if you look at number of authors, more authors comes out from the Italy. Again, we are there, but our authors are less than 10. So as an editor, when we observe how many publications comes out from which country, then China used to be top, and then nowadays India used to be second. So to correlate how many papers are retracted between China and India, around 2010, approximately 1.5% retraction happens to be from China, and India was a little bit less. But by 2017, the China could manage for the retraction, but India not. Nowadays, India is on top. Even the percentage is less, and number of publications comes out in scientific journals from US are higher than China, and we are really very less in number. China publishes approximately 5 lakh publications per year, and we used to publish 1.5 lakhs, which is very less number. Out of that, around 0.04 publications are retracted from India, and US and China one less than that. But these retractions comes out from publication, plagiarism and image manipulation. So image copying, this is the best example of image copying across which I have come. So you can see this paper published by Yu et al. In 2006 in JPCB, and they given some idea about synthesis of Fe2O4 nanoparticles, and they published this XRD in that paper as a figure 3. Before that, other guy who is Park et al. So they published one paper on silicon nanoparticles in 2004 in Nature Materials. But this smart guy who is called Chung Yang Ma, he published these two figures in his paper in GPCC in 2007. So he copied as it is, just only change in the resolution. So this is called as a complete image copying case. So this paper has been retracted. So this indicates that sooner or later, if you violate the ethics, then your ethical violation will get exposed. So here are some famous examples. So if you look at this, there was very big news around 2002, that paper been retracted, right? This paper comes out from Science. This is from Nature, again from Science, published in 2000, 2001 and 1. So what they were talking, that they tailored the different properties, tailored the same properties of at different applications. So they use same material for different applications, and they can see that tuning is possible. But this paper was retracted because of one PhD student. What he observed, if you look at this axis, x-axis, this value starts from -4 to -10. Here, -1 to 2. Here again 1 to 2. But if you look at the error noise here, that noise is to be appear similar. It's impossible for any device, if you are preparing independently, the noise will never be similar. Then the student had a question how noise is similar, and because of this paper is retracted, which published in Science and Nature journal. Of course, as an Indian, we are not away from this. There is a famous example in 2008 from Sir Venkateswaraya University, where the faculty published a lot of papers, and out of that 70 publications were retracted from single faculty. What he did, he just cited number of instruments in his paper which were not available in the institute premises, not even in a university premises. So all papers of his were retracted. So in India, during 2005 to 2018, total 239 papers have been retracted. And out of that, 38 publications where foreign authors were involved. Total authors involved in this 200. So ethical misconduct happens out of these 239 publications, so 139, and then there were other scientific distortions and many things. 11, and then one paper retracted where the 663 authors were involved. So this is a very huge number, in fact, looking through the Indian population for the scientific community. So how journal track the public plagiarism? So if you look at this, this slide, then we have a plagiarism software associated with each journal. Sometimes we receive information from reviewers or some other editors, and sometimes authors or these readers of the journal let us know the plagiarism. So if journal track the plagiarism, then immediately they start process for withdrawing your publication, and then the authors will be banned. All the authors of this track publication will be banned for 3 to 5 years, and this information will be passed to co-authors as well as editors of the various journals, and then you will be always put in a watch list. So any publication submitted with your name will be always under watch list. So how we track exactly? So if you look at this page, these images from elsewhere where I'm working as editor. So I have hide some important message like manuscript number and whole title and author list because I cannot disclose those. So how we track? So once you submit the paper to the journal, then we used to have this option. So first comes out with the title. So first we check your publication. It's copied from somewhere. So we put your title in a PubMed and then we search. So you can see here, if your title is not matching with any of the publication, then the software will say there is no result found. Then we go with Scopus, search with Scopus, similar articles. Then all publications which are having similarity to your research publication will come. So we'll start selecting one by one and we check which paper has been copied in your paper. Then we go with again midline. There we search. So there if you find something, then we copied it. The most important thing here comes out is author search. So corresponding author search. So all your publications will be accessible for the editor. So this Scopus and editors author search will be a major task force for us. So after that, we will come to know where exactly we are copied from. So you can see this particular paper copied from the accepted papers as well as rejected papers, and some transfer papers also he has copied. Now the question comes out, how come we track the rejected paper being copied? What happens once we receive the paper for editing as an editor or for review, then we pass it to the reviewers. So what happens, the reviewer put this paper with them and they read out, and sometimes that reject the paper, and that same rejected paper, sometimes this reviewer copy in his own research article. So because of that, sometimes authors will not come to know, but editors will come to know easily because these rejected papers will be always in record of the journals. So here, the copying material being considered, and based on that, we can track your plagiarism. So these retracted updates can be daily available on retractionwatch.com, but retraction always takes 2 years of time for any publication. So if you want to go with Science Direct, then you can just put word retracted and you can find out all retracted papers altogether. So when we catch some authors and we ask the reason for this copying, because we cannot just identify retraction on our own and then we retract the paper, or plagiarism on our own and we ask authors to retract the paper. There are certain protocols needs to be followed. First thing is we have to inform the authors, the corresponding author and all other authors, that these things have been observed and please explain. So when we ask them to their explanation, then there are funny responses comes out. So first response we observe, I have no idea why this piece of similarity is being there. So this is quite surprising because paper has been written by the authors and submitted by the authors, and they didn't observe it. Then sometimes author says that I was not involved in this article. I have no idea why name is included. Just author raise his hand, say no, I was not involved. So sometimes they said this article was mainly done by my young fellow, and I'm not involved in this. And he has been died. How can we ask him? So this is quite funny. Sometimes author says that I'm not a native English speaker, so I do have a problem with my language to express the reasons. This is sometimes acceptable. Then they says that, to be honest, I was not aware of this fact, and they just raise the hand. And what surprises us that when we ask the first authors, which we usually used to be a research scholar, what they say is in their email, the corresponding author has been my teacher, and from whom I have learned many things. My respect for him was to utmost level until I found that he has been plagiarizing papers for all over the world. It's quite surprising that a PhD student is blaming his supervisor, right? That should not happen. So what needs to be done is research and publications needs to be ethical. So we have to know the ethics in research and publication. So to do that, we have to avoid the research misconduct. That means we have to avoid falsification, fabrication of data, and plagiarism. We have to stop issues with our collaborators. We have to give authorship to the collaborators. We have to give data ownership to them, and we have to learn the management. We have to trust on peer review system, as well as we have to late trust other. Then we have to declare the conflict of interest during the submission of paper. We have to avoid the complexity and with the funding agencies. We have, if you are doing biological research, then we have to be careful with the animal subject research, and we have to follow the guidelines for human subject research as well. So if you publish data and if you not cite it, that means it's remain dead publications, which we have to avoid. And then if you publish a lot of data which is not useful for society, then it's like a throwaway publication to the society. It's like a garbage. We are polluting online data and research ethics as well. So what helps to keep good record and avoid the unethical things is we have to always put accurate, accessible, and permanent data, which can be in the form of record. And this record should be sufficiently available and which can be rechecked again and again, because this retraction can happen at any time. So this you have to identify your work done and many things you have to consider. And then you have to consider the process of review. So that means we need the solution, and that we need right now to avoid this falsification of data, and we have to be ethical. So this is my research group, which having PhD student, master, and bachelor student as well. We have one research visiting fellow as well. So these are my international collaborations, comes from Taiwan, Korea, and of course South Korea and UK, and these are my funding agencies. Thank you. So this topic is open for the discussion.
Thank you, sir. Thank you, sir. As you can explain very well, synthesis, materials, and good work. How we can publish this good work in good publications and with good papers. Avoid research misconducts, high crime, punishments. As now, if we publish a good papers in publications with high impact factor, make plagiarism for this work, avoid unready works. Writing English is very good. Now these instructions are given is useful for all research scholars to explain or publish for in research papers in good papers. With these words, I would like to thank our distinguished resource person, Dr. Rupesh S. Dewan, for making excellent presentations and making this conference interesting and meaningful. Thank you, sir. Thank you, sir.
Thank you. Yeah, thank you very much.
Thank you. Now, we are moving towards the third session. Dear participants, it's my great pleasure to introduce you the Chief Resource Person, Dr. Rupesh Sirsagar, Assistant Professor, Discipline of Chemistry, Indian Institute of Technology, Indore. As far as teaching and research experience, he is postdoctoral research fellow, Ben Gurion University, Beersheba, Israel, from October 2011 to June 2013. He is DST Inspire faculty, CSR IICT Hyderabad, India, from June 2013 to May 2014. Next, DST Inspire Faculty, Department of Chemistry, Savitribai Phule University, Pune, from 2014 to January 2019. He has supervised 12 master students successfully, completed research project work from 2014 to 2019. 3 PhD students are registered and currently working. He is equally contributed in corporate life too. As invited talk and resource person, he has remained present in international, national and state level conferences. Really, we are fortunate enough to have resource person like him for conference. I hope that this presentation will be coherent, neat, dynamic and engaging. Now I request Honorable Dr. Umesh Sirsagar to start his topic, modern photochemistry using photocatalysis, a way towards green organic synthesis. Honorable Dr. Umesh Sirsagar, sir. Dr. Umesh Sirsagar, sir.
Hello.
Sir. Hello, sir.
Okay, thank you.
Okay, sir. Okay.
Thank you, sir, for your nice introduction for me.
Okay.
I'm really grateful that you have asked me to deliver the talk here in this talk. First, I would like to thank you all, your principal, your higher authorities, and organizing committee for conducting such events in this COVID-19 pandemic situation, so that transfer of the knowledge will not be hampered. Correct? So I really thank you for that. So with these short things, I would like to start the session for this lecture. Just as I'm trying to share my screen so that can you see my screen? Hello?
Yes, sir. Yes, sir. Yes, sir. It is visible.
Okay.
Yes, sir. It is visible.
Okay. Its name is coming. My son's name, Tanish Sagar. Actually, we are taking Zoom classes on his school. So we have login through his ID. I'm giving talk on his account only, so that my name is not there. But actually lectures is presenting by me only, not my son. So please bear with this name. I'm sorry.
Yes.
I don't know how to stop the video. He just Skype say. Just 1 minute, sir. Okay. Okay. Okay, so for today's talk, I have decided to give the talk on my interesting topic, that is which I'm working on that from last 5 years. I have decided to do the title of this talk as a modern photochemistry using photocatalysis, way towards green organic synthesis. In this talk, I will talk about some photochemistry. This is because synthetic manipulations that create new bonds like carbon-carbon bond or carbon heteroatom bonds are among the most important tasks as well as objective of the synthetic chemistry, because they enables the design of artificial chemical structures which are highly essential for the modern life. And traditionally for this, we call it as a organic reaction or reactions in chemistry language. So traditionally for this, nucleophilic or electrophilic reactions such as addition reaction, substitution reaction, elimination reaction, you might have heard these things, Grignard-Wittig or Friedel-Crafts reactions. These are the main pillar of these organic reactions. And majority of these reactions generally proceed through three main type of the mechanistic paths, such as first is ionic reaction. Second is concerted pathway, which can be done by the thermal or photochemical. And third way is the radical reactions, and this can be done by chemical method, or another is a photochemical method. In today's discussion, it is related to this third method, that is the reaction by the photochemical reactions, that is the radical reactions. In this discussion, we will see historical development of this photochemistry from its early stage photochemistry through then traditional, that is classical photochemistry, and then modern photochemistry, that is recently developed visible light mediated photochemistry. We will see importance of this field as well as their limitations, drawbacks. We will see their possible solutions and some further challenges. Let's start with the some basics concept of this field. What is meant by photochemistry? If you see basically the IUPAC definition of this photochemistry, it is a branch of chemistry that concerned with the chemical effects of light. That is, light interact with the molecule and initiate the chemical reaction, and some product will form. Generally, this term is used to describe a chemical reaction caused by absorption of light in the visible region or ultraviolet or IR region. Okay, so absorption of light in the form of photon promote the molecule to excited state, and this high energetic molecule transfer its energy or electron to the other molecule, and so that reaction occur. Of course, there are other fates of also this excited molecules, but we are mostly interested when it happened to transfer the electron or energy, thereby occurs the chemical reaction. Now, earliest form of the photochemistry is solar chemistry. All we know that, and this earliest form of the photochemistry as a photochemical transformation have been occurred on Earth since before the human life came into existence. Apart from that, if you see in the last 300 or 200 years ago, when scientists found out the concept of photosynthesis. Photosynthesis appear in the nature, which uses the solar energy. Plant uses the solar energy to convert the CO2 and H2 into the glucose and oxygen. If whatever we are seeing our eyes, that is vision, it is also initiated by the photochemical reactions of rhodospine. One of the important vitamin in our body, that is vitamin D. Formation of this vitamin D is also initiated by exposure to the sunlight. That is also involved in some photochemical reaction. And if you see treatment for the cancer, that is photodynamic therapy, is also involved the photochemistry, that is light is used to destroy the tumor cell. So photochemistry has a tremendous importance in human and modern life. Photochemistry has very old, crucial, and important historical background. However, interest in the synthetic photochemistry did not commence until the 18th century, when Siamicin, who is also called as the father of molecular photochemistry, in 1885, he first discovered the one synthetic transformation for the synthesis of hydroquinone from benzoquinone, and this reaction was carried out in presence of sunlight as an energy source. Of course, that time this reaction required the 5 months to complete. 5 months. Okay, although it required the 5 months to complete this reaction, Siamicin showed that the potential, he saw the potential for use of light as a future energy for mankind. Apart from this Siamicin, Alexander Sonnenberg, he's also the one of the initial contributor for this field. And both of these scientists discovered many organic reaction or reaction at that time using the sunlight as an energy source. Okay, and later on, why this is, sunlight is an inexhaustible energy source. Correct. The photochemical reaction proceed differently than thermal reaction, that is temperature driven reaction, and you can easily access the high energy intermediate that cannot be really easily generated using the thermal or temperature science, and so that you can easily overcome the large activation energy or barrier in short time, and that allows a reaction which are otherwise inaccessible by the thermal ways. Now let's see some development in this technology. If you can see the picture at the right top, it is a snap of Siamisin's laboratory in Italy, University of Bologna. It has all its reaction vessel outside of his lab. That is, he's doing all those reaction in sunlight. That's why all the reactions vessels were in the natural sunlight. He has to keep the outside of the lab. Although they have performed the various reaction, there are some drawbacks in this. We will see for the time outdoor photochemistry. Okay, we will require the lot of time. That is, it may require the days, weeks, or even months also. And it was associated with some risk of explosion if you do the reaction in containers, or if you do the open container, evaporation will be happen. And sometime there is a chances of reaction mixture gets lost due to some windstorm or other accident, because 5 months you cannot continuous 24 hours, you cannot stay outside of the your in front of your reaction vessel, correct? So that there are the many such drawbacks of this chemistry. Despite that drawbacks, these people have found out, investigated a lot of reaction that time. Mainly all majority of those reactions were solar reactions. Later in the half of the 20th century, photochemistry moved to indoor with the significant advance in lamp technology. So photochemistry moved to indoor and became the successful research area with larger reaction range. Okay, so later they have used advanced lamp which can generate the ultraviolet light. These are the some classical examples of photochemistry, photochemical transformation using the UV light done in past times. So, sorry. Over the last 4 or 5 decades, tremendous development in the synthetic organic chemistry have been observed. Example, transition metal catalyzed cross-coupling reactions such as Hake reaction, Suzuki reaction, or Nigesi reaction, Grubbs metathesis, and CH activation, and many more. Most of the discoveries even awarded by the Nobel Prize. This advancement or improvement reached the level that one might argue that almost any structure can be prepared from, whether it is small molecule, bioactive molecule, or in large molecule, complex natural product, or their analog. However, in the last 2 decades, the scientific community has changed its perspective about the way in which chemical reactions are evaluated. Today, the challenge is not only to synthesize particular compound or to develop the new synthetic method for the given transformation, but to perform it in practical, environmentally friendly, step and atom economic way. That is green chemical way. Okay, so nowadays challenge is when we are evaluating any reaction, how much green chemistry is involved in that. Green chemistry is a part of the chemistry that have certain principles, 12 principles. On that basis, we evaluate that reaction, such as less energy requirement, less waste generation, need the simple feedback of feedstock or starting material, use of the hazardous solvents, chemical, like this. So the concept of photochemistry as a green technology is over the 100 years old. And Siamisin in his chemistry congress in 1912 at New York delivered his remarkable views on the photochemistry of the future. I will not read that exact what he given in his talk in there. Just I will summarize in small, in which he clearly mentioned that in the future, chemical industries will be replaced with photochemical industries with the help of natural sunlight as an energy source. That is, solar chemistry would be the key component of future chemical industries. So green chemistry has a very long, photochemistry as a green chemistry is a very long relation. Although it has some green aspects, photochemistry has some drawbacks. Like if you see, before 10 years, very few research groups were involved in the photochemistry. And reason is that most of this photochemistry is involved the UV light. And if you see the sunlight photochemistry, that is solar photochemistry, which this CIME scene and those people were doing before the half century ago. That is sunlight. They required the high time. There are the explosion hazardous losing reaction mixtures like that. When this we are talking about the indoor chemistry, this chemistry required mostly UV light, but UV light is highly harmful light, required specially designed apparatus and light source to generate this. And most of the organic molecules, your reagent, your substrate, your solvents, your catalyst, everything will absorb the UV light, and so that you all those get excited, and so that there will be the uncontrolled reaction. Very side reaction will happen and will generate the many side products, and that's why lack of predictability of the product outcome always is there. And when you talk about the industrial scale of application of this photochemistry, another problem is that high running cost of this light source. Okay, and over the time these lamps get degenerate, so that is another contributor for the high cost. And because of all these reasons, photochemistry has a very little impact in the industry. And because of this reason, this photochemistry was not user friendly. Now, what is the solution for this? The solution is visible light. Instead of using the ultraviolet, we have to use the visible light, because if you see the solar spectrum, almost 43% of the part of this solar energy is visible light. So if you consider this visible light as an attractive reagent for the organic synthesis, you can see it is readily available, very clean, renewable. So we can definitely use it for the green synthesis. But another problem is that although it is abundant in nature, it is very difficult to harness, as most of the organic molecules do not absorb the visible light. If you see the same time, if you see the ultraviolet light, most of the organic molecule absorb the UV light, but most of the organic molecules do not absorb the visible light. That is a major problem. But instead of looking it as a negative point, if you see the positively, the solution is to use the photoredox catalysis. So solution for this ultraviolet photochemistry is visible light mediated photoredox catalysis. We'll see what is that in short. Visible light mediated photoredox catalysis is in this substrate. We are doing the reaction on the substrate in the presence of some photocatalyst. We are using some photocatalyst in which reaction will be mediated by the visible light. Of course, we have to use some acceptor and donor. We will talk about this, what is meant by this acceptor and donor shortly. And this reaction will give you product. It is relatively young and emerging field in organic synthesis that has recently delivered a variety of powerful bond forming reactions. Now, why visible light mediated photoredox catalysis? Recently, visible light mediated photoredox catalysis has received increasing attention as a potent synthetic technique to generate reactive intermediates and radicals that has opened the door to synthetically interesting, novel, as well as challenging reactions path, okay, that are difficult to perform otherwise. And the strength of photocatalysis lies in its ability to provide unique synthetic disconnections, allowing more efficient and straightforward routes under extremely mild condition. It has a very extreme mild condition. That is also one of the important aspects of green chemistry, with the very good functional group tolerance. And very important that it uses visible light, which is a highly non-toxic, waste-free, green and sustainable energy source. And most of the organic molecules do not absorb the visible light, which is very important factor that minimizes the potential for uncontrolled formation of organic radicals and thereby their side reaction, and provides the high degree of selectivity. So what is meant by photoredox catalyst? So it a photo means light, and redox is the simultaneously it undergo the oxidation and reduction. There are the three major types of photoredox catalyst which we are generally using. So one is a transition metal based polyphenol complexes such as ruthenium or iridium based or some other. Also here I have given some representative examples of this type of catalyst. Then of course you can use the organic dyes. There are some organic compounds, those can absorb the visible light. So these molecules also you can use as a catalyst. So these are the organic dyes. Generally, dyes has a very good UV maxima, or they can easily absorb the visible light. They have good conjugation. And apart from this, third type is the semiconductors. So evaluation of these light sources for the enhanced reactivity and scalability. If you see, earlier people were when this field started 10 to 15 years back, people are using household CFL bulbs for the energy source. Then some LED lights they have started. Then some advancement in high power LED lamps were available in the market, and now some industries also started preparing some specially designed photoreactors that also can be used here. Although some it increase the cost, but still you can use a LED ribbon. In my research lab, I'm using the LED ribbons. I'm just pasting those LED ribbons what we are using in the Diwali or those things in my that flower pot, and I'm putting the reaction vessel in that. So using such simple light source, you can perform your reactions. So photoredox catalysis, we'll see the simple mechanism of this, how it photocatalysis work. This photocatalyst absorbs the visible light in its ground state and generates an electronically excited state, which actually engage in the redox reaction by undergoing either oxidation or reduction, depending on the reaction condition. There are the two major scenarios. Excited photocatalyst react with the suitable sacrificial electron donor known as a reducing agent and undergo reaction which further transfer electron to substrate and facilitate the further reaction in turnover state. This path is a reductive quenching path. And another scenario is excited photocatalyst react with suitable sacrificial electron acceptor, that is oxidizing agent, and undergo oxidation, which transfer electron to substrate for further reaction and regenerate the catalyst. This is a oxidative quenching path. If you see the overall redox nature of this reaction, it is of the three type. One is a net oxidative reaction, which requires an external electron acceptor. You can also call it as oxygen. Another type is a net reductive reaction, which requires an external electron donor. We can say it reducing agent or reductant. And third is a net redox neutral reaction, which is slightly complicated than above these two types, as it either require both acceptor and donor both, or it does not require both. Okay, so these three people are pioneers of this modern visible light mediated photoredox catalysis. That is this Tae-Sik Yoon, David Macmillan, and Corey Stephenson. Of course, there are others also like Sanford, Nicewick, Koenigs, and Rupping. They also later on started working on this visible light mediated photoredox catalysis. We'll see some early examples before this. Actually, this work was these three people done after 2008 only. But before 2008, there were few examples where visible light was used as an energy source. One of the example very early known is in the 1978, which is a desulfurization was done using this Hans ester as a reducing agent in the ruthenium photocatalyst in the presence of visible light. Then in 1981, this Pack et al. Have performed the reduction of electron poor alkene using BNAH as a reducing oxidizing agent. Reducing agent for the reduction of this double bond. You can see the simple mechanism of this, in which this photocatalyst absorb the light, generate the excited catalyst. This excited catalyst oxidize this oxidizing agent and undergo the reduction, and this reduced catalyst will transfer the electron to this double bond and undergo the oxidation to give this ground state catalyst. And then once this substrate accept the electron, it will generate the negative charge here and one radical here. This negative charge will accept the hydrogen from this reducing agent or some reaction solvent to generate the this intermediate, and this intermediate again accept the another radical or hydrogen radical, and then accept the proton to give the reduced form of the product. This is the simple mechanism of this transformation. After this, in this early example in 1984, Deronizer has published the visible light mediated ruthenium photocatalyzed reaction for the intramolecular cyclation of this diazo compound. And after that, he also published the first example of photocatalytic oxidation of benzene alcohol using the diazo compound as an oxidizing agent in presence of the ruthenium as a photocatalyst and visible light as this one. In another example known in the 2004, that is a cycloaddition of anthracene and oxygen, which was done using the actinium, which is a organic molecule, and they have used this organic molecule as a photocatalyst and visible light as an energy source. But dramatic increase of the interest of this field attributed to the three key paper published during 2008 and 2009. Macmillan et al. Demonstrated that intramolecular 2+ he demonstrated that it is possible to merge the organocatalysis with the photoredox catalysis. In this, he showed the alpha alkylation of the carbonyl compounds using this organocatalyst plus he activated his substrate, that is this ketone, with the help of photocatalyst in the presence of visible light. He published this paper in 2008. Same time, this Yoon and co-workers published another paper using again photocatalyst and visible light, in which they have shown 2+2 cycloaddition reaction of dienes can be performed using the photocatalyst. And immediately after that, Stephenson also showed that dehalogenation can be done by the photoredox catalysis under the presence of visible light. These are the three important papers. After that, three people have investigated many more reactions using the visible light, and some other people also have shown some reactions. Just I'm talking about some one particular reactions. Type of reaction, that is formation of the iminium ion by the photoredox catalysis. Motivated by important role of nitrogen containing bioactive compounds, much attention has been given to the generation of amine radical cation via this photocatalytic single electron transfer, and they have used the tertiary amine as a substrate for this synthetic modification, because tertiary amines are a good electron donor and easily form the radical cation, and alpha CH bond alpha CH bond of this nitrogen has a very low dissociation energy, and that can easily undergo the deprotonation to produce the iminium ion here. If you see the mechanism, this photocatalyst undergo the excitation, and then it oxidizes this amine to this amine cation, and then easy breakup of this alpha CH bond happen catalytic this under this visible light mediated photoredox catalyzed condition to generate this iminium, and this iminium ion can be attacked by various nucleophiles. Okay, and many people have taken the advantage of this particular reaction by reacting with various nucleophiles. Some few of those nucleophiles I am showing here. So Stephenson then showed the Aza-Henry reaction using the photoredox catalyzed oxidative Aza reaction. Henry reaction is some other reaction, but he showed the application of photoredox catalyzed oxidative Aza Henry reaction. Later on, Strecker reaction was also performed using the photoredox catalyzed condition by Magnus Rupping et al. And of course, there are the other nucleophiles such as this butyrolactose and indole that can be also attached at this alpha position of the this tertiary amines compound. So apart from this nucleophile, they have also shown that carbon phosphorus bond also can be easily prepared using this under this visible light mediated photoredox catalyzed condition. Then this carbon-carbon bond by this ketone substrate or this acetylene can be attached easily, or CF relation can be also easily attached here on this tertiary amines very easily. CF3 molecules has a very good importance in the medicinal chemistry. Then Bruckert Koenig has shown the until now we have seen some transition metal based photoredox catalyst. Bruckert Koenig has shown that organic molecules such as eosin Y, they can also absorb the visible light. Very good conjugation they have, so they can easily absorb the visible light. And first time he shown that these molecules also can be used for the photoredox catalyzed reactions as a photoredox catalyst. And what are the reaction earlier people have done using the transition metal photoredox catalyst? He showed that those all reactions can be performed using the organic photoredox catalyst. That is, he used this organic dye, that is eosin Y. Later on, he showed the mild alternative to metal catalyzed or base promoted condition that allows the range of functional group that can be easily tolerated. So arylation of any heterocyclic molecule he has shown, in which you can see this eosin Y get excited to this excited catalyst by absorption of the visible light, and this excited catalyst undergo oxidation by reducing this diazo compound, giving this aromatic radical, and that will add on this heterocyclic moiety, and further oxidation will give this cation, and this aromatization give the desired products. These are some simple mechanisms of these reactions. Later on, he has shown this utilize this photochemistry in the classical CH activation reaction. CH activation reaction is also very important part of the reaction, and Stanford shown that for visible light mediated photoredox catalysis can be used in the CH activation also. We are also working on photoredox catalysis. Here I'm giving 2-3 slides on the work from our laboratory on this visible light mediated photoredox catalysis. We have developed eosin Y photoredox catalyzed oxidant and reducing free, that is a net redox neutral reaction for vicinal sulfonamation of the alkyne via radical cascade cyclation to construct 3-sulfonyl indol, which follows the reductive quenching path. In a substrate scope, you can see not only aryl or heteroaryl, but alkyl substituent also works in good to moderate yield. Whereas beside the aryl sulfonates, alkyl sulfonates also provide the desired product in moderate yield. So to have the mechanistic insight in this reaction, we have performed some series of control experiments where we have observed that both photocatalyst as well as visible light both are required for this reaction to occur, which indicate that the photoredox catalysis is operating in this reaction. In the presence of classical radical inhibitor or quenchers such as BHT or butylated hydroxy toluene or tempo, the formation of product was not observed. We suggest that radical is forming in the reaction, and this radical quencher immediately trap that radical so that they will stop happening the reaction. So we are not receiving the desired product in this condition, which suggests that radical are forming in the reaction. And to find out the overall redox outcome of this reaction, we have performed the various reactions in presence of external oxidizing agent and reducing agent. In all those reactions, we have not observed the formation of product. It suggests that reaction is having the net redox neutral path. That is, it requires either both, and either it does not require the oxidizing agent as well as reducing agent both. It means that itself your substrate or some of the intermediates are acting as the oxidizing agent and reducing agent. And on all this basis, we have suggested one mechanism for this reaction. And even we have ruled out the initial formation of nitrogen intermediate by like azide by photocatalysis. The reaction was carried out in the presence of alkene, so that if some nitrogen is forming, that will get trapped with that azide, but we have not received such product. That will also rule out the formation of nitrogen intermediate in the product. On this control experiment and some literature precedents, also we suggested this following this mechanism in which the reductive quenching cycle with the net redox neutral pathway. And plausible mechanism is like this. The one electron oxidation of this sulfonate ion by this excited photocatalyst provide the sulfur center sulfonyl radical, and with the reduction of this excited catalyst to this reduced form of the catalyst, the radioselective addition of this catalyst on this triple bond from this side provide this radical intermediate 6, and this intermediate upon intramolecular cyclation with this azide with the release of nitrogen give this nitrogen center radical intermediate 7, which oxidize this catalyst to give the ground set catalyst and give this nitrogen ion, and this ion can absorb the hydrogen from the reaction mixture or after the reaction quenching to give the desired product. This is a very simple mechanism for this reaction we have proposed. Apart from 3-sulfonyl indoles, 3-sulfonyl indoles are also the important important scaffold due to their potent biological activities in the very important intermediate or drug molecule, so that we have tried to get them by using the thiol instead of sodium sulfonate, and in order to get the desired product it required the oxidant. Here we use the ambient air as oxidant, and this was a net reductive reaction via the reductive quenching path. So we have prepared various compound using this method. You know the broad biological profile of the benzothiazepine, as well as aryl thiocyanate can be have the very good applications in the agrochemicals. So we decided to club these two molecules in together and synthesize this type of molecule using this visible light mediated photoredox catalysis, and we are used for this purpose this starting material, and ammonium thiocyanate adds a thiocyanate source, and in presence of eosin Y and oxygen using the blue light as a light source, we could get easily this product. You can see the simple mechanism. This thiocyanate undergo the single electron oxidation with this excited photocatalyst, and then this again radioselectively add on the triple bond, then intramolecular cyclation followed by giving this radical cation of sulfur radical cation, and its oxidation by this air oxygen provide the sulfur radical, and then breaking of the sulfur and methyl bond provide this desired product. So we have again synthesized various compound using this method. Our next target which we are working right now to generate the acyl radical is using this photoredox catalyzed under the visible light condition, and to react with this type of substrate to generate this type of antibiotic molecule. This is a raloxifene, this is an antibiotic molecule. And if we will be succeed in this, we will apply that for the another type of indole to acyl indole derivative. So this type of also molecule are important because they are present in various biologically active natural products. So here I have shown you some of my work in my laboratory. So I would like to conclude this talk here. So if you see the major benefits of the current progress on photoredox catalysis, it is very highly mild and environmentally friendly because we are using just visible light, and that's why we can go for the green approach for this synthesis. And apart from synthetic chemist, this visible light mediated photoredox catalyst is attracting the attention of researcher in drug discovery, chemical biology, even material science also. And merging of photoredox catalysis with other catalysis still serve as a driving force for innovation of the novel reactions. Of course, there are the very less examples in photochemistry which have been utilized for the asymmetric synthesis. So that will be the another challenge for future challenge for this visible light mediated photoredox catalyst. So asymmetric synthesis using visible light photoredox catalysis. And long-term goal are to continue to improve efficiency and utility, and to realize that long-standing goal of performing chemical synthesis using sunlight. I know still now we are unable to perform the reaction very efficiently using the sunlight. We are doing the although we are using the visible light, but we are using some visible light source, like I told you that CFL light, LED lights, those things we are using. But real challenge is that to perform the reactions in like a chemist in outdoor chemistry, that is using a natural sunlight, but in the very efficient way, in very less time, and with the less wastage or those things. So that will be real challenge in this field. With this conclusion, I would like to thank again all this organizing committee for inviting me for this talk, as well as I would like to thank all you for your patience and listening this topic.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.
You can enlighten on photochemistry, solar chemistry, development of chemistry, photoredox catalysis, dual catalysis, green approach, and your deep knowledge on this topic. So thank you, sir. A big thank to Dr. Umesh Sirsagar for giving an excellent coverage to this topic, modern photochemistry using photocatalysis, a way towards green organic synthesis. Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir. Now we are moving towards fourth session. I am pleased and honored to introduce our guest resource person, Dr. Arindam Ghosh, for today's event. He has been inspiration to everyone because of that he is hardworking and dedicated to his job. His career objective is to explore opportunity to work with active research group in reputed university institutes to enhance his knowledge, skill, and group in reputed expertise in the emerging fields of science and technology, and to strengthen the Indian economy by sharing his knowledge with the emerging minds and delivering qualitative education to them. He has career motivated, good adaptability, a self-starter, and a good team player with a keen eye for details. 6 years of multidisciplinary research experience and more than 3 years of teaching experience. Good experience of working on academic and research projects, hands-on experiences with modern material characterization and analytical tools. Developed low operating temperature metal oxide LPG gas sensor. He has the experience of tailoring the material properties with the help of sweet heavy ion, that is SHI irradiation. Now, he has total teaching experience of 7 years till the date, and total research experience excluding PhD, that is 1 year and 9 months. He is PhD research scholar from Department of Physics, Dr. Babasaheb Ambedkar University, Aurangabad. Research Associate, IIT Kharagpur, India. Now, he has got some awards and fellowship. CSR India Junior Research Fellowship, JRF, CSR Indian Senior Research Fellowship, SRF, Best Research Scholar Award in 2010 by NCL Research Foundation, DST Inspire Faculty Award in 2013. Really, we are fortunate enough to have resource person like him for such conference. I hope that his presence will be coherent, neat and dynamic and engaging. Now I request Dr. Arindam Ghosh to explain the topic, that is nanotechnology, a revolutionary technology.
First of all, good afternoon to all of you.
Good afternoon, sir.
Am I audible?
Audible, sir.
Okay. And can you see my presentation? My PPT is visible?
Yes, sir. Yeah, sir. Yeah.
Okay.
Visible, sir. It is visible.
First of all, I want to say thank you for the Vasantrao Nayak Arts, Commerce and Science College, Shahada, and the whole team for organizing such a beautiful conference in this pandemic. So, from morning till yet, we have heard a lot about the nanotechnology and the basic ideas and the what current research all the researchers are performing, and how to write a paper, and what should be the way of presentations. So in this topic, basically I want to discuss the total pathway of nanotechnology from the beginning till the date. Am I audible to all of you? Na? Am I audible to all of you? Hello?
Audible, sir, audible. Audible and visible
Yes.
also.
Okay.
Okay, sir. Okay.
So the plan of my talk, when nanotechnology began, what does the nanotechnology signifies, how it is prepared, and where the nanotechnology is used, and the current achievement of the nanotechnology. So the word nanotechnology comes into our mind from last few years. But but from where it begins its journey? It's a million dollar question. So the question comes into our mind whether the nanotechnology is new or it is a old technology. So let's see. As we know that the Maharashtra itself, it tells us the presence of nanotechnology from a last thousand of years before. We are very much familiar with the Ajanta and Ellora caves and its beautiful painting, which is also present as it is in front of you in my slide. The foreigners, they have a lot of pain in destroying the Indian sculpture, but they have burnt a lot. There, till the day, we have some sculptures, some paintings that are in front of us. But I want to say you something that this painting, whether they are representing something regarding the nanotechnology, yes, the answer is yes. Their colors, how the colors, they are also present just before 1000 or 2000 years. Because if we take a paintbrush and draw something, then it will take 1 to 2 years to get it discolored. But this 2000 years back painting, it is also alive today. How? And how it is so? That means in that previous age, basically they're using the leaves, the cow dungs, and all the things. These things, these can be used as a color. So this is nothing but the assembly of nano rods, nanotubes. So this is a great example of nanotechnology. So this is not the new thing. In 4th century, the lycragen glass, this is the glass made up of same material, but as the particle size or the grain size changes, their color is also going to get changed. In 19th to 17th century, the luster ceramic glasses, and in 16th to 15th centuries, the vibrant standing glasses, they are also representing the symbol of nanotechnology. And we have heard the sword of various kings. The sword of Tipu Sultan is also famous. And here it is also, this is the same image of a sword, historical sword. It also symbolizes the presence of nanotube. Why? That this technology, it is named recently the nanotechnology, but it is used from last thousand of years. In 1936, Erwin Muller, he has invented the field emission microscope. In 1947, the Barden and William, they're also working on the semiconductor transistors. And this is the image of it. And the size of the transistors are very, very high. And this image, they are also representing you the ruby gold. And as we can see, that if we can tailor the size of the material, then also the size of and the color is also going to get change. This, the size, they are also going to get change. And these, the transistors, this is this is the one kind of laptop or computer, you can say. It is taking almost a shape of a building, but now it is a thumb top, palm top, laptop, and all the things. They are familiar with, all of you are familiar, very much familiar with it. And in 1950s, the theory and the processing growth of colloidal material, this comes into account. And in 1951, the field emission microscope. In 1956, the molecular engineering with the help of nanotechnology comes into account. In 1958, the integrated circuit comes into account. And in my presentation, I also put up light on these things. So in 1959, just like this is a webinar or an international conference, the Feynman, Richard Feynman, the famous scientist, he has told there is a plenty of room at the bottom. This is very much well-known sentence to all of us, and this also gives us the birth of the nanotechnology. And after that, a lot of research work is going on under the curtain of the nanotechnology. So basically, what does the nanotechnology signifies? In order to represent the things, I want to represent you demonstrate a video. See, in this case, this is a billion of light years, and if you can go through it, the 1 million years of light, and this is into the spiral atoms. Then now it is local bubbles. Now as you magnify the things, then you are coming into the outer orbit of the cloud, and this is the inner drift planets. And like this way, now we are the outer planet in the solar cells, and if we are now into the near earth surface, and now we are into lunar orbit, we are into the earth surface, now into the planet of the moon. See here, the scale is also going to get changed. So if we can change the things, then we can easily see what is the effect of nanotechnology. So as you can see, this is a 10 centimeter range, and we are entering into the pupil of a human being. So now if you are coming into the 1 centimeter, then this is the pupil iris. Now if we are coming into the 1 millimeter range, then pupil retina we can see. And now if we can reduce the size, then we are into the 100 micrometer, then we can see the WBC. And in 10 micrometer, we can see the white blood cell. And then if we are into the 1 micrometer, then we are coming into the DNA, chromosomes. And now if we can see the chromosome tips, and in 100 nanometer level, we are now into the chromosome tips. And if we can also in 1 nanometer level, then we are coming into the inner side of the DNA. This is nothing but the group of atoms. And now this picometer, this, like this way, then we can, like this way, we can categorize in between the electrons. So till yet, I think the what is nanotechnology, it is clear to all of you, because we are all learned students, and sorry, we are all learned faculty members, and there are also some students I am expecting. That is why I am making this basic concept. So basically, this triangle, this is representing a chemistry of a material science. What does it mean? Basically, if we are, first of all, in first stage, it is the processing, and then after making the solutions, after making the treatment, we are going to get the microstructures, and then we are going into the properties. So from processing to microstructures, we have to take the help of chemistry, and from microstructures to properties, we have to take the help of physics. So being a material scientist, we have to very much familiar with the chemistry knowledge, as well as we are also mastered in physics all this. So this material science is nothing but the combined study of chemistry and physics. So in first stage, I am going to discuss about the processing of the nanomaterial. As we can see that, as we can see, as we can see that this nanomaterial, they are of two types. One is top down approach, and another one is bottom up approach. In top down approach, what is happening? Because we have to hammer the bulk material. That means if we are having a bulk material and if we hammer it, then we are dividing it into small fragments or the small particles. So this can be called as top down approach. And if we are considering the nucleation process, atoms and molecules, then the cluster is also going to get formed. And then if we are going to get from the nanostructured material, then like this way, in both the ways, in top down approach and in bottom up approach, we are going to get the nanomaterials. So basically, I want to discuss the enlighten the various type of deposition techniques. Basically, this thin film deposition technique, they are broadly classified into two categories: physical technique and the chemical technique. In physical technique, it is a vacuum techniques and the sputtering. Vacuum technique, resistive heating, RF sputtering, and the in sputtering, this much categories are there. And then chemical phase, the gaseous phase and liquid phase. In gaseous phase, CVD, laser CVD, PVD, plasma enhanced CVD, and in liquid phase, the chemical wet deposition, electrolysis, pyrolysis, and there are many more techniques are also there. Now, in our next technique, I am going to discuss with you regarding the, I am going to, wait a minute. Here,
yeah, sir. Yeah.
Okay. So
okay, clear, sir.
This is the chemical bar deposition technique, and this is, in this case, this is basically a beaker, and this is a substrate. Basically, whenever we are going to deposit a film, we have to deposit it onto the substrate, and then what we have to do, we have to do the reaction mechanism, and then the film, this brown color film, whatever we are going to get, and this is the thin film. And the modified chemical bar deposition technique is nothing but the successive ionic layer adsorption and reaction technique. What does it mean? Basically, it has four beakers. Cationic this is the cationic precursors. This is the H2O, deionized water. This is the anionic precursors, and this is also the H2O. And when this substrate they get into the cations, then what does it happen? The cations they get absorbed over here. The cations they get absorbed over here, and after that, when it is inserted into the H2O or the water, then the loosely bounded atoms they get removed from these things, and we are going to get a uniform layer of a film of the cationic layers. And when it is inserted into the anionic precursors, then we are also going to get a two type of layers. One is tightly bound and another one is loosely bound. When we insert it into the anionic precursors, when we insert it into the anionic precursors, then what is happening? The loosely anions they get removed out, and we are going to get a uniform deposition of the required film. And in this case, whatever we can see, this is the H2O. Sorry, this is the Zn plus O, and this is the zinc oxide thin film. Like this way, these are the various type of chemical techniques, and so this is all about the sealer technique. And in this chemical technique, basically it is a very cost effective technique, and large area deposition can be possible over it. And in the first lecture, as Dr. N.G. Deshpande have described you about the gas sensing unit, in this case, what does we require? We require a porous material, and in it, what that means as the porosity increases, the surface to volume ratio also get increases, and we are going to get a good gas sensing property. Now we are also looking into the physical technique. Now in this diagram, we are going to enlighten or highlight the basic principles of the physical techniques. What does it happen? Basically, this is the substrate holder, and here the substrate like quartz, crystals, and ITO and the glass substrate, they are inserted over here. And after that, this is the target material which is we have to deposit it, and this is the source of energy which is heat up the material. And in this vacuum, and in this case, this is a more important thing, that one vacuum technique is also there. And this vacuum technique, what does it do? It basically increases the mean free path, and it also produces a good quality film. It also produces a good quality film. So this is all about your basic principles of the physical technique. And there are various type of physical techniques are there. Here I have shown you some of them. One is physical vapor deposition, one is PLD, pulse laser deposition technique, ion beam deposition technique, etc., and many more. So in all of them, as I have discussed you previously, that in PVD, the thermal vapor evaporation is also used over here. In this case, IBD, ion beam, they are used as a source of energy, and PLD, the lasers, they are used as a source of energy. And after that, like this way, we are going to get a uniform thin film. So now basically till yet we have discussed about the various type of processing. Now we are basically concentrating on the microstructure and how it is applicable in case of some sort of properties according to our own requirement. So like this way, basically there are some properties are there. Basically the size dependent properties. What does it mean, size dependent properties? Basically, if we consider a bulk material, then the surface to volume ratio is less in comparison to if we divide it into n number of small particles, then surface to volume ratio get enhances. And like this way, there are various type of properties. They can also be get changed with the help of size. These are the chemical properties, thermal properties, mechanical properties, optical properties, electrical properties, magnetic properties, and many more. Like, and there are various type of experimental techniques are there in order to study the things. Basically, whenever I used to teach students the material science or the solid state physics, I used to say that you have to be into the crystals. So, but through our naked eye, we cannot see into that nano level. That is why we have to take various type of instruments like XPS, UPS, AES, SIMS, IPS, SCAR, and so more. Basically, with these techniques, we can use what is happening into the intermolecular phenomenon, intermolecular physics. So there is a lot of things we have to explain. And in various type of research institute like UGCDA, CSR, IITs, various type of IITs, Bhabha Atomic Research Center, IISER, and various research labs, various universities, they are also coming forward, and Indian government is also allowing us by providing various type of funds, and it is also boosting up in case of purchasing the instrument and pursue our research work. So we have to now, what we have to do, we have to only use our brains, and we have to find out the technologies, what is new in it and how it is working. So now in this part, I want to discuss you about the applications and various type of properties. Basically, this is one of my work. In this case, basically this is the whatever I've shown you, the successive ionic layer adsorption and reaction technique, and I have grown the zinc oxide using this technique, and we are going to get the cabbage leaf-like structure. As I have discussed you previously, or NG responder have discussed you previously, that for gas sensing purpose, the surface to volume ratio should be greater, and it also enable us in order to get room temperature gas sensors. And now, being a physicist, what we have to do, being a researcher, what we have to do, we have to develop some sort of model. And if we are trying to correlate this experimental work with the theoretical work, then this work can be greatly appreciated. And as Dr. Rupesh Devan has said, that this can be appreciated in good journals. And I also have a lot of response by this model. Here I am going to represent you the things. In this case, this leaf, this is a vertically cabbage leaf-like structure. If we are removing, we are only considering this is a symbolic representation of the gas, then what is happening when it is less than the operating temperature? Now you have to know what does it operating temperature means. That means this operating temperature signifies that at a particular temperature, the below that temperature, the gas sensor cannot work, and beyond that temperature, it starts working. And why it starts working? That this in oxygen atmosphere, in air atmosphere, in oxygen atmosphere, this oxygen gas, it is get absorbed onto the surface. It is get absorbed onto the surface. This is this Milky Way. This is representing the absorbed oxygen onto the surface. And after that it is attaining the operating temperature. And when just below the operating temperature, what would be there? Approaching towards the operating temperature, then what is we are inserting the C4 H2O and CO2, and this get this oxygen, whatever it get absorbed, and then the barrier height it reduces, and then it starts responding the LPG gas and we are going to get a good response as a electrical properties, because we are here going to get a free electron over it. So this is a total model. Like this way, we have to develop a model, and whoever is going to get a good representative model, he or she is going to get a good response over it, research work, and the citations is also going to get increased. Now, this picture, all of you are very much familiar with it. He is none other than the Spider-Man, and this is the glyco. And these insects, they easily can move into the vertical wall or any rough surfaces. But how they are working? Are they associated with any case of any kind of study of nanotechnology? Yes. This response was given by some research papers. And in this case, as we can see the rows of sticky leaves over here. And this is the same images of the things. And then in this case, we can see that this work like a air bubble, and it can easily stick onto it, and we are going to these insects get stuck to the wall. So so these are the various type of studies, and the similar type of things can be happen with that Spider-Man hand. And using this technology, the scientists, they have invented this type of robots, which can be very handy in case of our day-to-day life or applications point of view. So now we are going to discuss the various type of advancement in case of our in this case. So in this case, the nanobubble water, it is the National Institute of Advanced Industrial scientists and technology and Rio combinedly, they have developed nanobubble water, and it is what is the specialty of this water? Basically, there are two types of water we can see: the sweet water and the salted water. The sweet water, what does it signify? It signifies the water of the river or the water of the pond, and this the salted water, that means water of the sea. And the animals, the fish of salted water, they cannot live into the sweet water. The animal of sweet water or the fish of sweet water, they cannot live into the salted water. But these nanobubble water, these things can be used in case of both of the animals. That means both of the sweet water animal and the salted water animal, they can easily live into the same water, and this is the nanobubble water. This is things is invented into the researchers. The nano sensor probe. This is a great invention in case of a medical science, and this needle, it basically, what does it do? It may selectively develop a research group, and now what does it do? It target a material, and it basically tells you the possibility of cancer well before time, and this is also a very good invention in today's era. And this is also a great engineering of our biomaterials science. And as we can see that as the age goes on increasing, so the skin, it is not that much smooth, and we are going to get wrinkle over it. So this is the one kind of skin, and in this by these things we can easily use this type of skin in case of our inner part also, and this is also a biomaterial. It cannot be harmful for our body. And the as till yet we have heard about the solar energy and wind energy. Now I am going to introduce with one good energy. This is called as thermo power. MIT scientists have discovered this thermo power using the CNTs, and these things, it also gives you a new era in the field of field of energy resources. So this could also be a good example of it. And as Rupesh Devan sir all and previous discussions, we have seen about the green technology. Green technology also plays a very vital role in case of analyzing the various type of things. So combining all the things, we can say nanotechnology is not a science, it is a tool in order to explain various type of phenomenon. So at last, I want to say you that it is nothing but a black hole. A lot of things can be done with the help of nanotechnology. It only needs our patience and our concept understanding. So with these things, without taking much more time, I want to thank you all for your kind attention. Now this question is open for discussion. Please.
Thank you, sir. Thank you, sir.
Thank you, sir.
And sir, as you have explained very well how the nanotechnology is related with caves, historical places, historical models are related to nanotechnology. Now you explain different types of deposition techniques like CLR, CBD, different characterization techniques. These are what are the applications of this nano bubble water, as explained very well. Thank you, sir. I must mention our deep sense of appreciation, Dr. Arindam Ghosh, for his explanation of nanotechnology, a revolutionary technology. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you. Thank you very much.
Thank you.
Now, I over to Dr. S.M. Patil, sir.
Hello. Hello, thank you. Yes, sir. Hello, thank you all the key resource person of these technical sessions who have delivered very insightful and fruitful information about the nanotechnology and the correlate with the theme that the ethics and best practices in research in the field of nanoscience and nanotechnology. I express my deepest thanks to Professor Nishad Deshpande. Then I express my thanks to Dr. Rupesh Devan, Dr. Umesh Sagar, and Dr. Arindam Ghosh, who have very systematically deliberated on the issue, churn out the key factors, keeping in relevant terms with their topic. I hope their lecture, their talk will have definitely help our participants, research students, and all the stakeholders related with this conference directly and indirectly. Thank you, all of you, once again. Thank you. Thank you very much. I express that the technical session of the resource persons are over here by now. Up to this time, the various factors, various teachers, stakeholders associated with this conference, I pay my sincere thanks to all of them. Now it's a turn to move for the paper presentation. So many papers have been presented, abstracts have been presented for this conference. Among those, we have selected some 10 specimens as a representatively for the paper presentation, because the involvement of the research students, research scholars, and other stakeholders is most necessary for the fruitful outcome of the conference. Now it's a time for the paper presentation of some of the scholars who are going to turn or topic different issues on the related to nanoscience and nanotechnology. I request the first paper presenter, Sri Karthik Kumar, who his title of oral presentation is Nanobiosensor and Biotechnology. So I request Karthik Kumar, a paper presenter, to have a brief presentation in 10 minutes. In a brief. Over to Karthik Kumar. Sir, am I audible to you? Mr. Karthik Kumar. Am I audible? Sir, you are not audible to us. Am I audible to you? Sir, please unmute yourself so can we hear you properly. I request the paper presenter, Dr. Karthik Kumar, please unmute your device. Sir, you are not audible to us. Am I audible to you?
Am I audible now?
Yes, sir, you are now audible.
Okay, so I have one suggestion. Can you allow me to present the screen, sir? I'm gone.
Oh, yes, yes. So will you want to be a co-host? So our technical team has made you co-host. You can share your screen or PPT presentation on a given time. Okay?
Okay, sir. Okay, I'm ready.
8 + 2, sir. Okay, let us continue. Let us start.
Sir, but I have not given that option to share my screen. I can't get it. Please just again allow me to do it, sir. Can you please repeat it?
Yes, sir. You are a co-host now. Just see there. You are a co-host, so you can share the screen, your PPT. Our technical team has made you a co-host. Sir. Yes, yes. Now you can share your screen.
Sir, I'm sorry that I don't get that option in my mobile.
Yes, sir. There is a screen sharing option. Please look
Sir,
at the bottom.
I see that previously, sir, but I'm not availing with that option right now. Please just wait me for a single minute. I'll get it.
Yes, yes, yes. Take a time. Option. If you see at the bottom line, Mr. Karthik Kumar, you can see a green color option, share screen.
Yes, sir, I can see, but I have also used this app many times, sir, but I could not see the option screen share. It was one just before the N1.
Oh.
But right now,
at present, are you availing that option?
No, sir, no, I'm not availing that option right now.
So, can you make the presentation orally with the help of paper printout or any other things?
So just a minute, let me try with other options, just for a single minute.
Sure.
So can you see now?
Yes, sir. You are audible and you are visible both to us.
So I'm asking for a presentation.
Your presentation, no. You are visible and you are audible, but your presentation is not there. Your screen has not been shared.
So could you please make me the next one to present? Let me check it.
Sir, please minimize your PPT.
Sir, excuse me.
Sir, please minimize your PPT and make the screen sharing.
So that option screen sharing is only not available for me right now.
Oh,
why I'm doing
it means that screen sharing itself is not available to you.
Yes,
oh, how that's possible? Actually, in our screen, we have the option.
Sir, but just before 10 minutes, I saw that option in my phone that there is a screen sharing, but right now I can't get it.
So right now you are not getting it.
Yes, sir.
Sir, should we move to another participant so you can get the time to repair your screen or see what the technical
Okay, sir. Let
difficulty.
me do it to the next participant. Let them do.
Okay,
I can do it.
Okay, and if you correct yourself technically, then please communicate with us through message. Okay, so we can
Okay,
take
sir.
your turn. Okay.
Okay. Okay. Thank you very much.
Next one on. Dr. Pramod Kumar. Now, as there is some technical difficulty of screen sharing with Mr. Karthik Kumar, we are moving for the next presentation. Dr. Pramod Kumar, Department of Physics, Republic of South Africa. Dr. Pramod Kumar, am I audible to you? Dr. Pramod Kumar? Screen share. Yes, yes. You have shared your screen. Please unmute yourself. Dr. Pramod Kumar?
Yeah, it's fine, sir.
Yes. Am I audible?
Yeah.
Sir, your screen has been shared. You can start your presentation 8+2. Okay.
Okay, thank you very much.
Let's begin.
Sir, just I'm getting one problem. This screen is coming like every one people's screen is coming on my PPT. So how I can change? Okay, I know I'm
No,
getting
sir.
everything. Okay.
Yes, no, sir. Your PPT is okay. No issue.
Okay. First of all, thank you very much for giving me the opportunity to oral presentation on the one-day international conference that is basically on the ethical and quality aspect in nanoscience and nanotechnology. So for the short time period, I'm going to discuss about zinc doped rubidium nanostructure for photovoltaic applications. So this is basically my abstract. So we have prepared this rubidium doped zinc oxide nanostructure by well-known combustion method technique, and we have applied various technique like X-ray detection, photoluminescence, transmission electron microscope, time of flight, secondary mass spectroscopy, as well as XPS spectroscopy in order to employ the basic characterization of these materials. And as we know that there's a limited study related to our XPS like rubidium doped zinc oxide. So we have performed some like a Wagner plot with modified Auger parameter that basically investigate the chemical state of zinc oxide and zinc hydroxide that we have observed before and after doping with rubidium. And after that, we have discussed about the top sims that give the information about the homogeneous distribution of rubidium ions into zinc oxide. And we have performed like another additional phase of RB2 Gen2 phase at the outside of the surface of rubidium doped zinc oxide nanostructure. After that, we have used this material for like a photovoltaic applications that I'm going to discuss in the next. And this is basically my outline. So first of all, I'm going to discuss about zinc nanostructures and discuss about the fabrication technique, and I will discuss some result and discussion like optical absorption spectroscopy, PL, and I will discuss like a morphology by using TEM and SAM. Then I'm going to discuss about time of flight mass spectroscopy that we are seeing top sims, and after that I'm going to discuss about X-ray photoelectron spectroscopy. Then I'm going to discuss about the photocatalytic experiment of this material. Then I will conclude like my work. So as you know that first of all, I'm going to discuss about the zinc nanocomposites. But first of all, I'm going to give the overview about the photocatalytic activities of this zinc doped rubidium zinc oxide. So as we know that in the last few decades, the researchers, they are currently paying a lot of attention toward the environmental issues that created by the pesticide and different kind of the industrial influence, and that has emerged a global problem. Therefore, it is imperative to work towards the environmental issues. So for this case, it is worth noting that the untreated wastewater containing large amount of the organic as well as the inorganic compound, like right now a very serious problem for the developing country in the world. Therefore, it is a great challenge for the scientific community to check the water pollution level for the security of clean and safe water. So for the present presentation, I'm going to discuss about like a semiconductor photocatalyst that have facilitated the researcher for the last few decades due to their growing environmental problems. So for this study, we have used zinc nanostructure, and that is a versatile family of voltage and type semiconductor having like a exciton binding energy of 60 million electron volt at 300 Kelvin, like room temperature. So the appropriate band gap makes it promising photocatalytic for the removal of the water pollutant because due to its non-toxic effect, wide direct band gap, low cost, high photocatalytic activity, etc. So first of all, so I'm going to discuss this overview, and then I'm going to discuss about there are a lot of applications like solar cell, chemical sensor, and then photocatalyst. But basically this study we are going to discuss about like photocatalyst studies. And so first I'm going to discuss about the fabrication techniques. So we have applied like some combustion techniques. We have a top-down approach and bottom-up approach, but in the present scenario we have applied a combustion technique in order to synthesize rubidium doped zinc oxide nanostructures by combustion technique. And first of all, this combustion technique is a very old technique in order to prepare and different concentration of this rubidium nanostructures, and we have used like a zinc nitrate as a precursor and urea as a fuel for the synthesis of this zinc oxide nanostructures. Then after that, we have we have took the ratio of zinc nitrate urea and then dissolved in the like a some stoichiometric ratio in 2 to 7, and we have got a like a homogeneous solution. Then these prepared homogeneous solution we have transferred into the aluminum board and then annealed at 400 degrees Celsius for like a 20 minutes, and this reaction was done in open area, atmosphere. And it is worth noting that the urea acts as a reducing agent for the formation of the zinc oxide nanostructure during the thermal treatment. And we have incorporated different kind of like concentration of rubidium like 5, 7, 10, 15% using the same techniques. And final obtained powder we have annealed at 450 degrees Celsius for 1 hour in order to study the phase transition and its morphology studies. So sorry, yeah. After that, we have prepared the like our like a material. Then I'm going to discuss about the UV visible absorption spectroscopy, that we are going to tune the like a optical band of this material by doping with rubidium ions. So this picture clearly shows that the diffuse reflecting spectra of pure and rubidium doped Jadano sample measured in the wavelength of 250 degrees to 650 degrees Celsius in the using UV visible spectrometer. And we have observed a prominent peak below the 400 nanometers, which is basically associated with the deep band-to-band transition of zinc oxide. And furthermore, we have performed this UPS like ultraphoton spectroscopy in order to measure the valence band positions. And we have observed the band gap of our material of pure zinc oxide is 3.2. After that, after doping with rubidium, it was reduced up to 2.97 electron. And after that, we have measured this ultraphoton electron spectroscopy, and we have observed the valence band position of zinc oxide, and various concentration of rubidium were found to be 2.9, 3.1, 3.12, 3.48, 3.9 in case when we are doping with rubidium with various concentrations. And the corresponding conduction band position were calculating the subtracting respective value of band gaps, and we are getting minus 0.30 and 0.13 up to 0.22 respectively. After that, we have performed like a photoluminescence studies of our materials, and this is the photoluminescence study of pure zinc oxide, and this is the doping with RB concentration. And after that, we have discussed like energy level diagram. So this spectra, it can be clearly seen that the PL spectra we have performed to change the optical and photochemical response of pure and rubidium emission spectra with an excitation of 325 nanometers we have used. And the defects such as like a zinc interstellar surface oxygen could be determined by the PL emission spectra. And we in the present study we have deconvoluted our PL emission spectra into 4 peaks using Gaussian function for all the same samples. And the PL's emission spectra exhibit like a sharp ultraviolet emission observed at 3.2 electron volt, which is due to the like an NBE to electronic transition between the conduction band and the valence band near band emission. And the PL emission observed at the photon energy of 2.9 electron 2.9 electron due to the near band excitation emission. The emission was not consistent with all the sample. Therefore, the PL emission peaks at the photon energy of 2.35 to 2.5 are attributed due to the presence of the oxygen vacancy, which may be influenced by the surface defects. In addition to this, we have got like a orange band in the range of 1.95 to 2.16 electron volt, and a red emission in the range of 1.67 to the 1.85 that is observed for the sample due to the surface defects. And after that, we have performed this energy level diagram, and it can be clearly seen that the PL emission observed at the bottom of at the photon range of 2.9 to 3.2 electron volt, which is basically to a near band emission and excitation emission, while the PL emission 2.35 to 2.5, which is basically due to the oxygen vacancy observed in the sample after doping with rubidium. Apart from this, then PL range in the range of 1.67 to 2.16 electron has been due to the interstitial defects like interstitial zinc defect, interstitial oxygen vacancy that may be the observed in the sample. After that, we have discussed about the structural information by using like an X-ray diffraction technique, and it can be sorry. So this is the basically XRD pattern of pure zinc oxide structures, and we have performed like a different peaks of zinc oxide. But when we increase the concentration of rubidium, it can be clearly seen that the rubidium intensity of the sample is increasing when we increase the rubidium concentration in the zinc oxide nanostructure after doping with zinc oxide. So it can be clearly observed that when we dope Rb into zinc oxide, we have observed an additional phase of Rb2 ZnO2. That phase was interesting, increasing with increasing the concentration of the rubidium ions in the samples. So in the present study, then we have performed like our TEM, transmission electron microscope, and transmission electron microscope. We have seen a lot of particles that are uniformly like a spherical shaped nanoparticles agglomerated with each others, and that are found around 22 nanometers. When we increase the rubidium concentration, the size of nanometer increased up to 44 nanometers. So basically this we have observed here, and we have calculated the particle size, and the particle size has been increased up to 22 nanometers to 44 nanometers. After that, we have done like a scanning electron microscope, and scanning electron microscope we have clearly observed like the uniform non-size distribution of an agglomeration of spherical shaped nanoparticle that is clearly observed in the micrographs. And when we increase the concentration of Rb, the size of the rubidium zinc oxide is going to increase, and it can be clearly seen that this color mapping, and in sample zinc and oxygen both are present in our sample. After that we have performed top SIMS studies. That is very important study in the present scenario. And first of all, I am giving the overview about what is like a top SIMS. So as you know that the time of flight secondary ion mass spectroscopy is a very surface technique method that is widely used a pulse ion beam like a cesium, like a gallium cluster of gold and bismuth to remove the molecule from the surface, outermost surface of the sample, and the particle were removed from the atomic monolayer on the surface. So these particles are then accelerated to the constant kinetic energy and ejected into the flight tube. Then their mass is determined by the measuring the exact time at which they reach to the detector. So in the present study, it can be clearly seen that this figure shows the top SIMS images of the rubidium doped zinc oxide sample, and the overlay of overlay image of the rubidium with zinc oxide nanostructure, and it can be seen that the homogeneous distribution of the elements and the enrichment of Rb zinc oxide are also clear from this overlay. And this top SAM 3D image, this 3D image clearly shows that on the top of the surface, Rb2 Z2 was completely observed on the surface of these nanoparticles. And after that, we have performed like a XPS X-ray photoelectron spectroscopy to investigate the chemical properties of this material. So first we have to do the charge correction, and we have fixed the carbon position around 284.8 electron volt, and we did like a charge correction for all the higher reduction of the binding energy. And this is the
Dr. Pramod Kumar.
Yes, sir.
Dr. Pramod Kumar, please make the concluding remark as your time is over. It's a humble request to make a concluding remarks.
Okay, just give me 2 minutes. I will explain this expression. I'm going to discuss the result. So because this is most important here, like this is a zinc 2p spectra, and we have fit these peaks like 3 peaks, and the peak 1021 point electron we have assigned to the zinc oxide, and this peaks 1022 point for the zinc hydroxide, and 19.5 electron volt that is assigned to the impurities. And similar, we have fitted this zinc LLM peak, and we have fitted for the 3 peaks. After that, we have applied like a Wagner plot here. This is like a Wagner plot with modified as a parameter. So we have calculated the like a zinc LLM peak, and then we have calculated the like a binding energy of zinc 2p, and we have did the sum of like a kinetic energy plus binding energy, and we got like a modified OJ parameters in the case, and we have observed like the zinc oxide modified OJ parameter to 10.3 electron volt, and zinc hydroxide to 2009.7 electron volt. So this study basically comes from that in our sample. Basically, we have observed like a zinc oxide and zinc hydroxide. After that, we have performed like a relative concentration of like a rubidium and zinc oxide with respect to rubidium concentration. It can be clearly seen that the zinc oxide is going to reduce toward the bulk and the impurity, and zinc hydroxide, when we increase the concentration of rubidium, it is coming toward the surface. And after that, we have fitted the oxygen this rubidium spectra, and we have deconvoluted two peaks. First peak giving the information about RB, and second peak giving the information about RB2ZN2. And when we increase the concentration, and it will confirm that the RB2ZN2 phase is also going to increase.
Thank
so
you,
after
Dr.
that,
Sir.
I'm going to discuss about the photocatalytic activity of our material or samples. So the photocatalytic activity we have performed like a photocatalytic performance of pure zinc oxide and rubidium zinc oxide sample was investigated by using the degradation of rhodamine dye under the natural sunlight, and the experiment performed by sunlight between 11:30 to 2 o'clock in the daytime with the sunlight intensity of 80,000 to 85,000 like a lux, and we have used 20 milligram of the photocatalytics and dispersed into 20 ml of the 5 pico parts per million aqueous solution of rhodamine sample. Then we have did this solution like a reaction in the dark for the 30 minutes for the adsorption equilibrium. After that, we have calculated the adsorption and like a degradations, and it can be clearly observed in the our present scenario.
So
The the absorbance of when we did the reaction, the absorbance of our material that is going to reduce with increasing the like a time duration for the different in the presence of
Yes.
sunlight for the different time duration, and the
Dear Dr. Pramod Kumar.
Yes, sir.
Dear Doctor, yes, sir. Your research and your paper is a nice one, but we have a number of other participants. They are in line for oral presentation. It's a humble request to make a conclusion within 1 minute. You have taken already an extra time. Please.
Okay, so we have performed like a just that we have calculated the degradation, and we are getting the degradation of our sample like 4.3 to 12.9 electron volt when we increase the concentration, and we have got the correlation coefficient, and we have done like a recombination rate by using the photocurrent, but we have a short time of duration. I'm going to conclude my work. So in the present scenario, we have prepared like a zinc rubidium nanostructure by using combustion method, and we have confirmed the phase of RB2ZN2 with the help of the top seams and XPS and XRD. And the time study, we have get the agglomerate shape like nanoparticles, and the size of these nanoparticles increase with increase the RB concentration, and the band gap was tuning up to 3.9 to 2.97 after doping with RB, and we have performed like a PL, and we are getting the NS PL emissions with increasing the decolization of the electron hole pairs, and the dye degradation in the presence of pure zinc oxide was found to be 97% for like a rhodamine B, and 91 point for the TC was higher than for the rubidium sample. Thus, the present result significantly give the recombination rate of the electron hole pair and produced by the photon absorption and consolidate demolish the photocatalytic activity of the zinc oxide.
Thank you. Thank you, Dr. Pramod Kumar. Actually, you have taken a deep study in your research paper. On behalf of the organizing committee, I assure to all the participants that in the next attempt, we will give you the ample opportunity to present your presentation. By this time, I request all the participants on behalf of the committee that please stick your time 8+2, because the schedule should not be get prolonged. Thank you, Dr. Pramod Kumar, for your presentation.
Sorry, sir. Actually,
Now
I don't get more time to discuss.
Yes, sir. No. You have already taken 3 minutes more. The allotted time is, dear participants, the allotted time is 8+2. Please try to stick to your time. Now the next turn of paper presentation, oral presentation is Mr.
Hello.
Balaji Gop. Mr.
Hello.
Balaji Gop, are you audible? Am I audible to you?
Yeah, yes. Hello.
Yes, you are audible and visible, Mr. Balaji Gop. So are you going to share the screen?
Yeah, yes, sir.
Okay, take your time, and it's a once again humble request on behalf of the organizing committee that please stick your time 8+2.
Yes. Okay, sir. No issue.
Now it's 2:51. You could end by 3.301.
Yeah. I shared my screen, sir.
Yes, you are visible. Go
Is
on.
it okay?
Yes.
Yeah.
It's visible.
Yeah. Okay, sir. Yeah. Okay, sir. Thank you. So I will start my presentation. Welcome to all, first of all, in this my presentation and in this international conference. Now, myself Balaji Ego, and I am from Dayanand College, Solapur, and my study is based on the acoustics and molecular interaction study, and which is based on different solvent mixtures. And here, one of the synthesized organic compound which I have prepared in my lab, that is 2,4-dibromochalcone, and its IUPAC name that I have provided here on screen. You can just look at. And next to this, I will share my next slide. Now, look at this. Chalcones have different activities such as anti-inflammatory, anti-cancer, antifungal, antiviral. Now, chalcones are very important compounds. With the help of these different chalcones, means by different making substitutions at the ring of this chalcone, you can uh, change its different properties, means its activities you can study with the help of uh, its different antimicrobial antioxidant properties. Now here chalcones, its sources are mainly based on its major, it is nothing but the major classes of natural products with widespread distribution in fruits, vegetables, spices, tea. You will get its percentage. Now, naturally occurring chalcones and synthetic chalcones possess diverse range of biological activities that I have shown here in my slide. Now here, antibacterial, antioxidant activity, these are helpful uh, for to cure the different diseases, and all of you know about the anti-cancer property, and this is very important for our future. Again, anti-malarial, anti-inflammatory, anti-leishmanial activities are also shown by these compounds. So, by considering all these things, we can say that this is an important organic compound, means by making different substitutions at different positions, we can study their physical properties. And why we have studied these physical properties? Because these physical properties will tend us, means take us for the study of solvent, for the study of these organic compounds in solvent mixture. And when we study these compounds in solvent mixture for drug delivery, it is a very important way by which we can select a proper drug. Now here, 2,4-dibromochalcone, which I have prepared by this method, that is a mixture of 2,4-dibromoacetophenone I have taken, and with the benzaldehyde I have reacted this compound, means which I have stirred for 24 hours in the presence of strong base, or we can say the another base also we can use here, that is KOH, like that. Only the condition is that we have to use the strong base. And the product which I have got, which is I have recrystallized with the help of the solvent, that is ethanol, or instead of that solvent you can choose another solvent which is uh, familiar with this compound, means this compound should not be soluble in that case. And here the compound which I have prepared, I have uh, characterized with different parameters, that is IR, NMR, and GCMS data, which I have got, that I will represent with the help of screen share. Now, this one is the IR spectrum of compound. Now, in the IR spectrum of compound, you will notice that the stretch which I have got here at 691.07, this peak, and the peak which I have got in between 760 to 691. From that, we can say that the bromo which is present in my compound, which is detected, and this I have taken 3 times, means after starting the reaction and meanwhile in between the reaction and after the reaction, I have taken this spectrum, and by this stretch, this much stretch IR will show that there is a presence of what we can say the bromo which I have detected in this compound. And after this IR compound, I have taken another characterization parameters, that is NMR also, for the detection of uh, protons. Here I have characterized this compound with the help of NMR spectrum on in Solapur University, Solapur. And again, somewhat different characterizations which includes GCMS data, that is gas chromatography mass spectrum, and that spectra I have also taken, that I will share with the help of photo. Now, this is the GCMS data of the compound which we have prepared. Here, the mass, that is 287, which shows M+1 peak, by which its molecular formula can be verified, and different types of characterizations are also we have taken, that is antibacterial property also we have studied. Now, after that, the preparation of this compound, we have studied its physical parameters, which includes the ultrasonic velocity. And this ultrasonic velocity, which we have measured with the help of ultrasonic interferometer model FAT, that is methyl interferometer, which we have taken from New Delhi. And some viscosities are also measured with the help of Oswald viscometer, which is having accuracy of 0.002% and calibrated by double distilled water. Now, the densities of pure compounds and their solutions were measured accurately using 10 ml specific gravity bottle. These are the all experimental procedures which we have did in my laboratory. And after this, also we have taken different physical parameters here. So these are the some different acoustical parameters by which we have determined the different parameters, that is molecular interaction, that is the interaction between solute solvent and solvent solvent interactions, which we have detected by all these parameters, which includes adiabatic compressibility, intermolecular free path length, and again acoustical impedance. All these are the different parameters which by which we have studied the different acoustical parameters, means that acoustical parameters which derives, means which is the better solvent for the prepared organic compound, that we have seen with the help of different parameters. Again, they include some molar compressibility and polarizability constant. These parameters also helpful for the interaction study between solute and solvent molecules. Now, after that, I have collected some important data from ultrasonic interferometer, and here these are the results which I have got through the study. Now,
Mr.
the
Balaji
compound
sir,
which I have prepared. Yes, sir.
please take 2 minutes and make a concluding remarks. It's humble request.
Yes. Now these are the some different physical parameters, or we can also say acoustical parameters, because of the solvent mixtures we have used here. Now these are the different parameters: ultrasonic velocity, effective molecular weight, molar volume, Rao's molar sound velocity. By taking all these parameters, we can plot a graph, and by the nature of graph, we can say where the molecular interactions are more, and whether the given suitable solvent is suitable for that compound or not, we can conclude there. Now, the compound which we have prepared is having antibacterial property as well as anti-leishmanial as well as anti-cancer properties. All these parameters we have studied with the help of their testings in labs and on in zoological studies. Also, this is very important. And in different species, we have tested such type of compounds which I have prepared. Now these are the some different graphs. Due to the I have more slides to show, but here due to the lack of time, I will share some important slides only. Now here this graph shows us the relation between the ultrasonic velocity of 3 different temperatures. Now the prepared mixture, that is solvent mixtures. For that solvent mixtures, I have chosen an benzene and methanol. Means one of the solvent is polar and another one is non-polar. And at 3 different temperatures, I have studied the different acoustical parameters. Now we will move to our conclusion section because that one is the important, means where the application is there. So we will discuss. We will have different graphs also. Due to the lack of time, I will share some important slides from you. Now we will move to the result section. Now the decrease of this density ultrasonic velocity with the concentration, this will suggest that the cohesive forces is due to the powerful molecular interactions between the solid mixtures which we have used, while the decrease in these parameters with temperature indicates the cohesive forces are decreased. You all of us, we are familiar with the cohesive force and cohesive forces, and they are decreases due to the decrease in density and ultrasonic velocity, and that conclusions I have made with the help of graph. Now the intermolecular free path length is also observed to increase with temperature. This will suggest there is the presence of some solvent solute interactions. As in my this slide in tables, I have mentioned the different values of this free path length, and along with I have also mentioned graph. There you will get values. So in conclusion, I have mentioned just the highlighted points. Here, the increase in adiabatic compressibility might be due to the dissociation of solvent molecules around the solute molecules. Now, this will support the strong solvent-solute interactions, and the adiabatic compressibility beta of this solution, that is the mixture which we have used here, 2,4-dibromochalcone, is also found to decrease with concentration as with temperature if we study. Now we will move to the next part. Hello.
Dr. Balaji sir.
Yeah, yes sir.
Thank you for your oral presentation. You have taken a very painstaking effort, it seems, from your presentation and your conclusion. Our college and our team gives a very best of luck for your continuous research in the field of nanotechnology. But we have very shortage of time, therefore we are moving further once again. And I promise that on behalf of the committee, in the next time, you will give them ample time to present your presentation.
Yes, sir, sure.
Thank you being a part of with us, our conference. Thanks once again.
Thank you, sir. Thank you very much.
Now I request to the next participant, that is Mr. Kaustup Kumar Shukla.
Sir, good afternoon. Am I audible, sir?
Yes, sir, you are audible and you have shared your screen. Am I audible to you?
Yeah, yes, sir. Yes, sir. Yes, sir.
Mr. Shukla, sir, it's a very humble and kind request. Please take 8+2. Okay.
Yeah, yes, sir. Yes, sir. For sure, sir.
You have started your at just 4 p.m. Please end up to 3:15.
Yeah, for sure, sir. For sure, sir. Okay, a very good afternoon to all of you, and so this is the topic of my paper, and here actually I am going to highlight how the materials are useful for the different technology. And these are the different content. Because of time, just I want to tell the main part only. So first of all, actually, what is my topic or what I am going to discuss here is, nowadays that multidisciplinary is very much important. So we are going to do any kind of research which is useful for society. That is the main aim of any kind of research. That's why we are doing the research on a and that is for multi. Sir, it is showing something like admit. Okay, no issues. I am coming back. So here we are going to do some multi-disciplinary research. So I am going to use here, or presently I am doing in my research work, MEMS technology. So what is first of all MEMS technology? So it is a technology which is combining different kind of components like electronics, mechanical and electrical components, and all together we are making a device in a single chip, which is very much useful for sensing and actuation. And the properties of materials we are going to use here. That is the main theme of this. And for reference, I have given here example, like what is the example of macro, micro and nano. How nano is better than micro. So this is the one of the reason. Here gap is very smaller, around 60 nanometer, and here gap is larger. And what is the objective of my research? My research is, I am going to find out, or I am trying to find it, the biological behavior, mechanical behavior, as well as physical behavior. What are the applications I am going to use? So in environmental monitoring I am using, as well as healthcare and agriculture I am using my research work. So as we know, suppose we are considering a human being. So for every activities, we should have some kind of devices. So here using MEMS technology, I am trying to give some kind of real-time device, which is really helpful for body sensation or for improved sensitivity to find out the healthcare conditions and all. So these are the literature surveys. Because of time concern, I am going on. So here nanowires. So I am using nanowires using MEMS technology to identify different kind of disease. That is also using FET technology, means FET is there, field effect transistors. So why this technology is very much important? Because of some common properties like mechanical properties, thermal properties. So here I would like to highlight one mechanical sensing property. What is that mechanical sensing property? So right now I am using this property in my research work. So I have taken a problem of micro cantilever. So what is micro cantilever is, we can see here, it is the so this is the fixed in micro cantilever, and here it is the free end. So suppose these are the targets materials. So whenever we are going to use the micro cantilever, so using this target materials, what will happen is it will capture. So here we can design different kind of sensing materials. So that is the importance of different kind of materials in my research work. And there are 3 stages of the work in environmental monitoring. Second one is agriculture and healthcare. So why I am using the MEMS technology? Because MEMS can sense, I mean, movement, vibration, pressure and all. It is possible. It can think, means it can analyze, interpret and make decision. It can communicate. So it means it can send the informations and all, and it can act. It means it can transmit. And now one kind of discussion is there, why we are going for the MEMS, why not ICs itself we can go ahead. So the main reason is, we can see here, in case of MEMS technology, we have 3D complex structures, we have moving parts, biological, chemical and optical operations are possible using MEMS technology. So that is the beauty of this MEMS technology, and it is the advantage over ICs. So these are the few materials I have analyzed using console multiphysics software. Apart from that, tungsten is also there. I have analyzed silicon and all. Okay, so these are the fabrication steps which we can use. We have some fabrication labs like IIT Mumbai, ISC Bangalore. So we may use these steps. And here I have tried to make you to understand, these are the suppose analytes. So based on the, depending on the material layering, the particular analytes can be detected because of high sensitivity. This side it is a fixed end, this side it is a free end. So this will actually, it is a very sensitive. So what will happen means, easily it will capture the target. So proposed research means what is the proposed research through this technology is for environmental monitoring. The heart of this, the heart of this research is environmental monitoring, as well as it is very much useful for the agriculture. And of course, biomedical, it is always useful. And I have done some kind of analysis and simulation. And the next step of my work is actually we are going to modify the complex structure, since it is a moving part. And in MEMS, we can analyze, we can study about the moving parts. Okay, so these are the simulation I have done using COMSOL multiphysics. Okay, 5.3a software. So it is a multiphysics, and I am suggesting also to maximum the people, those who are working in chemistry and physics, they can use this software. So it will be very useful to analyze at least before fabrication. So I have used it, and since time is not there, otherwise I would have shown all the parts. But somehow here you can see this is the fixed end, and this is the here this is the sense. Because of some pressures and all, okay, it will be getting deflected. Okay, so here it is a fixed structure, and how it is getting deflected, various cases are there, but I cannot show you now here. Okay, so what is the conclusion of my project is, or what is the conclusion of my work is, I am trying to monitor the environment as well as healthcare using micro cantilever or using MEMS based devices. By using those devices, it is very easy to monitor the healthcare system. And nowadays, since nanotechnology is rapidly, it is growing, so we can take some of the concept from nanotechnology like nanowires, and we can take the nanotubes, and by using and by mixing this MEMS technology as well as nanotechnology, we may develop one kind of biosensors which will be really helpful for the people to monitor the health, as well as early detection is possible. Like cancer is there, so using MEMS technology, early detection is possible, like breast cancer or different kind of lungs cancer. Similarly, while we are going for environment monitoring, we can use as a gas sensor. Okay, so MEMS based gas sensor, it is very much useful. Similarly, using nanotechnology wires, we can go ahead for the water level detection, and these things are possible. So this is the main part of this, and I have analyzed the different kind of materials. So sensitivity of the materials also plays a vital role. So thank you so much for the opportunities, and if any queries are there, please, because time limit is there, so that's why I have concluded it very fast. So sir, if any question means I am here.
Thank you, Dr. Saab. As you have very well explained the importance of MEF's technology in the coming scenario, and especially it is mainly focused and related with biotechnology and agriculture. It's a challenging field nowadays. Our team, we hope very best of luck for you, your further research, and to find out a device which can cope and adjust with the ongoing pandemic. Our best wishes are with you. Thanks. We are very eager to hear you in detail, and we hope that we will meet you very soon, and where you can make the representation of all your device, your research and project. Thank you, Dr. Saab. Thank you once again.
Thank you, sir. Because of time limit, very, very briefly, I have explained it, sir. So I'm really sorry for it, because
nothing. Yeah, no. You have done a very fantastic research and useful research for mankind. Therefore, I promise you that in coming days we will meet you once again with the ample time and the ample representation.
Thank you, sir. Thank you so much. Thank you, sir. Thank you, sir.
Next one. Now I request the next participant, Tarannum Wahid Attar.
Good afternoon, sir. Sir, am I audible?
Yes, you are audible. Am I audible to you?
Yes, sir.
Are you going to share a screen?
Yes, sir. I've shared, sir.
Yes, you have shared it.
Yes,
ma'am,
sir.
it's a humble request. Please take
Yes, sir.
8+2.
Sir, shall I start?
Yes, let's begin.
Good afternoon to one and all. This is Dr. Tarannum Attar from GM Women Women's College, Bhiwandi. I'm head Department of Physics, and the college is affiliated to University of Mumbai. I've done my MPhil and PhD from Material Research Laboratory, BK Birla College, Kalyan, under the able guidance of Dr. Mahendra Khandpekar. My topic for today's discussion is synthesis and characterization of LAF3 NDHO nanoparticles for electrical and dielectric properties. These are the topics which I'll be covering during my presentation. When we talk about the introduction to lanthanide elements, these elements starts from La57 to lutetium-71 along with the chemically similar scandium and yttrium. These are the characteristics of lanthanides. Because of time constraint, I'm not discussing these characteristics in detail. This is the overview of our research. When we talk about lanthanide-based nanoparticles, the main question arises, why we have chosen these lanthanides to develop these nanoparticles. The research review tells us that these lanthanide-based nanoparticles, they are used as an efficient phosphor materials in fluorescent lamps, optical amplification, lasing, optical data storage, and chemical sensing. These water-soluble rare earth doped nanoparticles, they are used in biolabeling, drug delivery, and in two-photon microscope imaging. When we talk about the advantages of lanthanide-based nanoparticles, a few important properties to mention, again, because of the time constraint. These materials, these lanthanide-based nanoparticles, they have long fluorescent lifetime, they have high quantum efficiency, they have sharp and non-overlapping absorption and emission band, they have enhanced photostability, and one important property, they have very good light emission properties. So we have chosen these materials to synthesize our nanoparticles. There are various methods of synthesis of nanoparticles like co-precipitation method, thermal decomposition, hydrothermal synthesis, sol gel synthesis, sol gel processing, etc. We have synthesized these LAF3 NDHO nanoparticles by using microwave assisted technique, using deionized water as a solvent, and using co-precipitation method. The reaction in the slide shows the reactions which are taking place during the formation of the nanoparticles. The elemental analysis has been done by EDAX, and it shows the presence of lanthanum, fluorine, NDHO clearly. This is the XRD pattern what we got, and the diffraction peak positions are found to be in accordance with the JCPDS standard CAR 320483 of pure LF3. These dope crystals have been reported to show hexagonal crystal structure with phase group P3C1 with alpha is equal to beta is equal to 90 degrees and gamma is equal to 120 degrees. As we can see from the slide, the broadening of the diffraction peaks, we can conclude that the synthesized nanoparticles, they have good crystallinity. The low intensity peaks in the XRD pattern confirm the presence of ligands attached on the surface of the synthesized nanoparticles. Next slide shows the particle size from XRD. The particle size has been estimated by D by Scherer relation, which is D is equal to K lambda by B cos of theta, using the strongest peak 111 at 2 theta, and it was found to be 12.54 nanometer, which is in agreement with the JCPDS standard CAR 320483 of pure hexagonal LF3 crystals. The particle size and the shape of the next slide is particle size. This slide shows the particle size and the shape of the synthesized nanoparticles and the comparison is made with the already available references. As we can see, the first row is our material and the succeeding rows are showing the already existing references. We can see that the particle size and shape is very much matching with the already available data. These are the TEM images, and the particle size obtained from the TEM studies was 15 nanometer. Next slide, we have selected area electron diffraction pattern, and we can see that the presence of large number of diffraction rings corresponding to 221, 113, 111, 110, 006, 223 reflections, they indicate the better crystallinity in the synthesized nanocrystals. These are the same images. The morphology of the synthesized nanoparticles was observed by same images, and it was found that well separated and uniform distribution of nanocrystals with traces of white agglomerates we can see clearly. So this is the overview of our research. We have synthesized lanthanum fluoride LFNH nanoparticles by co-precipitation method. For structural characterization, we have used XRD, EDAX, TEM, STEM, and FTR. For biological properties, to study biological properties, we have used various techniques like UV visible spectra, PL spectra, NLO test. In search of possible biomedical applications, we have made an attempt to study the antimicrobial properties, the antioxidant properties, the cytotoxicity, and the mosquito larvicidal activity of the synthesized nanoparticles. Today, I will be focusing only on electrical and dielectric properties. So this is a diagram for this is the instrument Hioki 353250 LCR meter, which has been used for resistivity and conductivity measurement. The conductivity was measured by using the formula P by RA, and it was found that the conductivity of the synthesized sample was found to be 0.588 into 10⁻³ per ohm centimeter. If we talk about the ionic conductivity, the ionic conductivity exists in LaF3 samples due to fluorine ions, as well as the ions on the surface of LaF3 NDHO nanoparticles due to doping. The ionic conductivity of pure LaF3 is of the order of 10 to minus 6 per ohm centimeter, where in our case, in our synthesized sample, the conductivity was found to be of the order of 10 to minus 3 per ohm centimeter. So we can conclude that the conductivity, the ionic conductivity is enhanced by doping the material, by doping LaF3 with lanthanides. That means the ionic conductivity is enhanced. The resistivity is found to be 1700.68 ohm centimeter. So we can conclude, this is the conclusion what I said, by doping the LaF3, the conductivity is enhanced. Then these are the dielectric measurements. For dielectric measurements, we have measured dielectric constant epsilon dash, dielectric loss epsilon double dash, and tangent loss factor, that is 10 delta. LCR, again, the LCR meter is used to measure the capacitance of the sample in the frequency range 100 Hertz to 5 megahertz. And it has been observed that when we plot the graph of epsilon dash and epsilon double dash versus log of S, it has been found that there is exponential decrease in both the parameters with the increase in the frequency, which is a normal behavior of the dielectric materials as the dipoles lag behind in orientation proposed by dpi. The next slide is log of epsilon double dash versus log of S. The graph shows almost linear behavior. We can see that almost linear behavior with slope equal to minus 1.038 using linear fit. The value of the slope near unity indicates that the DC conduction is dominant due to the space charge effect in the synthesized sample. This is the graph of 10 delta versus log of S. As we can see, at low frequency, 10 delta is constant. As the frequency increases, 10 delta decreases, following the same trend as a decrease in capacitance. Maximum 10 delta value in the low frequency range indicates contribution of the real dielectric constant of the material due to polarization. Now, the conclusion of our study is we have synthesized new rare earth dope lanthanum fluoride multifunction nanoparticles with enhanced properties for luminescent, biological, electrical, and dielectric applications. Hexagonal shape and particle size of 15 nanometer is in near agreement with the TEM and XRD studies. Dope LaF3 nanocrystals can be used as a dielectric medium. Also, there are reports on the use of LaF3 as thin film oxygen detectors. So this part can be extended for the development of LaF3 sensors in future. These are the future prospects where lanthanide-based nanomaterials can be used. These are the references which I have used during my presentation. This is the patent published. We have already filed and published patent with these details, and we are waiting for patent to be granted. Thank you all. Sir, am I audible? Hello?
Yes, ma'am, you are audible
Sir,
to us. Ma'am, thank you very much. Thank you very much.
Yes, sir.
And on looking the quality of your research, we hope that the patent which are in line, we hope very soon you will get the sanction because of its qualitative work and various
Thank you,
applicability.
sir. Thank you very much, sir, for your
We hope-
wishes. I'm thankful to the organizing committee. I'm thankful to the organizing committee, especially Bagul sir, for providing me an opportunity to be a part of this international e-conference. Thank you. Thank you very much.
Thank you. We also thankful on behalf of the organizing committee that the really good participant and research scholars are being a part of our conference. Thank you. Thank you very much, ma'am.
Thank you very much, sir.
Now I request the next participant, Karthik Kumar, for the oral presentation. I request Mr. Karthik Kumar be log in and be online for oral presentation. Mr. Karthik Kumar, am I audible to you? Mr. Karthik Kumar.
Sir, hello.
Am I audible to you?
Yes, sir. Am I audible to you, sir?
Yes, you are audible. And have you got the option of screen sharing?
Yes, I got, but again I was failing to get that option for screen sharing.
So you are going to present orally?
So just a single minute, sir. Let me correct it. Just 1 minute.
Okay.
Sir, can you see the screen? Sir?
No, the screen hasn't been shared, but you are audible and visible to us.
Sir, the host disability attended screen sharing. It's coming, sir. Can you please enable it?
Enable. This is sir. Enable kara. Now you are co-host now, Mr. Karthik Kumar. You can share the screen. Have you got the option?
Sir, no, I can.
Actually, you are a co-host now. You can control the
Yes,
screen.
sir, I can go. I'm a host, but I didn't get even that option in my phone.
So
That's more.
Mr. Karthik Kumar, are you able to deliver your lecture without a screen sharing?
Sir, yes, I'm available. Are you comfortable with it? What I don't know. So
Yes, we
can I
are.
do
You
it
are.
last? Can I try it?
The most fortunate is that you are both visible and audible to us. So if you can share your talk with us without the screen sharing. Mr. Karthik, sir.
Sir, just a single minute. It is uploading, sir. Just a minute.
Okay, it's uploading. So have you got the button of the screen sharing?
No. That there. So okay, let me just present it orally without the presentation, sir.
Yes. You are both visible and audible to us. You can make the presentation orally.
Okay. So, very good afternoon to all. I'm Karthik Ma, studying second year in Government College of Technology, Coimbatore. Today, I'm going to present the topic nano biosensor. A biosensor is just an analytical tool used to analyze the composition, structure, and function of the analyte in given sample. It was first designed by Professor Clark and Lyons. They have immobilized the glucose oxidase on the amperometric oxygen electrode surface with semi-permeable dialysis membrane in order to quantify the glucose concentration in the sample given. So by doing so, they have described how to make the electrochemical sensors much intelligent by adding enzyme transducers with them. The principle on which the biosensor works is that the analyte bind to the biorecognition element. This changes is detected by the transducer and the signal is produced and the signal is converted into the useful information. This is the main principle on which it works. There are four major components of the biosensor. They are the analyte, biorecognition element, transducer, and display. The first, analyte. Analyte is the substance need to be analyzed or measured. Biorecognition element is the element that must be biosensitive and also it must be in complement with the analyte. It should produce some reactions with analyte. So it should be complement with it, such as enzyme for substrate, DNA probe for DNA, antibody for antigen, such wise. Next, the third one is transducer. Transducer is the most important and used to convert biochemical signals resulting from the reaction of analyte and the bioreceptor and convert it into the electrical signal. This electrical signal is amplified and converted into a number in the display units. There are many types of biosensors such as optical biosensors, calorimetric biosensors, potentiometric biosensors, and electrochemical biosensors, which works differently based on the type of transducer with the basic principles of light, heat, current, potentiometry, impedance, and etc. The most important one is the amperometric glucobiosensor, which most of us are using in day-to-day life to check the blood glucose level in our blood. It works on a simple principle that glucose is oxidized by molecular oxygen into glucolactonate and hydrogen peroxide in presence of the enzyme glucose oxidase. So by just we can easily calculate the number of the glucose molecule present in the blood sample in the way that the hydrogen peroxide oxidizes at the platinum electrode in the device. This platinum electrode, this number of electrons transferring is directly proportional to it. We can easily monitor it. But by using the biological components and the platinum electrode in a normal way, it is a very big and complicated design. But by using the carbon nanotubes, which has the excellent mechanical strength, high surface area, excellent electrical conductivity, and electrochemical stability, they act as the ideal material for the biosensor device. Also, they are due to the hollow structure of the carbon nanotube, they absorbs the enzymes very easily. So now let's discuss how to prepare the carbon nanotube modified amperometric biosensor. So just we know the normal way to grow the CNT. Let's grow the CNT and convert them into the CNT electrode and also purify it. Now just deposit the platinum nanoparticles in the electrode. Now the platinum CNT electrode is ready, and then immobilize the glucose oxidase on this electrode by immersing this electrode in the glucose oxidase enzymatic solution for at least 12 hours. After completing this process, now we are ready with the glucose oxidase platinum CNT electrode, which is very useful for the biosensor. The biosensor with this CNT has the electrocatalytic effect and faster electron transfer rates. Such biosensor can effectively perform the selective and electrochemical analysis of the glucose. They are also capable of avoiding the overlapping of the signals, which causes the disturbance to the amplifications. And they also eliminate the need for the semi-permeable barriers, which was used in earlier decades, and then now simplifying the designs and the fabrication of these biosensors. And this carbon nanotube enhanced the usage of the biosensor not only to test glucose in the blood, but they have also taken us to next level by concentrating the glucose in saliva, sweat, urine, and serum. But also there are few disadvantages that the production of the carbon nanotube is too high, and it also hard to purify it for this usages, and also it causes some changes to the DNA and maybe applications. There is no is a multi-role in the multiple fields, especially it plays an important role in the healthcare checking and the diagnosis processes, and especially in cancer technology they do vital role, and also in insulin treatments. And in agriculture it is used to analyze the nutrient present in the soil, and also the pesticides and other weedicides to be used in the soil without spoiling the fertility of the soil. And also in the ecological pollution control it plays an important role. It can perform all the bioremediations and and biomagnifications, etc. The most emerging trends now, the studies has been made to use this for the multi-sensing system of homeland security. It can sense the high explosives nearby it, so it is very useful. And now it is also used for the wellness of the humans. We all know smart watches, smartphones, etc. By just keeping some chips in our body, we can monitor our body conditions, health, and everything. Now, to the current situation, we can see that the world is facing a high pandemic COVID-19, but this nano biosensor also came for the help. That now the researchers has been developed, and biosensor has been designed that it could specifically detect the SARS coronavirus 2, which causes the COVID-19. In the commercial development, it is undergone. For in future, we can get the biosensor which can be employed in the hospital, train station, laboratories, more and also more crowding places in order to combat the spread of COVID-19 pandemic. So this biosensor is very useful and also the very important one and ready to life. Sir, hello. Hello.
Hello, Mr. Karthik Kumar.
Yes, sir, I am complete.
Have you completed?
Yes, sir, I am complete. Any queries, sir?
Before to proceed further, I would like to say that you are a student, but the quality of the research you presented and your hard determined work, although some technical problems appear before you, but you didn't show any, you didn't discourage by it, and you showed very strong courage, and the quality of the research work you showed, I am fully confident that you have the good potential ability to being a good scientist, good research students. Our team, our college, our management has a very best of luck for you. Because Jayan, most important, although there are some technical problems, but you completed your presentation orally. That's too far better for you. Thank you very much, our team, and we are very fully impressed by your such an attempt, your determination to being a good research student and good scientist. Thank you very much. We are very enlightened that a student like you are being a part of our international conference. Thank you, Mr. Karthik Kumar. Thank you very much.
Thank you very much for your kind words, sir.
No,
also, I
kind
would like to
words.
congratulate those who present before me and all the best to others.
Yes, yes, it's our observation. Okay, thank you very much. Now, I request the next participant, Tulika P. Sinha.
Yes, sir. Hello.
Ma'am, am I audible to you?
Yes, sir.
Okay, you are both visible and audible to us. Please, let's begin your oral presentation, and it's a humble and kind request. Stick to the time 8+2.
Yes, sir. Sir, actually, I guess there should be an option to share screen. After share screen should come, right?
Yes, yes. You are a co-host. You can share the screen. At the bottom, you can see in a green color screen sharing option.
But the thing is, there is no screen share. So can I just show you the PPT through my camera?
Yes, yes, you can do anything for 10 minutes.
Yeah, thank you, sir. Just a second.
Oh, screen sharing cover होत नाही त्यांचं.
Yeah, is my PPT visible?
Yes, it's visible, ma'am.
Yeah, just a minute. So, good afternoon, everyone.
Good afternoon.
I'm Ms. Tulika Sinha, an FYBSc student from NES Ratnam College. And I'm extremely sorry, there's some technical issues. Just 1 more minute, let me fix my camera, otherwise it will keep on disturbing. I hope that's better now.
Ma'am, your screen sharing is far better than actual sharing. Don't worry.
Thank you.
Go on.
Yeah. Okay, so today basically I shall be speaking about the project on which we are currently working on. So we are working on the photocatalytic properties of chemically synthesized TiO2 nanoparticles, and we have analyzed the effect of annealing and pH variation during the synthesis process and correspondingly observe the photodegradation of methyl orange with the same. And as per reports, it is seen that in the textile sector, about 10 to 50% of the dyes that are used is directly wasted in the effluents and then down into the water body. So the pollution in this particular case is very apparent. And the more biggest problem is with these dyes that they are complex organic molecules, and so treating them by the conventional wastewater management process is not that sufficient. Hence, we need a different technology to purify the textile effluents. It is proved that the advanced oxidation chemical process is most efficient and cost-effective process for this particular case. And hence, our objective is to synthesize TiO2 nanoparticles in order to purify industrial textile effluents that consist of the organic pollutants. So this advanced oxidation process consists of this 5 other processes, of which we have majorly focused on photocatalysis with titanium dioxide under UV radiation. So why photocatalysis? To begin with, the process is eco-friendly and complete degradation can be obtained. The organic pollutants are broken down into carbon dioxide and water, thus needing no further disposal process. Also, photocatalysts are economically cheap and can be recycled, possessing no harm to the environment. A photocatalyst needs to have this certain characteristics. Yeah. So the certain characteristics are needed, and TiO2 is the most preferred photocatalyst as it meets all the requirements. There are many methods for synthesis, but we have followed sol gel method since it can be carried out in simple apparatus, and the TiO2 powders with desired properties we are successfully able to produce. All right, so this is our ideal procedure that we have followed. Firstly, appropriate proportion of ethanol is added to the titanium precursor and then it is kept for stirring for an hour. After 1 hour, a freshly prepared mixture of H2O, ethanol and HNO3 is added. Now this HNO3 is cautiously added in order to maintain the desired pH. Since we obtained the best result at pH 1, it's our ideal pH. After 4 hours of stirring, the solution prepared is kept at rest. With 24 hours of aging, the process of washing and drying at 120 degrees Celsius is carried out. So as shown in the image at bottom left, after drying we obtain such crystal-like particles, and these crystals are then crushed into fine powder and annealed. We found that annealing at 450 degrees Celsius produced the best results, and in this manner we produced our TiO2 nanoparticle photocatalyst. Okay, so this is the pH variation which I said about we had carried out. So this is the graphical representation of the photocatalytic degradation against time obtained by the TiO2 samples with different pH. It's seen that the photocatalyst with pH 1 shows better degradation. Annealing has a very significant role in this entire process. Annealing temperature decides the phase of the titanium dioxide that shall be formed. Annealing beyond 450 degrees Celsius leads to the formation of rutile phase. So at exact 450 degrees Celsius, it's anatase phase formed. At 700 degrees Celsius, it's only rutile phase formed. And at temperatures in between, both the phases coexist. And as I mentioned earlier, at 450 degrees Celsius of annealing, the most effective photodegradation was observed. Now this is our SRD characteristics. We analyzed the structures of our crystalline TiO2 nanoparticles through XRD and verified the phases of our sample. Okay. So after preparing the TiO2 powders, 10 mg of the sample was added to a 10 ppm methyl orange solution and was kept under UV radiation. So the top right image shows this particular setup. In intervals of 1 hour, the photocatalytic degradation of the methyl orange was analyzed using the UV visible spectrometer. The bottom right image is our UV visible spectrometer, and in irradiation period of 3 hours, 83% of degradation of the methyl orange was seen. This was by far the most effective result obtained. So to conclude, the variation in pH and annealing temperature showed variation in the photodegradation results as well. Anatase TiO2 at pH 1 produced the optimum degradation of 83% in the period of 180 minutes. Okay. Though TiO2 is the best photocatalyst, it has certain drawbacks. Due to its wide band gap, light from only UV spectrum can be observed. So from this wide solar energy that we have, we can only absorb the UV spectrum using TiO2. So our future plan is to synthesize nitrogen doped TiO2 nanoparticles and correspondingly analyze the photodegradation. So we can see that by nitrogen doping, this drawbacks can be cancelled out, can be ruled out, and the most effective result can be obtained. So thank you everyone. It was indeed a great honor to be able to present our work on this esteemed forum. And my heartiest gratitude to the managing committee and the organizing committee. Thank you everyone and have a good day, and thank you for bearing with this technical issue. Though it was a little...
No, ma'am.
Yeah.
About the technical issue, I would like to say one line to you. That's a very famous line by Sohanlal Dwivedi or Harivansh Rai Bachchan, a poetry. You know, लहरों से डरकर नौका पार नहीं होती, कोशिश करने वालों की कभी हार नहीं होती. And this line completely fits you. The 11th hour problem you solve very instantly by adjusting a camera on the screen, and you completed your presentation. That's a sign of a best student, best researcher. To adjust or cope within a time, to adjust the situation, and that's a need of time, even a ongoing pandemic situation too. I am very thankful to you,
Yes, sir.
a research student like you being a part of our international conference. Thank you very much. Be a part of our other academic activities in coming days also. We will be in touch with you. Thank you very much once again.
Sure, sir. Sure. Thank you.
Now I move to the next participant, Vikas Kashyap, for oral presentation. Mr. Vikas Kashyap.
Am I audible?
Yes, sir. You are audible. Am I audible to you?
Yes, sir. Sure.
Please adjust your camera properly.
Yes, sir. Sure. Sir, any issue of voice?
No. You are both visible and audible.
Okay, sir. Okay, sir. Sir, can I present the by sharing the screen or
Yes,
on the laptop as I have done it?
Mr. Vikas, sir, you are a co-host, so you can control the screen and share the screen.
Oh, okay, right, sir. Sir, I will show it as the Tulika has already shown to you. Okay.
Yes. A very humble and kind request, unnecessary request. Please maintain the time 8+2.
Yeah, sir. Sure. So is it fine?
Yes.
Okay.
Reduplication of Tulika, but it's okay. Very good.
Okay. Firstly, thank you so much for giving me the opportunity for presenting my presentation. The topic of my presentation is the study of enhancement of optoelectronic properties with vertically aligned silicon nanowire from the Department of Physics, Punjab University, Chandigarh. And here is basically I have studied on the silicon topic. The outline of my talk is represented by the introduction method to be used and fabricated vertically aligned silicon nanowire and the applicative point of view of the silicon nanowire and what I have done till up to now. And at the last, I will conclude my topic. I will try it as earlier I can concluded it. Introduction part that there is a plenty of room at the bottom. So from the millimeter to the micrometer, as we move from micrometer range to nanometer range, physical laws and effects are different because of the quantum reason that comes into the picture. So there are change of properties in the nano domain. That properties are basically electronic properties, physical properties, chemical properties, which depend upon the quantum size effect, hardness, and structure reactivity, and the optical properties that is the main concern, that is nanostructure interact with the light. So we basically concentrate our research on this part. So advantages of going into that domain is the reduction of effective electronic path picture. Electrons can, and the disadvantages are also we have earlier keep into our mind before going to our research, that is a more complicated fabrication techniques are there and the higher fabrication cost involved in that. So at the nanoscale, we deal with the unusual properties, which are electron are confined, which leads to the quantum confinement effect, which occurs because of the delocalization of the electron. So large surface to volume ratio comes into the picture. That is because of the electron. Then the more disorder on the surface, then that of the bulk material it comes, and which leads to many properties like conductivity, absorption. I'm sorry for my absorption power and transmittance. So in the end, what is the about the material? The silicon is very abundant element. We mostly common found in the sand is silicon oxide. So silicon is restricted in the field of optically active material, the optoelectronics, due to its indirect energy band gap. Over the past decade, due to their unique physical properties and various applications ranging from electronic to biophysics, it has a huge impact. So we have concentrated on the porous silicon. So porous silicon is defined as a silicon having pores. It is a electrically semiconducting material. Porous silicon used for potential application in electronics and optoelectronics. It is also quoted in the nanoscale research letters. So the method we have chosen for making these vertically aligned silicon nanowire is its valuable properties, like due to the following reason. This is the simplest and cheapest method for the synthesis of the semiconductor nanostructures. All the procedure can be accomplished in a chemical lab without expensive equipments, and it is much more flexible and can be used to make higher surface to volume ratio structures. Crystalline quality of the silicon nanowire is generally high. The silicon nanowire is being made with the metal-assisted chemical etching. Then there is no obvious limitation on the size of the feature fabricated by the metal-assisted chemical etching. So therefore, because of these properties, we follow the MACE method, that is metal-assisted chemical etching. Therefore, metal-assisted chemical etching has become the increasingly important in the last decade. The most has utilized to fabricate various silicon and silicon germanium nanostructures. So experimental kit that is involved in this, that is so simpler as we can see into that only pipettes and spatula and two that cough syrup caps are involved into that. In these cup we have put that silicon wafer. After that etching process and the deposition process occurs. I will discuss it in the later part. So till up to now, the work we have done, that is we have fabricated it, and the FESM images we can see it simply. That is involving in the MACE method. There is first step is of etching, and first step is sorry, that is deposition, and the later subject later is etching process. In the etching part, we have time duration changes, that is the 30 minutes and 50 minutes. What the changes comes into the picture, we can clearly see in that. In the 30-minute, that is the first one picture. In the second one, that is 15-minute. So silicon nanowires correlation of etching time and photoelectronic data had been developed into that. So PL spectra in the 30 minutes etching time diminished peak of 425 nanometer is observed, and laterally on the 50 minutes the diminished peak of 435 nanometer is observed. So that is, we can say clearly, that is S1 sample which is of 30 minutes, and this is a later on sample that is of 50 minutes. PL spectra, we all know that as the wavelength falls into the sample, that the band gap, it shows that how much electrons are absorbing, at which wavelength they are absorbing. So within that we can get the electronic conductivity. Within that we can increase in that. So these things can be easily done into our part. So study of variation we have done with the Raman spectra also, which shows that the Raman spectra of these sample display a optical mode at 520 centimeter inverse that is shifted to a lower wave number with line shape broadening and asymmetry toward the lower wave number for sample S1 and S2. So these are the samples. Because of the COVID-19, I was not able to get that sample total data from the FSM our lab, but the clear picture of that desktop picture from the FSM machine that is showing on our desktop, I am showing that data is picture, the samples me. So application of vertically aligned silicon nanowires are to enhance the electronic efficiency in the direct band semiconductor which reached in nanoscale. Non-toxicity of the material help us to decorate other nanomaterial on it without any of using the biological sensing. Thing that toxicity also plays a major role in the biosensing also field. So these things are quite useful in our research. The high carrier mobility of the material opens a door for the major outcomes in the optical and electronic properties. Silicon nanowire opens its application in the field effect transistor, electrochemistry, in battery, in solar cell, in drug delivery, and in the sensing part. There is a well-established fabrication technique. The most simple method is available. We can see. So, in which part of the silicon nanowire we are totally focused upon? That is anti-flexion coating. By using the dimension through the nanostructure surfaces, developing high-efficient crystalline conductors, and identifying low-cost fabrication process, this research effort aims to open a new pathway for meeting anti-reflection coating-based cost target. It minimizes light reflection and improve light transmission over the entire solar spectrum. It maximizes the rate of solar to electric energy. Anti-reflection properties of the surface could be utilized in the electro-optical devices for defense services, photonics, microelectronics. So performance of the PV device fabricated using silicon could be improved by minimizing the reflectance loss using ARC. Surface anti-reflection technique shows stupendous impact on the optoelectronic devices such as solar cell, planar displays, cameras, light sensor. So we basically, our research should be that it can be work into that social reforms. So energy harvesting is the main key point on which we are concentrating ourselves. So solar power conversion loss of energy occurs due to the optical reflection that can be minimized by the anti-reflective application of silicon nanowire, shows by its black color. The conclusion part is that maze method is the best method for the fabrication of silicon nanostructure. There is a great impact of etching duration on the length of nanowire that increase with the increase in etching time. So most of our that participant may be understanding this deposition part and the etching part. Silicon nanowire's length that totally depends on its etching duration. We our wafer in that deposition some chemicals. There is a huge impact of silicon nanowire in the field of optoelectronics, like clearly variation can be seen with PL and Raman spectra. We have proceeded with particular application of silicon nanowire in anti-reflection coating, to which it will have influential impact on photovoltaics. So thank you so much.
Thank you, Dr. Saab. Thank you for your nice presentation and being a part of this international conference. Now I request the next participant, Dr. Amit Singh. Thank you. Dr. Amit sir, am I audible to you? पहले लॉग को लॉग आउट कराओ. Hello. Dr. Amit sir, am I audible to you? Dr. Amit sir.
Sir, am I audible, sir?
Am I audible to you? You are audible to us.
Yes, sir.
Okay.
You are audible, sir.
So heartily welcome on this international conference for your oral presentation. It's a humble and kind request to keep the time at +2 and you can begin your presentation now.
Thank you, sir. Thank you for giving me the opportunity to present my work. My work is on lanthanum fluoride matrix modified by dysprosium, and then the surface modification has been done by L-alanine so as to make the molecule water soluble. The outline of the talk will be the introduction, synthesis, structural, vibrational, and conclusion. Although I've done other characterization as well, along with publishing of the patent, applying for the patent, but today I will restrict myself to only synthesis, structural, and vibrational characterization. This is the abstract which I have submitted. Yeah, now why I have taken lanthanum fluoride? Now we want the material to be stable. Lanthanum fluoride matrix is one of the very stable matrix and on its own, and if it is doped with dysprosium, the stability increases. That has been observed by the structural, vibrational, thermal, and optical characteristic that we'll see. And L-aniline has been used to modify the outer surface of the lanthanum fluoride matrix doped with dysprosium. Now, what L-aniline does is that it the functional groups, the organic functional group get entangled, get stuck up on the surface of the lanthanum fluoride molecule, and they make it water soluble, which is our objective for its application point of view. Now, synthesis, we have done it from a wet chemical method. I will the brief write-up or the explanation will be like the nanocrystal has been synthesized by aqueous route with subsequent drying in a microwave oven. Water soluble chlorides like lanthanum, dysprosium were used for synthesis of nanocrystal. Solution of lanthanum chloride was prepared by dissolving. Then these are the there are the molar concentration that I'm not going into detail, but the reagents lanthanum, dysprosium, and L-aniline form one part, and ammonium fluoride form 3 part of the solution in the molar proportion 1:3. Now, in a 100 ml beaker, lanthanum chloride and dysprosium chloride are mixed in 1.5 ml, 1.5 ml amount and quantity, and then L-aniline is added swiftly, and then taking ammonium fluoride into it is injected. Now, due to this, what happens? White ultra white precipitate is formed. This white precipitate is dried in microwave oven, dried in distilled water, and then heated in microwave oven 3 to 4 times, so that the cleaning of the precipitate and the then we have a very clear powder form. Then the structural characterization has been done by XRD, SAME, TEM, IDAX, SAID. This is the XRD pattern. Now, from the XRD pattern, we observe that by the Debye-Scherer formula, the particle size is 21.61 nanometer for the 111 peak. The crystalline hexagonal structure of lanthanum fluoride has been verified by JCPDS card number 320483, having lattice parameters A, B equal to 7.112 Armstrong and C equals to 7.340 Armstrong, and the C by A ratio is 1.320. Then the same pattern particle size obtained is 23.43. Also, here we observe there is agglomeration. The agglomeration, we try to reduce this agglomeration by the microwave drying, but it is not very successful. Still, the molecules which are obtained, they can be used in practical purpose. Then we are having the TEM particle size obtained is 12.1226 nanometers, and the morphology obtained is nanorod. Then we are having the shade pattern. The shade pattern reflecting planes obtained for the JCPDS card 320483 is 110, 111, 113. Now, apart from that, 220, 221, 223, 410, and 330 are also there, which are not shown in this diagram. Then this is the IDAX profile. IDAX profile lists the presence of almost all the chemicals used except dysprosium. The problem is that dysprosium cannot be detected in IDAX profile. It can be for detection of dysprosium. I had used the ICP AES, that is inductively coupled plasma atomic electron spectroscopy technique to detect IDAX. There in IDAX, we don't get a graph. Directly the reading comes in the percentage. Now, then we are having the vibrational analysis. Vibrational analysis I have done with FTIR and FT Raman. Here are the graphs for FTIR and FT Raman. Now, I have listed all these things. I have tabulated with all these vibrations, and these vibrations are, as I've mentioned in my abstract, that is mu NH, mu carbon bond H, then mu asymmetric carbon bond H, then mu oxygen bond H, and etc. This is for FTIR, and for this is for FT Raman, and for FTIR it is nu NH, nu asymmetric H2O, nu CH, then delta H2O and delta H2. These are the vibrations which we have obtained. And briefly, I'll like to conclude. There are many things which I will tell after this. The particles synthesized are nanosized. The structural stability of nanoparticles are confirmed by XRD, SAME, TEM, SAID, and IDEX profiles. The surface modification of LAF3 dy nanoparticle by the organic functional groups are confirmed by FTIR and FT Raman analysis. The water solubility of L-alanine doped LAF3 dysprosium nanoparticle makes it suitable for biomedical applications. Now, these are the two papers which we are actually in the PhD coursework, we had synthesized around 10 molecules, of which 2 have been published like this over here. One is this for glycine functionalized LF3C and L-alanine capped LF3C. The present work which I have presented is for LF3DY, dysprosium, and I have got it published for cerium. Although the molecule category is same, but the observed behavior is quite different. So it makes them more applicable in various areas. And also we had filed 2 patents on this. Actually, I was under the impression that I have to present only part of the work. So the topic was suggested in this way. So that is all what I have to say. If anybody is having any questions, they can ask.
Thank you, Dr. Saheb. Thank you, Dr. Amit, for nice presentation. And we expect and we give a best of luck for the recognition of your patent. And we hope it so. Your quality research will definitely do the recognition to your patent. Best of luck from our team. Thank you. Thank you very much.
Thanks a lot.
Now, I move for the next presentation. I request to the next oral presentation for Dr. Madhuja Katkar.
Yes, sir.
त्यांना कोर्स केला ते काय येते
Sir, is the screen visible?
Am I audible to you?
Yes, sir.
So you are both audible and visible to us, and you have started your screen sharing too. It's a humble request. Please, let's begin your presentation within the stepping time of 10 minutes.
Yes, sir. Should I start?
Yes.
Yeah. Good afternoon, one and all. I am Madhuja Katkar from Institute of Chemical Technology, Mumbai. And my topic for discussion will be nanotechnology in surfacing. So let us start. Let us think of the tiniest particle or tiniest thing in our body, that is cell, blood cell, which is very, very minute or which is very, very small. But there are things which are much smaller than even the blood cell. That is, those particles are known as nano. The size range for nano particles are 1 to 100 nanometers. So Richard Feynman, he is known as father of nanotechnology. He stated once that there's plenty room at the bottom. That means there's a lot of space or there's a lot of area for researching. Like as we go down, as we jot down particles to its maximum smallest particle, there's a lot of space for us to research. He is a recipient of Nobel Prize in Physics in 1965. So why do we need nanotechnology? Previously, stains were acceptable. Wet shoes in the rainy season were acceptable. The growth of microbial on clothing or any other surfaces were acceptable. But as we advance in the technology, we need materials which were self-cleaning. They show super hydrophobicity, and also they were also they show antimicrobial property. And all this is possible because of the nanotechnology, the development in nanotechnology. So nanotechnology in day-to-day life, nanotechnology is not just limited to outdoors or indoors. It is applicable everywhere, like in food and food processing, in cosmetics, may it be defense. It's applicable everywhere. Concept of nanotechnology. What is a nanometer? A nanometer is 1/1000th of a meter. Like we can't even imagine how small a nanometer or a nanoparticle can be. Nanotechnology is basically the study of a material to its atomic or molecular scale. There are two approaches towards nanotechnology: top to bottom approach and bottom to top approach. Like in the first approach, that is top to bottom approach, milling, emulsion, homogenization are the techniques used for going from top to bottom. For vice versa, like from going from bottom to top, polymerization, precipitation, these methods can be used, like from converting from atoms to clusters, and the same goes with the other one. So nanotechnology in textiles. The nano effects can be given in nanotextiles, like
making smart textiles, for making textiles which are antibacterial, for making them stain repellent, and many other aspects can be cleared with the use of nanotechnology. How do we come material? Layer on the nanometer scale. So there are various methods or various technique coating surfaces. First one is sol gel method, cross-linking method, thin film deposition technique, nanofiber coating via electrospinning. Let's see the first one, that is sol gel method. Excuse me. In the sol gel method, the sol is prepared by inorganic colloidal, organic colloidal suspension, and when it goes in continuous liquid form, like it undergoes gelish, what we get is a gel form, and then we can coat it by dip coating, spin coating, electrodiffusion, etc. So drying can be done, like air drying can be done, simple curing is possible. Next method, that is cross-linking method. In cross-linking method, hydrophobic interaction and cilian filling by silica is done. The next technique, that is thin deposition technique. Thin deposition technique can be carried out by vacuum evaporation, ion implantation, and splinter coat. Like you can see here, I have taken the example of textile technically in surface technique. Like application of the nanotechnology in surface. Super UV protection, antibacterial, anti-static properties, wrinkles. All these applications are possible if we put a surface nano.
नाही आवाज गेला बरं सगळा.
Hello.
Sir, ma'am, you are audible. Hello.
Okay.
No, you are audible. Please continue.
Yeah. Hello.
You are audible. Please continue.
Okay.
You are sharing the screen. We are seeing your PPTs. Please continue.
Okay, so I'll start from here. That is application. There are version of anti UV protection, and electromagnetic shielding. So first one, that is super hydrophobicity. Super hydrophobicity is generally observed in nature lotus leaves. It can be encountered by adding the sun particles, and hence we can have dry even these. The next application, that is UV protection. We can use AI to particle for the same purpose. Antibacterial. Nanosilver is something which for antiviral properties. It directly attacks DNA and stops its replication, and hence it's
परत बंद झालं.
hello. Sir, should I continue?
Yes, continue, madam. Continue.
Hello, sir.
Hello, madam. Continue.
Yes. Okay. So anti-static properties can be indulged by adding of Zn oxide in the material. Next, that is electromagnetic shielding. These can be incorporated in the coating by addition of indium tin oxide nanoparticles. So I would like to end by saying enormous potential in the field of nano. There's an enormous potential in the field of nanotechnology. Obviously, huge gaps in knowledge concerning the possible risks, uh, difficulty in detecting and removing the nanoparticles, absence of regulation about the nanotechnology, and adverse health effects in human from deliberate or accidental exposures. Obviously, these particles are even smaller than the human cell, and hence they can have adverse health effects on the human cells as well. And also, further research is obviously required for the same. Thank you.
Hello,
Hello.
ma'am. Hello, ma'am.
Yeah, I'm done, sir.
Please make the
Yes,
concluding
sir.
remarks.
I concluded.
Okay, okay. I have concluded. Okay, sorry. Ma'am,
Yes,
thanks
sir.
for.
You want me to conclude once again?
Yes, yes, yes. We conclusion the increasing interest concern about nanotechnology is mainly because of. Okay, we have got it. Thank you, ma'am. Thanks for nice presentation.
Okay.
On behalf of the
Yes,
organizing
sir.
committee, I am thankful to you being a part of this international conference. Thank you very much.
Thank you, sir.
Now I request the next participant for the oral presentation. Sagar More, na? Sagar More. Hello. Sir, please unmute yourself. Mr. Sagar More. Mr. Sagar More, am I audible to you? Mr. Sagar. Mr. Sagar, sir. Hello. Hello, Mr. Sagar. Hello, Mr. Sagar, sir. Mr. Sagar. Please unmute yourself. मोबाईलचं नाव कोणाचं एखादं काही तो सुरू होता लॉगिन करून हां काहीच नाही ना कम्युनिकेशनच नाही नेक्स्ट कोण Hello, Mr. Sagar.
Tarannum ma'am. सागर आला का?
Hello, sir. बोलिए.
हाँ, am I audible, ma'am?
Yes, sir. Yes, sir.
So already you have made a very best presentation, better presentation.
Thank you very much.
The conference is over with the 10 presentations and with so many technical session.
Yes,
Now it's a time for feedback. So would you like to have a feedback for this conference?
Yes, sir.
Now it's a humble request to please go over for your kind feedback for
Yes,
the
sir.
conference.
Okay, sir. Respected chief patrons, management members, resource persons, conveners of this e-conference, and all the participants, good afternoon once again to one and all. On behalf of all the participants, it's my privilege to express a deep sense of gratitude to the organizing team of Vasantrao Naik College for the successful conduct of this one-day international e-conference on ethical and quality aspects in nanoscience and nanotechnology research. I must congratulate them, especially the convener Bagul sir and IQSC coordinator R.D. Patil sir for the grand success of this conference. The theme of the conference was very interesting. All the technical sessions were highly informative. Discussions were very fruitful. And I hope that the information provided in this e-conference on nanomaterials, nanotechnology, and their applications will be definitely beneficial for us in our future research work. Thank you very much, sir.
Thank you, ma'am. Thank you very much.
Thank you, sir. Thank you for giving
Thank
me
you.
this opportunity, sir.
Okay, thank you very much. मोरे आएगा तो हाँ हा कोण आहे ना हो सर पाच वाटतंय हाँ मोरे hello Mr. Sagar More, please unmute yourself. सागर मोरे नहीं मग आवाज नाही येते unmute होतो. Hello. हाँ Mr. Amit Singh, am I audible?
Yes, sir.
So, would you like to go for feedback for this conference? Hello.
Yes, sir.
So, please have your kind feedback for us.
Hello. Yes, sir. Pardon, sir.
Yes.
Yes, sir.
Please go on for your kind feedback for us.
Yeah. Thank you, sir. Thank you for giving me the opportunity. And it was really a nice initiative in this time wherein we are unable to meet physically. And in this time, collecting so many scholars on one platform, including all the activities which a conference are expected to do. Like there have been various webinars, but the participants were not being given opportunity to present their works. But this is one of the single conference which I have attended in these days, in these apart from the many webinars which I have attended, wherein the participants have been given opportunity to present their works to the audience. So this, I think, is the highlight of this webinar conference over here. The topic selected were from varied field. The scholars were from varied field. So collecting all such people in itself is a big task. And I really congratulate the organizers for taking so much effort in these testing times to collect such such group of people. And especially on the organizers part, I found it very encouraging that all the things have been going on in a pre-planned, systematic, timely way, and wherein if it was required by a participant or by a expert to increase his or her time, the participant, the organizer readily agreed for that, without caring about much more about the protocols. So which is again a very good thing for scientific conferences. So I'm really thankful to the organizers for taking their time out, because it would have taken lots of time on their part also to prepare for such a international conference, a virtual conference. So I really thank them, and especially Bagul sir, who who guided us to be part of this conference. And I wish all the very best to the organizing team, and hope they will pursue further such endeavors and make us part of this their future endeavors. Thank you, sir.
Thank you, Dr. Amit, sir. Thank you for kind feedback. And I again pay my special thanks to you on behalf of the all organizing committee, management, principal of the Vasantrao Naik College for your kind and nice feedback for us. Thank you very much. We hope we will be a part and parcel of this higher education initiative in coming days too. Thank you very much.
Thank you, sir. Thank you.
Now, I invite Madhuja for a feedback.
Yes, sir.
Miss Madhuja, am I audible?
Uh, yes, sir. Yes, you are audible.
So, please have your kind words, kind feedback for us.
Yes, sir. Thanks to your college for arranging such a wonderful platform. It was a great experience in this lockdown period. It was really a great initiative from your side. And all the conveners and co-conveners were also quite cooperative. And if further in future we get opportunity to do the same, and we obviously would be interested to be a part of this again.
Thank you. Thank you very much, Madhuja ji, for your kind word for us. Surely, in coming days, in next moment, next attempt, we will try to be more friendly and more better with all the arrangements with you. Thank you very much for your kind words. Now, as the conference has begun early in the morning at 10 a.m. and it's still going on. It held an inaugural function at the beginning. Thereafter, 4 scholarly technical sessions with the high academic scholars. Then we have 10 oral presentation from different parts of the country as well as from abroad, South Africa, where the oral paper presenters share their experiences, share their papers, and share their knowledge with us in the conference. Then we have a feedback of some of the participants, registered participants, where they have very kind word for the organization of this conference. Dear participants and the all honorable dignitaries associated with this conference, I myself, Santosh Kumar Patil, co-convener and coordinator IQAC, is very thankful to all of you. You know, as it's a time for the valedictory function of this conference. For this valedictory function, we have a very reputed guest and chief guests and higher dignitaries to be present over here. We have Professor Bhaiya Sahib Sanjayji Jadhav, who is working as a professor in the Department of Geology in our college and working in the capacity of Divisional Secretary of Satpura Shikshan Prasarak Mandal Vidyawadi Dhule. It's our grand pleasure that he is in both a role of management as well as a teacher, as an innovative teacher and he always has the innovative ideas in his mind. He prompts us, he guides us like a lighthouse for the some time to conduct on more and more academic activities. I will not to hesitate to say that the today's conference is an outcome of his motivation for us. This international conference and earlier our college has held two national workshop and in conference all are the outcome of the our Bhaiya Sahib. Bhaiya Sahib, I am welcome you and thanks for the being a part of the validatory function. For validatory function, we have another chief guest. So Varshatai Jadhav, Secretary Sonamai Shikshan Prasarak Mandal Vidyavali Dhude. She is a constant spirit of motivation for all the employees of this campus. The campus, which itself is an educational hub, where a student enroll in the standard 1 could be out with a graduation in science and arts. It's a educational gurukul, educational Vidya Mandir. And so Varshatai Jadhav is a secretary of Mahila College in the same campus. Welcome Didi, very very welcome. Then we have our lovely principal, academic administrator, Dr. A.M. Patil sir, being a part of this validatory function. Hmm? I welcome all the chief guests for this validatory function. हे दोन नावं कुठे आहेत? Before to proceed for the validatory function, dear participants, I would like to announce that. Huh? I would like to say that the validatory function is now start. Now I request the chief guest of this validatory function, Honorable Bhaiya Sahib Jadhav, to have your validatory speech of this function. Over to Bhaiya Sahib Jadhav for presidential speech of the validatory function.
Hello.
Yes, Bhaiya Sahib, you are audible.
Audible, videoable.
Yes, you are visible and audible.
Yes. Today's international conference on ethical quality aspects in nanoscience and nanotechnology research was very enthusiastically completed. For this conference, all our intellectual experts, resource person, Dr. Shir Sagar and Dr. Devan from Indian Institute of Technology, Indore, Dr. Ghosh from Haryana, and Dr. Deshpande from South Korea gives very precious and highly informative and brilliant talk with PPT in all the session that focus on new techniques and ideas. It will definitely knowledgeable and useful to promote the vision of researchers. This international conference was organized with the blessing of our founder president, Honorable Karmasakshi Nana Sahib Premchandji Jadhav, and Vice President Bharat Jyoti, Honorable I Sahib Jadhav, and also well-wishers, our Honorable Secretary, Advocate Appa Sahib Sudhir Kumar Jadhav, and Honorable Director Ismail Chacha, and all the body members. I am very grateful to KBC North Maharashtra University for giving the permission to collaborate conference with VN College Shahada. I am also thankful to all the chief patron, Pro Vice Chancellor Dr. Mahulikar sir and Honorable Dr. Joint Director Satish Pandeji for giving the welcome message and encourage us. During valediction, I congratulate the organizing committee, Principal Dr. A.N. Patil convener Professor Bagul sir, co-convener Dr. S.M. Patil, Dr. R.B. Marathe for successful organization of the workshop, e-seminar and e-conference. I strongly congratulate to our hard-working technical support, Professor Ishi, Professor R.P. Patil, Mr. Himanshu Jadhav, Mr. Rajesh Rathod, and Mr. Swapnil Kulkarni. I also thankful to participant to submit the abstract with the paper presentation. Nowadays, to organize the online activity is the essential need of time. And in future, sometimes the educational study can be possible online process. I think for this point of view, online attempt is one of the proper way to study. So once again, for organization of the e-conference, workshop and e-seminar, I am thankful to all of you. Good luck and have a nice day. Thank you.
Thank you, Bhaiya Sahib. Actually, I do not hesitate to say that this conference or any other activity that happens in this campus, whether it is academic or non-academic, it is just because of the moral guidance and technical guidance and the timely guidance of you. All the other activities that emerge from your brain and pen, and we try to give a hard shape to them. Today's international conference was just because of your kind guidance, your motivation, not a motivation, but your constant motivation to us, which prompted us to arrange such type of academic activities. On behalf of the organizing committee of Vasantrao Naik College, I assure that the same motive, same initiative will continue in coming days to fulfill the goals which has been seen and founded by the President Honorable Karma Sakshi Nana Sahib Jadhav to enhance the campus credibility, morality, ethics and quality. All these are part of this campus. So I again thanks Bhaiya Sahib Jadhav. Actually, we miss our Didi who has a indirect and direct constant source of inspiration for us. I hope her blessing is always with us. Without her kind blessing and words, we could not proceed further for any other activities. Thank you, Honorable Bhaiya Sahib Jadhav and Honorable Didi and all the patrons of the Management Trustee of Satpura Shikshan Prasarak Mandal. Bhaiya Sahib, thanks once again. Now it's a time to move as every event has an architect. So I would like to say that in today's event, the main architect, the pillar of this organization was our academic lovely principal, Dr. A.N. Patil sir, who is the president of today's valedictory function. I request Principal Dr. A.N. Patil to have a brief presidential message on the valedictory function of this international in conference of ethics and quality in nanoscience and nanotechnology research. Over to Principal Dr. A.N. Patil, sir.
Very good evening, Honorable Chief Patron, who are being a part of this international e-conference, jointly organized by ABC, NMU, and Vasantrao Naik College, Shahada. I am very happy to say that our parent university granted permission only because of trust of maintaining quality and ethics by our college. We organized a galaxy of academicians and administrators who enlightened various participants of e-conference by their knowledge. The e-conference had resource persons from abroad It is really international by content, quality, and by other means. I think that this conference may be first kind of international conference where resource are being observed. We allow 10 participants to present the research paper. It is two-way communication conference. The whole credit goes to my management, organization committee, technical committee, and many others. I'm very thankful to kind support of management. It gives me immense pleasure and congratulates to declare three best paper presenter from who have presently. It is very difficult for our judge to select three best papers because all papers are quality paper presented from all over the world. It is a teamwork, and now I announce these three top presenter. The first one, congratulations, Dr. Pramod Kumar. Secondly, congratulations to Mr. Kaushik Kumar Shukla. And third, congratulations to Tiluka Sina. Thank you very much. Thank you for our judge, Dr. Gosavi sir, Kaloda and Dr. Jagtap sir from Shahada. Thank you.
Thank you, Honorable Principal Dr. N. Patil sir. On this valedictory function, everything has been said by the main guest, Honorable Bhaiya Sahib Jadhav. But at the concluding time, I would like to say that in last 3 months, because of the COVID pandemic, where manual meeting is prohibited, where we can meet only online, so many academic activities, conferences, webinars, e-webinars, seminars, various e-activities are going on. It was a very kind wish and very hard urge of our Honorable Bhaiya Sahib Jadhav to urge the same activity in our campus. Many campuses are doing a very formal one. I also become a part of those various conferences, webinars and seminars. But I am very happy and glad to say that this is the first type of conferences where the resource person from India and abroad share their knowledge, share their talk completely relevant with the topic of the conference. This is the first kind of conference where the paper presenters were allowed to participate. It was a dual channel conference. It was a two-way communication. It was not a one-way communication where a speaker comes, delivers a lecture, the attendee listen it and forget it. No, it was a two-way communication. It was the first type communication where the selection committee had been appointed by honorable principal of academician resource person to select the best presenter so can they motivate in coming days for the best result. It was the first type of conference where not only academic persons, teachers, but the various stakeholders, I would like to say that there were two students from different parts of India, Tamil Nadu, India, where they showed their research. This all is only because of the constant motivation, spirit, and urge to maintain the quality ethics in every field of management of Satpura Shikshan Prasarak Mandal. I am very thankful to all of you. It's from my own part, but it will be incomplete if the whole vote of thanks will not be mentioned by the convener or the appointee. Therefore, for a formal vote of thanks, now I invite Head of the Department of Zoology, Professor Ravindra Patil, to have a vote of thanks of this conference. I again say that it is not an end, it's a beginning. It's not the ending of the responsibility, but it's of the sharing of the responsibility. So I invite Professor Dr. Ravindra Patil for a vote of thanks of this conference. Over to Professor R.D. Patil, sir.
Thank you, sir. Good afternoon to all. I, Dr. Ravindra Patil, Head of Department of Zoology. I take this opportunity to express my vote of thanks, concluding part of the World International Conference on ethical and quality aspects in nanoscience and nanotechnology research, IGNA to Sub 2020. In the beginning, I sincerely thanks to our patrons, Honorable Karma Sakshi Nana Sir Premchand Jadhav, Founder President Satpura Shikshan Prasad Mandal Dhule, Honorable Bharat Jyoti Savashate Premchand Jadhav, President Sonamai Shikshan Prasad Mandal Dhule, Honorable Advocate Appa Sahib Sudhirji Premchand Jadhav, Secretary Satpura Shikshan Prasad Mandal Vidyavadi Dhule, Honorable Professor P. Patil, Vice Chancellor Kavitri Bainabai Chaudhary North University, Jalgaon, Honorable Professor Bhaiya Sahib Sanjay Ji Jadhav, Divisional Secretary of SSP Mandal, Dhule, Honorable Sau Pratimatai S. Jadhav, Vice President Sonamai Shikshan Prasad Mandal Dhule, Honorable Sau Varshatai S. Jadhav, Secretary Sonamai Shikshan Prasad Mandal Dhule, Honorable Sri Ismail Mansuri, Member of Shikshan Prasad Mandal Dhule, the dynamic leadership of these dignitaries and their encouragement and excellent support has given us a great strength for this conference. I would also like to thank patrons Honorable Professor P.P. Maulikar, Pro Vice Chancellor KB CNB Jalgaon, Honorable Dr. Satish M. Deshpande, Joint Director Higher Education Jalgaon. Also, I am to thank Honorable P.V. Pawar, Registrar KB CNB Jalgaon for kindly accepting our invitation and gracing the inaugural functions. I also thanks our principal Dr. N. Patil sir also his able guidance and always encouraged us. I would especially like to mention that in this situation of pandemic when we cannot have mass gathering, words of speakers through together several people not under the proof, under spirit of science. I must mention our deep sense of appreciation for today's speakers, Honorable Dr. Vishad Ji Deshpande, Advanced Material Science and Engineering, Sukan University, Swan, South Korea, for giving an excellent coverage to his speech on what makes nanomaterials important. Honorable Dr. Rupesh S. Diwan, Discipline of Meteorology Engineering and Material Science, Indian Institute of Technology, Indore, for his explanation, ethics in research publication. Honorable Dr. Umesh A. Srisagar, Discipline of Chemistry, Indian Institute of Technology, Indore, for his effort towards modern photochemistry, a way towards green organic synthesis. And Honorable Dr. Arindam Ghosh, JTC Memorial College, Bahal, Bidwani, Haryana, for sharing their valuable guidance on nanotechnology. Proof in a keynote address, ST Bendre, BO Chairman, KBCNM Jalgaon, for physics, sharing their valuable speech on materials aspects of green energy issues. I also wish to express my deep gratitude National Advisory Committee members, Dr. A. Sinha, Directors, UGC DAECS Indore, Dr. Devdatta Phais, Center Director, UGC DAECSR Indore, Dr. L. A. Patil, Nano Scientist Amaler, from M.A. More, Savitribai Phule University Pune, S.T. Bendre, BOS Chairman, KB Senvi Jalgaon, Principal Dr. D.R. Patil, former Dean KB Senvi Jalgaon, Dr. J.V. Sali, KB CNMU Jalgaon, Principal Dr. Harish Patil, Member of Senate, KB CNMU Jalgaon, Dr. S.R. Goswami, Member of Senate and Board of Research, KB Cinema Jalgaon, Dr. P.S. Sonone Pratap Farid Amaler, Dr. S.S. Sonone, Member of Senate, KB Cinema Jalgaon, Dr. Sasikan B. Jedam, MD College, Armori, East Gadchurli, Dr. K.G. Kolle, Member of Senate, KB Cinema Jalgaon, Dr. R.S. Rad, Board of Member of Physics, KB Cinema Jalgaon, Dr. E.G. Nete, Member of Senate, KB Cinema Jalgaon, Dr. P.B. Airo, Member of Senate, KB Cinema Jalgaon, and Principal Dr. R.R. Aire, I am member of BOS KB Civil Jalgaon. How can I conclude the program without expressing my deepest thanks towards all the participants? You all have been greatest motivators of our entire team. It is your participation that motivates us and keeps our enthusiasm high. I also pay special thanks to paper presenters and feedback participants. I congratulate and thanks to three best paper presenters. I also thanks the examiners of Dr. Goswami SR, ASC College from Tohoda, and Dr. Jagtap, PP, PhD UPS College, Shahada, also great to examine the best paper presenters in this conference. I thank our principal, Dr. N. Patil sir, for ample support for the international conference. My wholehearted thanks to convener, Professor P.Y. Babul, co-convener, Dr. S.M. Patil, IPAC coordinator, organizing and technical committee, Dr. R.B. Marathe, Dr. R.R. Solne, Professor S.S.E.C., Professor R.P. Patil, Mr. Imanshu Jadhav, and Mr. V.D. Jadhav. I thank all the teaching and non-teaching staff who worked hard and made this international conference worth feeling privileged to be a part of this. Last but not least, I thank everyone for your cooperation in making this one-day international conference and echoing success. I respect and believe that this international conference shall have made very relevant and fruitful outcomes of the expected results. The conference might have bring out many issues of nanotechnology. Now, with the prior permission of Chief Guest, I hereby declare that international conference is successfully over. Thank you. Stay home, stay safe.